All right, so let's get started with lesson number 7. Lesson number 7. It's a good one too, not terribly complex, but it's all right. All right, so this one is all about implementing authentication controls, right? Or what we would normally call it AAA. Some people call this AAA. Hey, trust me, this is not the company that do towing. You guys know the AAA company? And recently we have been calling this thing IAAA, I quadruple A, right? And really what this is the identification, authentication, authorization, accounting, and auditing. That's really what this is, which is like stupid because these two really mean the same thing, the last two. Accounting and auditing, it's the same thing. So I want you to go back to this guy right here, authentication, authorization, and accounting. Basically, we want to authenticate somebody. Once they're already authenticated, basically this is asking, hey, who are you? This is my username, this is my password. And after that, we want to be able to authorize you. Even though you say your name is Shayla, that does not mean you're supposed to have access to everything. What are you authorized to do, right? That's what the authorization part comes in. And now after we've authorized you, we have to keep track of everything that you're doing. I usually tell people computers snitch, right? Like everything you do on your computers, it keeps logging everything that you're doing. So you can use a computer and be like, hey, I guess they didn't see this. No, there's a way to bring all that stuff back and be able to see what you did. So that's the accounting, right? Or the auditing side of things. So that's really what this whole chapter is all about. We will talk about that and more. We'll talk about the technology that we use to do those sort of things, and more. But before we do that, I have a pop quiz for you.
A security engineer has enabled two-factor authentication on all workstations. Which of the following approaches are the most secure? Choose two. Most secure. I'm gonna go with password and one-time token.
Password, and if you're looking for biometrics, fingerprint.
Yeah, I was going to say password and fingerprint as well.
Okay.
Voice.
So give me another one.
I'll say password and voice.
Password and voice.
Yeah, I'm going to double up on that password and voice too for the second one.
Okay.
Same here, because your voice can change.
Okay.
I'm gonna go with smart card.
Smart card. Okay. Password and smart card. What is two-factor authentication? Two-FA. Usually people call this two-FA or MFA, multi-factor authentication, right? What does it mean?
It's
Kind of two ways to identify the user.
The way to identify the user. I'll take that. I'll take that explanation. That's all right. All right, let's see the answers. Boom. Password and smart card and password and fingerprint. Right? And allow me to explain. Whenever we're talking about MFA or 2FA, guys, look, there are different categories. There is the something you know, something you have, someone you are, and so on and so forth. So password will be the something you know. Everybody agrees. Knowledge, you know your password. Smart card will be something that you have at hand. Then a fingerprint will be someone you are. So whenever they say the most secure, because I understand that you guys say password and voice, but voice is what? It's biometric. It's just like smart card. Voice is also biometric. It's someone you are, right? And one-time token, this wasn't an okay choice, but this is not as secure as the smart cards. This is also something you have, right? Something you have at hand, and so on and so forth. But this give out all three instead of just this guy and this guy, which give us just two. Something you know and someone you are. See how they try to trick you? Yeah. All right. You'll see a lot of that in this. 2.4 from that exam objective is what we're talking about. Stuff right in. So identity and access management. This is actually a huge topic that you can specialize in. IAM, identity and access management. Basically, your job is to basically look at access management, like managing who has access to what. Basically, provisioning users, removing users, all that good stuff. That's what these people actually do and more. But, I'm just kind of giving you the basics. So if you're going to be identifying people, you need to know who and what you're identifying them to. So the subject is the user, the software that needs the access. The object is the resources that the subject need access to. So it could be the network, the servers, the data. That's the subject. So that's the object, Subject needs access to objects. These are like sort of like Microsoft terminologies here. I hate them, I don't like them, but they're here. So I don't think this is that important for the sake of the exam. What's important, however, it's what is following. This will pop up on that exam. If you're going to be accessing management, if you're going to be granting people access and removing their access, you need to know who they are first. Identification. Right? Identification, associating a valid subject with a computer or a network account. Identification really, it's in the name. It's identity, who you are. So think of this as the username. In a case of a computer systems, identification is your username. But here's something that you need to remember. Well, anybody can say, this is me, this is my username. So imagine if Michael's username is Michael. I can show up and just say, hey, I am also Michael. Right? Who is going to argue with me? No one, right? So we have to challenge the identity. So if you just show up and say, okay, my username is Michael, like, okay, we got it. But how do we know you are the Michael? Or how do we know which Michael you are? So that's where the authentication comes in. This is the challenging the identity. This is the password. There we go. This is a username. This is our username. And this right here is the password. I'm specifically differentiating this because you need to do that for that exam. The identity is something that identifies who you are. And the authentication, it's usually the challenge to the identity. And usually we talk about this interchangeably. When people are saying authentication, you say, okay, or it's my username and password, but they're two different things, right? And then once you've authenticated, once we've challenged your identity, we have to authorize you into what you're doing. Authorization, these are the permissions, right? And permissions that's given to you, right? After we know who you are. That's the authorization. I usually give out the example of, if you show up to my house right now, I don't know you, but you show up to my house. You knock on the door, like a gang, 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 gang. Then I'm like, who are you? You say, I'm Shayla. I'm like, okay, that's your identity. You just say you're Shayla. Anybody can say they're Shayla. So I might ask you, how do I know you are the Shayla? Well, you might show me your driver's license, right, Shayla? I never met you. I don't know who you are. You show me your driver's license. Your driver's license have the picture. So I can basically do the authentication. Be like, oh, okay, yeah, you are Shayla. Then I can welcome you to my house. But does that mean you have access to my refrigerator? No. That does not mean you have access to my bedroom. That does not mean you have access to my bathroom, right? So you are not authorized to do any of that stuff in my house as my guest. You could sit down and watch some TV. That's maybe what you're authorized to do, but that's about it, right? So if you want to go to the restrooms, you're probably going to be like, hey, where is the restroom? Right? You can ask me. So that's the rights, that's the permission, the authorization. And then now the accounting. Okay, accounting is literally keeping track of what you're doing. You already in my house now, are you just looking everywhere and just walking around and just doing what you're supposed to be doing? Accounting, it's keeping track of what people are doing. We usually call this auditing. Computers keep track of everything that you're doing, and that's known as accounting. So these three are very critical for us to be able to do the right identity and access management. Very important. And I'll remember those for the exam. So let's start with the authentication factor, right? We can authenticate people based on something they know, something you know. This is known as a knowledge factor. Could be username. Yeah, username is something you know. Password is something you know. A PIN is something you know. Like a swipe patterns is something you know. A challenged question. What's your favorite color? All these things are something you know, right? It could be something you have. It could be something you do. Something you have is something you have at hand. It could be like a key fob. Anybody here have had one of those RSA key fobs? Yes, that works for the government. You probably have. Yeah, definitely. So that's something you have at hand. Nowadays, we use smartphones. You know, within the smartphone, you will have the authenticator. Who's here have heard about the Google Authenticator or Microsoft authenticators? Yeah, right. You try to authenticate, they send you some kind of a code in your phone. Maybe it's an SMS. Maybe SMS is not the most secure. We'll talk about that. You probably don't want to use that thing. Anyway, but if you have like a Google Authenticator or Microsoft Authenticator where there's the one-time key that keep changing every 30 seconds, well, that's something you have at hand. Something you are or someone you are. That's the biometric factor. This is the facial recognition, the fingerprinting, the retina scan, the voice, all that stuff. Biometric, right? So I have a tricky question for you. Because CompTIA usually asks this question. So let's say that you're trying to authenticate into a system. Then that system asks you, what is your username? Then you say, this is my username. The system also asks you, what is your password? You say, hey, here's my password. Then the system asks you, what is your mother's maiden name, right? You provide that. Then they ask you, okay, now what is your PIN, for example? You provide that. All right, so is that multi-factor authentication?
I would say no.
Right, Shayla? No. Why?
Because if you miss the something you are or something you do.
Love it. And that's a very tricky question that usually gets a lot of students. And you're right. Everything is the knowledge here. Everything came from your brain. The username, the password, the PIN, the challenged question, all that stuff is the stuff you know. So in that exam, don't let CompTIA trick you into questions like that. For something to be multi-factor authentication, it has to come from two different factors, have to come from these two different categories. Right? Thank you, Shayla. That was good. Great, let's get going. So again, whenever we're doing the authentication, it has to meet the confidentiality, integrity, availability. We're not going to talk about those because we did. We did that already. What we need to talk about is multi-factor authentication. And I just asked you a question that set you up to this conversation. So if you are working for a company and the company doesn't do multi-factor authentication now, once you took Security Plus, go tell them we need to do multi-factor authentication now. like right this minute. Because with all the attack that have happened, guys, pretty much everybody's passwords, everybody's hashes, it's in the dark web somewhere. Hackers can easily get a hash of your password easily. There is this actually, we will talk about this as well, but there's this website, it's known.
I can't hear you.
Oh boy. All right. Did you hear about Crack Station though? No, all right. Well, it's not coming up too, so I need to clear my cookies. Let me go to Edge, crackstation.net. Come on. All right, let me go settings. Reset. Let's go and reset you. Settings were reset. All right, did you reset everything? Privacy. All right, well, let me try again. Okay, well, I give up. I don't know why the website is not coming up. But this was Crack Station. I'm gonna put this in the chat so you can take a look at it and sort of like play around with it. But this thing has over billions of cracked passwords. And let's say cracked passwords, I'm talking about legit passwords. These are the same passwords that people use in their systems. A majority of the company have already been hacked. The Google have been, not really Google, but the Adobe have been hacked. The Equifax, all these companies have been hacked, and then hackers have a database of your password somewhere. So using just a username and password is no longer secure enough, especially if you are using like a very simple password, right? That's like computers of nowadays can crack like a regular password in like no time, in like minutes. We're going to talk about a tool known as Hashcat. I'm probably going to demonstrate this one for you to show you how easy it is to crack password. And this thing is insanely fast to crack passwords. So again, I brought this up to tell you that if you are just using passwords for your work, you need to let them know we got to do multi-factor now. Even in your personal life, you need to get comfortable with this, right? So this is the strong authentication requirements, which requires 2. Knowledge factor is the weakest link, but it's the most common. The things you know, username and passwords. So we need to get comfortable with MFA. This is a multi-factor authentication. And I want you to understand the difference between 2FA and the MFA. MFA meaning it can be more than 2. That's what that means. We can use like all 3 or 4. We can use more than just 2. But 2FA simply means either you're doing something you know, something you have, or something you have and something you know. You just from those 2 categories. Right? That's 2FA. I'm using my username and then they're sending a code into my phone. That's 2FA. But if they're doing this and then they're asking me for me to scan my fingerprint, that's multi-factor authentication. That's more than 2, because they're using something you know, something you have, and something you are. Yeah. Going. There are different attributes of the authentication. We can authenticate you based on where you are, right? This is the location based. And I think Shayla just raised your hand. Please go ahead before I move forward.
Yes, the question would be, what else could be used for something you do in place of biometrics?
Something you do in place of biometrics.
And reason I'm asking is because now you see a lot of biometric authentication, like fingerprints, retina scans, palm scans.
Mhm.
So what else could be used instead of that?
Yeah, well, I'll tell you, but really, there's a reason why companies didn't use biometric a lot until Apple started implementing facial recognition and stuff. Until the technology became more mainstream. One reason, Shayla, is because it's extremely expensive to do biometric, very expensive, and there's a lot of false positive and false negatives. We're going to talk about those as well. But for your question of what else can we do? Oh my God, we can do like anything that is unique about you. We can use that as a way of authenticating you. So the way you talk, the way you walk. In fact, this one is known as a gait analysis, where we can authenticate you based on the way you walk. Apparently, there is uniqueness in the way people walk. So we can authenticate you based on that. We can authenticate you based on your voice. We can authenticate you based on, retina scan. You mentioned right now. In one word, it's literally anything unique about you. We can authenticate you based on that. It's just bio. Bio is you. Like anything that's about you. We can authenticate you based on that. The reason why companies don't do it is often, like I said, it's expensive.
And I guess my question, my reasoning behind leading into that, because using now something that you are to that level is dangerous.
Yes.
Because now you know more about me than anybody else. And if some crazy person or some, adversary out there gets that information, now I'm responsible for trying to prove that it wasn't me. But they have that level of information about me that, it can't be, it can't be reversed. So, and then you think of, things like deep fake. If you have my voice pattern or my retina scan, and then you tie that to some other entity and go out and perform some illegal act, and then they come to my house and arrest me or, try and interrogate me, and I know nothing about it. Well, now I have the burden of proof on me. So I don't kind of agree with, these biometrics. That's why I was asking if there's something else that could be utilized instead of really giving up that level of personal information.
Yeah, I agree with everything that you said, and I will also make one of my comments to that as well. But the biometric, the thing that I want you to understand about biometric, it has to be something about you, like it has to be bio you. We can't use anything else other than the you. That's one. And so the issue that you're raising, Shayla, which is very important, is this. You see how a lot of companies have been hacked. They hack Equifax, they take away your social security number. Well, you can go and change your social security number. But what if they take your fingerprint? Yeah, that's gone forever. Because we're all different, based on our DNAs and all that stuff, we're different. So one of the thing that I really, really don't like about biometric myself is just that. If it get breached or if they hack the system that have your biometric data, then you're done. Right. So anybody with a different opinion about this?
The prime examples, like when you have like these foreign entities that may call your phone and ask, I'm calling on a recorded line, can you hear me? And you say yes or no. Is that almost the same thing? Like, they're recording your voice where they can edit into like Sheila said, burden of proof, where they've got your voice saying yes, so they can add it to anything to say, hey, yes, hey, you said yes to this question. And now we're using it against you, saying that you agreed. Because that's happened here in this area before, where people have called, recorded your voice, and then used it against people. I think that that's along the lines of what Sheila was getting at, but that has happened.
Yeah, and these guys are criminal guys. These guys are criminals, so they have a creative way of coming up with stuff. There was this classic attack that happened. You know how like a lot of us, we like kids. So they will call you and they'll have like a YouTube video of a child crying, right, in the background. Like, oh, I'm working from home, there's a baby crying, but it's a YouTube videos of a baby crying. So now you don't want to hold them any longer. You're giving them anything they need because there is a baby crying in the background. So that's why we just have to rely on the security awareness training. Train people not to give up information that easily. Yeah, but Michael, they can easily, like, if they're using the like voice recognition, yeah, they capture your voice. Yeah, they can easily just impersonate you in that way. So there is a reason why you don't see biometric everywhere. You don't see biometric used on facilities unless it's super, super secure. I heard Google uses. So
Hey, so where I work at, before I even started working there, I had to get fingerprinted, and because I work in the restricted area, so my name is on my something you are, something you know, something you have are all in a system out there with my fingerprints. It's not only out where I work, but it's also with the government in their system. So my fingerprints are literally all over the place out there, and the government system. So, but that's the biometrics part of it that I can remember.
Yeah, when it comes to security, though, guys, look, the best way to secure anything is not to collect it in the first place. If you don't have it, that means it's secure. So I tell sort of, companies I work for a lot of time when we're doing the security, it's okay, let's limit the information that we're collecting. With the biometric, if we don't need it, let's not bother with that thing. There are other ways other than, dealing with biometric. Anyway, let's get going. So we can also, there are attributes, instead of using biometric, why can't we use it somewhere you are, like location-based? I mean, the military uses this quite a lot. I don't like this because it looks like they're spying on you. You can't go to the restroom without them knowing you went to the restrooms. Your location is being advertised every time you have that thing. So this is the geolocation. This is the GPS. They use the satellite in the sky to kind of keep track of all your movements. But it's great because now they can authenticate you based on where you're located. You are located, right? It could be based on the IP address, but it could also be based on the VLANs. This is a virtual local area network. We are going to talk about this, right? This is a way of virtually segmenting your network. Taking a bigger network and chunking that into small pieces. It's great because it provides segmentation. Remember, the best way to secure anything, is through segmentation. I probably should say the best way, but another great way of securing anything is by segmenting it. Right? You're not solely securing anything, but you're saying, okay, if they attack, it's okay if they attack this portion, but not the whole thing, just this little portion of the network. That's what really VLANs allows us to do. So we can authenticate people based on where they are within the VLAN as well. Good stuff. Something you can do. This is the action you perform. So anything that is unique, maybe this is where like Shayla was talking about, right? It's like, okay, well, if we cannot biometrically authenticate you, what else can we authenticate you based on? Well, maybe something you do. It could be the way you walk. It could be the way you sign, by the way, like the way you type, like how fast your fingers move on the keyboard. There are systems that authenticate you based on that. Right? So that's something that you can do. Actually, Microsoft introduces something known as Microsoft, I think they call that thing Hello. something like that. I don't know if you guys have seen that. If you have like a Windows 11-ish, Windows 10 or 11, you probably have this thing enabled. So this is their biometric system, which you don't have to use a fingerprint, a facial, or anything like that. You can use the speed of your finger to authenticate. You don't even need to create a password. As you go right there, you start typing nonsense, they recognize the speed of your movement and they authenticate you that way. So that's something you can do. You have something you exhibit. This is a behavior or a personality trait that can be captured as unique. So this is just like that guy right here, right? Just like that guy. And then someone you know. I have a funny story about this one. At some point, I applied to Lockheed Martin, the company that manufacture, war, jets and all that good stuff. So I applied over there. I never got the job, by the way. I never got the job. And now that I'm saying this, am I recording? You guys see the recording thing? All right, just want to make sure. So I applied and they gave me the interview. So I went to the facility. It was a super secure. Oh my God, I had to go through the security guards. I had to all kinds of stuff just for the interview. I'm like, oh my God. So I got in, I talked to the manager, they interviewing me, they're asking me all these technical questions and stuff. And now they ask me, okay, do you have security clearance? I'm like, no. They're like, okay, well, we're going to start getting into the security clearance, side of things. I'm like, okay, cool. Now, and then they asking me places I've been, places I've lived in, like people that I know. Because on my my application, I have put in, from Africa, all that stuff. And it's like saying, okay, how many people do you know in Africa? Who's your sister in Africa? They got so personal where I was like, no, I give up, right? Keep your job. But it's the someone especially a lot of these government jobs and, security clearance related type of stuff. Oh yeah, they're gonna need to know, to ask your neighbors, like, okay, so how do you know Michael? He usually make noise? Do he looks like he needs some money, right? So they, sort of, they were asking those things. So that's the someone family, neighbors, anybody you know. Any questions? Questions? All right, let's get going. Topic B, implement knowledge-based authentication. Let's see how you will go by doing this. 1.2, 3.8, 4.1 from that exam objective. Knowledge base. This is where it's getting a little bit technical now. So local network and remote authentication. So if you're going to be authenticating based on what people know, first of all, you need the authentication provider. The authentication provider is that thing that hold on to the information that these people are going to remember. These people are going to recall once you ask them, what's your username? This is my username. So you must have like a provider that has that username inside, like a little database that have the username inside, and they can, cross-check and make sure. The provider also, like I said, it's a database of usernames and passwords. Your passwords, remember, your passwords have to be stored as hashes. Remember that for your exam. Every secure system have to store your password in the hash, as a hash. The computer is intelligent enough to compare the two. So as soon as you type in your password, it's going to get the hash and compare with what you have in a database, and then boom, bingo. If it matches, they let you in. On Windows environment, we can do local sign-in. This is what you do if you have a Windows machine. We've done this for years and years. But if we want to do the network sign-in, we could use NTLM. This is old. This is not good. Old and not good. They have version 3, which is a little bit okay. But NTLM version 1, version 2, those things were not secure. So this is the new technology LAN manager. Somebody can maybe look at that up on Google quickly for us. So new technology LAN manager. Microsoft developed this within those days of a Windows NT. If you sort of old enough to remember that stuff. I don't remember that stuff. I read all that stuff in the books. So Windows NT. That's when they have this. So this is weak. Another one, we're going to talk about this in more depth, is Kerberos. Kerberos is another one we can use when we're signing in on network. So computers are connected on the network and then you're trying to log in. Kerberos is another one. This is the better version. This was developed at the MIT. Then Microsoft adopted this thing back in 2001 and 2-ish and 2003-ish. Microsoft at the time was having a lot of issues with security, so they dropped everything and started focusing on security, and then they started adopting this guy, Kerberos. I will talk more about this one. You're gonna have to remember this one for your exam, Kerberos. Then you have a remote sign-in. Again, you're just remoting into the environment. Usually on the Windows, we will use RDP. How many people have heard about RDP? I'll tell you this right now because you need to remember this for the exam. This is the remote desktop protocol, right, from Microsoft, and is port 3389. If I were you, I'll write that down. It's secure. It's secure, very secure actually. It allows us to remote desktop into stuff. Into Windows computers, for example. Cool. On Linux, we can also do some authentication on Linux. Linux usually have all the authentication information into these two locations. So they use the password, passwd, literally, we call this password, but it's passwd. And this thing has like the username right here. All the username on Linux, they're here. Then you have the shadow. This where all the password hashes are here in the shadow file. If you're using Linux on an enterprise environment, you could use PAM. This is the pluggable authentication module. This is just for businesses. You want to do like more than what you would do locally within a Linux computer. You will use the pluggable authentication module. This was introduced by Red Hat. If you heard about the company Red Hat, there are the good guys who gave us CentOS, which is like a flavor of Linux that we're not going to talk about it right now. I just want to give you a little background of that. Then single sign-on. We will talk more about single sign-on, I think, in the later chapters. But this is the idea of you sign in once, you have access to many things. Single sign-on, you sign in once, you have access to many. Google does this. As soon as you sign in into Gmail, you have access to other stuff, other Google stuff like YouTube and Google Docs and Google Slides, and like you have access to all their stuff. Single sign-on. You sign in once, you have access to multiple things. So let's keep digging into these things. Let me see how far I have so I can see how fast I need to go. Yeah, I definitely need to move quickly. Yeah, I need to move a little bit quickly. After this chapter, guys, we're going to lunch. So, right? Cool. So Kerberos authentication. So Kerberos, it's like a single sign-on. Remember the idea of a single sign-on. You sign in once, you have access to many stuff. So Kerberos is like a single sign-on, but this, it's for services. It's not for users. It's for services, right? So that's Kerberos. And the way Kerberos works, it will give you a ticket. I want you to remember that for your exam. If they ask you, oh, which one of the following authentication protocol that give you a ticket, Kerberos. It's just going to be Kerberos. And that's the question CompTIA might ask. Which one that does a single sign-on for services that give you a ticket? It's going to be Kerberos. So the way Kerberos, I'm not even sure if I'm saying this right, but there is the way Kerberos works, right? It's going to have what's known as a KDC. This is the Key Distribution Center. And this is the thing that give out like the ticketing stuff, right? So you're trying to authenticate. As soon as you sign in, you are given a ticket. And that ticket usually has your username, your passwords, and there's sort of like a timestamp, like when it's going to expire. That ticket will expire after 8 hours, for the most part, after 8 hours. So once you're given the ticket, then you're able to authenticate it through different services automatically. That's why this is known as a single sign-on. You're able to go from a service to another service to another service automatically. It's not going to ask you for your username and password again, because all that information is on that ticket. All right, so there's two things needed. There's a client known as a principal, the client, that's you who are trying to authenticate. And there's the KDC as well as the application server, right? The thing that you're trying to communicate with. So KDC is that ticket granting system that you're going to have to ask, hey, I'm trying to authenticate using Kerberos. Can I please have a ticket that I'm going to present, to everybody who's going to ask me, hey, who are you? So the KDC, there's the authentication. So the KDC, the ticket granting ticket, then there's the ticket granting service. I don't want you to go into this because I think the way they implemented this was stupid. Because the way it works is you go to KDC, you be like, hey, I need a ticket. KDC is like, okay, gotcha. It's going to give you a ticket granting ticket, meaning it's going to give you a ticket that's going to use to sign another ticket. Like, why would you do that? And then you go to the application server, and then that give you the actual ticket that you're going to have to use. I don't want you to remember that. What I want you to remember is Kerberos will give you a ticket, and that's the ticket you're going to use as you're trying to sign in, as you're trying to authenticate. So Kerberos, it's used on Windows. Yeah, so this is the diagram of what I was trying to tell you. You have the principal, the client. You go to the KDC, you get a ticket granting ticket. You bring that ticket granting ticket. That's like sort of like step one, service request. Step two, you take that ticket granting ticket, you present that ticket to the application server. And that application server kind of does the rest, the neutral authentication and all that good stuff. Then you can start communicating. You can start doing what you do. Anybody else who asks anything, you will give him this. Right? Any other service that asks you, hey, have you been authenticated? You will give them that ticket. Remember, ticket for Kerberos. Okay. Few other things that might maybe confuse you or not confuse you. We have a PAP, CHAP, MS, CHAP, and CHAP. So PAP is a password authentication protocol. This was one of those early versions of a protocol that they used to authenticate. It's completely unsecure right now. You authenticate using password. That's really what this does. There's no ticketing and any of that cool stuff. So this right here, you were using sort of like passwords. Therefore, it's not secure because the password was not even that long. I think it was like 7 character. The computing power we have right now, you can crack 7-character password in seconds. That's how easy that is, in seconds. So then they came up with CHAP, Challenged Handshake Authentication Protocol. So CHAP was sort of like a success because there was the challenged response. So this is sort of like what Microsoft used within the NTLM. Remember, I told you NTLM wasn't secure. That's because even CHAP wasn't secure. I mean, CHAP is not secure. But there was that challenge. What that means is if a client is trying to communicate with the server, they will have to do the mutual authentication. So it was asking me, who are you? And then the other guy would be, okay, who are you too? So there was like the mutual authentication that gets involved, that there is the challenged handshake for the authentication. So there was different implementation of this. Cisco came up with their own version. I think there was a few other companies. Microsoft came up with their own version of doing this. Again, like I said, they sort of like implemented that into NTLM. which was replaced by Kerberos, we just finished talking about. So everything you see here, if it pops up on the exam, I doubt if it will, but if it does, it's not secure. All these protocols, PAP, CHAP, MSCHAP, it's not secure, right? What's called the CHAP sort of solved the problem of authenticating using password, but it was still not secure. So your question might be, okay, well, if that wasn't secure, then what do they use for security? We are going to talk about that. It's this guy right here. It's not on this slide, but it's this guy right here. Is EAP, Extensible Authentication Protocol, EAP. So EAP is the secure protocol that we use for authentication purposes. And Microsoft have their own version known as PEEP, or Protected EAP, which we're going to talk about in more depth. All right, cool. So those protocols are used for passwords, right? For if we're trying to authenticate, if somebody's asking you, who are you? My username, my password is this. So there are ways of attacking passwords, right? Plain text. What is a plain text? Anybody? We talked about that in chapter 5. What is plain text?
It's encrypted.
You say it's encrypted or unencrypted?
It's encrypted.
Encrypted. And that will be, nope, that will be unencrypted. Encrypted is a ciphertext.
Oh, okay. All right.
Yeah, so ciphertext is a message that has been encrypted. Plain text, whenever you see this plain text, is unencrypted. It's something that has not been encrypted yet, which was right there, by the way. Anyway, so whenever we're talking about password attacks, guys, look, if you are using a protocol that transfer your information in plain text, meaning it's not encrypting anything, then yeah, man in the middle is coming and they're going to be able to see your passwords, right? They're going to be able to see your passwords because it's not secure, it's not encrypted. That's why you should never, ever, ever use unsecure protocols. Those HTTP, don't use them, right? Early on, I told you that they had the version TLS version 1.3. Guess what? One of the cool thing they introduced within version 1.3, HTTPS everywhere. It's literally HTTPS with the security everywhere. So now the browser, specifically Firefox, if any of you use the Firefox, the Mozilla Firefox browser, that thing has implemented this one already. Google Chrome haven't, but Firefox did, which basically means if a website is not secure, it's not going to work with the Firefox. That's what that means. If it's using clear text protocol, unsecure protocols, it's not going to load up using Firefox browser, which sounds like I'm marketing Firefox, that you guys should start using Firefox. All right, cool. So locating passwords in the documents and code repository. I told you about GitHub. GitHub is a way of a programmer, they develop code and they just drop in the GitHub. Those are repositories. I can't tell you how many companies that have been hacked because of that. They put password inside of code and they leave it there for some reason. If you remember the hack that I shared with you, the SolarWinds attack. The 2020. This happened because exactly what we're talking about right now. The developer of SolarWinds, they left the passwords into the code, into their GitHub code. And I keep saying GitHub, but I haven't shown you GitHub yet. But let me bring that up. This right here. That's GitHub. Which it's okay to grab account. It's the account is free. And then you're able to see pretty much a lot of stuff. Oh my God, a lot of code. You can see. For example, if you want like password spraying attack, bunch of stuff. Let me just grab one of these. To recovering your password from this. Yeah, there's a bunch of tools from a bunch of developers all around the world. You can just come here and be able to see it. So this is the repository here, right? These are the code. So the issue is they do all this, and they left the password inside. That's what happened with SolarWind. So you will come here into this repository, you look at the code, this Python here. Well, there's nothing here. Well, this empty. Anything here? Well, all right. Well, it looks like I picked the wrong example. But really the code will be like in here. And if you look carefully, you'll be able to find interesting stuff within the code. So that's that right there, repository. Online password attack. I told you about Crack Station. That's like sort of like an online database that you can use to attack passwords. So the adversary interacts with authentication services, and so on and so forth. So, but they can also go online and try to authenticate a sign in. A username is this, password is this. There is usually the restricted login rates where you try 3 times, we're gonna, kick you out. That's great. There's a way around that though, right? There's what we normally call password spraying, something you need to remember for your exam. This right here. Password spray is when we're trying to do brute force attack. Instead of brute force here somewhere, yeah, there we go. We're trying to do brute force attack where we are guessing your username and stuff like that. With the password spraying, we're doing the other way around. Right? The other way around, meaning usually whenever you're trying to brute force whenever hacker trying to do the brute force, they will usually be like, okay, this is the username, and they're gonna guess the password. Let me try summer 2020. Well, that didn't work. Well, let me try winter 2020. Well, that didn't work. You do that 3 times, they're gonna lock that account. Most software are, familiar with that. But password spray is the other way around. It's when we are using one password, like summer 2020, then we're trying different usernames. Right? One password, a different usernames. It's like the other way around. And that doesn't get blocked, by the way. So this whole, limit does not apply to that. So they can guess as many times as they want. And that, as we're talking right now, this is killing everybody right now. This right here. Because the attacker, they're using these and they're succeeding. Offline attack. This is when they capture the database of your password and they try to go offline and they try to crack it and figure out, try to match with the dictionary and all that good stuff. Offline attack. Because if they do online, it's going to limit to them how many times they try it. If they do offline, it doesn't. Right. And before you do, how can they get access to the database? There's a tons of database online that they can use for this. Right. So that is you. And these are like real passwords hashes, right? Real password hashes that that have been, that have been part of some sort of like a data breach. All right, brute force. Brute force, it's kind of trying every possible combination to try to match a hash. In another word, you're trying different things and try to see if you find the match. So that's classic. Right? A lot of attack use this, but most of systems will kind of sort of like block this, or let me just say it this way: it will take a very long time to crack anything using brute force attack if that password is secure. Right? Or it will take a long time to match the actual hash if that password is like sort of like a secure password. If it's like 12 character or 20 character long, yeah, it will take a while. But if that was like a 7 character password, oh yeah, it will take no time to crack that. All right, so large output space and sufficient login input password increased time required. Yeah. So basically, the longer the password, the more special character you include, all that good stuff. It takes a long time for the brute force system to do what they do. But guess what? Hackers are not stupid. They can also use a combination of a brute force and dictionary. And not just the dictionary, also a rainbow table. A rainbow table, these are hashes. It's like a table of a pre-computed hashes. So if they have like a table of a known hash, and they have like a dictionary of known keywords that people use as passwords, and they're doing brute force on that, it becomes a success. So they tend to have like a success with that as well. Okay. All right, so how do we prevent this from happening? Again, we could use a salt. I don't know if you remember about salting. We add a little string to the password, and then now everything is different. The rainbow table is out of the door. It's useless. It's not going to work. They try to match that with some kind of a keyword, dictionary. It's not going to work. But the combination of using both of these is known as a hybrid attack. That's when we're trying to using dictionary, brute force, rainbow table, and doing fuzzing and all that good stuff. It's hybrid attack. There are tools that does this. Let me show you this and I'll probably demonstrate this quickly. There are tools that we use when we're cracking passwords. Some of the common is can enable. Where is it? It's not here. All right. Can enable, it's one of the most common one. Tool to crack passwords, but it's not the fastest. What is the fastest is this guy, Hashcat. Hashcat is like the best hacking, password hacking tool there is. This guy right now, as we speak. One of the reasons because it's insanely fast. These tools such as can enable and can, now I see it, or loop crack. This one, they even stopped supporting this. There's the Hydra, it's another one. All these tools are great, but they use a CPU, the central processing unit, for the calculations as they're trying to crack your password. The thing about Hashcat, though, it uses GPU. Any video gamers here? Sort of. So you know how the importance of a GPU, right? Or how fast GPU is. I like this. They say the world's fastest password cracker, and that's true. I play around with this for a while. It's really true. So they rely on your GPU. This is the graphical processing unit, which is like very, very fast comparing to your CPU. So they're cracking your password using the GPU, which is very, very fast. And oh gosh, this thing has like a bunch of different hashes. So if a computer store your hash as MD5, well, we can use MD5 to crack that. They have like hundreds, if not tens, of different hashes. Even the stuff that we don't know that they exist, they have it here. Usually, the thing that I taught you was just MD5 and SHA, right? Just these two. That's what I taught you, MD5 and SHA. But this is another list of all different hashes that can be used. The beauty of Hashcat, and probably I will see if I still have this so I can demonstrate this for you, is you can decide to do the attack in a different attack mode. So you can do a straight, which is the most common, or you can do a combination of maybe brute force and the straight. You can do brute force, you can do the hybrid, and so on and so forth. Okay. So that's Hashcat. Let me see if I have Hashcat here downloaded and demonstrate this for you. Have I said that a lot of the things that I teach you in this class do not use this on the system? You're not authorized to use these ones. And have I said that you shouldn't be cracking your partner's password their Facebook passwords. I don't know if I made it clear. Yeah, no, you should definitely not using these skills for evil. There we go. There is a hashcat here. So let me show you this. Everything I'm doing right now, don't do this on anybody's passwords, guys. All right, so let's say that I bring on a PowerShell. PowerShell, I'm gonna open this in, I'm gonna run this as the administrator. So that give me the key to the kingdom here. Now let me grab just this link right here so I can change directory into this. I can CD into that guy. So I'll go back to PowerShell. I'm gonna say CD. I'm gonna change directory into that guy. I'm gonna just right click here so I get the same thing. I hit enter. Now you can see that little thing right there. Now I'm showing you PowerShell. You can see that right there. It's behind the 2.5, that guy. That means I am in this directory right now. I'm in this directory. So if I do ls, which means list, I can see all these, and all these is all of this right here. Same thing. I'm in that location. Cool. When I clear the screen. Cool. So there's a few things that I can do here. First of all, let me show you the help page. So I can do #cat and -h, for example. I do that -h, it goes to the help mode. I'm going to show you the things that we identify from their website. Come on. And the executable that you're looking at here is this guy right here. #cat right there. This thing. It's the same thing. You can only run it though from the command line. You can't run it from anywhere else. Right, that right there. And -h means, hey, help me. That's really what that is. -h meaning, hey, I want to see your help, sort of like help section. All right, so here's what you need to remember. And #cat is really, really easy. So you will type in #cat executable, the application. Then you will tell, okay, #cat, I want to use this hash type. So you will do -m for the hash type. That's why you knowing about MD5 or SHA-1 or SHA this or SHA that, it's important because you have to specify that. So now I will be able to tell #cat I'm going to be using this hash type. And then I'm going to be in this attack mode. Is it going to be a brute force? Is it going to be a hybrid? Is it going to be a straight mode? That right there, I'll come back to it. You can specify version and all the other stuff, but these two are the ones I just want you to be sort of familiar with. And the way you do it, you say, okay, -m, similar to right here, -m with the 1,000, and that 1,000 is supposed to identify which hash type this is. Then I'll show you that in a minute. And -a with the 3 is supposed to identify which attack mode. 3 is supposed to be something like a straight or a brute force. Those two. If I scroll down a little bit more, don't worry about all the other stuff. These are the hash modes that we were talking about a minute ago. So for example, if I put a -m as 0, that means, hey, I'm trying to crack MD5 hashes. Right? #cat, I'm trying to crack MD5 hashes. And obviously I can use 100 for SHA-1. I can use the 1,000. Where's that 1,000 we were looking at a minute ago? I think that's NTLM from Microsoft. I can see it here. All right, never mind. So all these are different hashes, the ones we're looking at from the their website. If I scroll down a little bit more, I can start seeing the mode. This is the attack mode. I was showing you this a minute ago. So I can just say 3, for example, that will be brute force. I can just say 0, that will be straight. And then I can just specify the format, all the other good stuff that I don't want to get into. So the way I would do this, first of all, I will have to have the databases. We talked about the dictionary or the data, the rainbow table. So right now here, I already have a rainbow table. This MD5, it's like rainbow table of MD5 hashes. These are passwords. I don't know what they are yet, but these are passwords that I can potentially match or potentially bring to life. Another thing I would need for this to work, it's something like a database of known passwords. So something like a RACU. I told you guys the story behind the RACU, right? No, I did not. Oh, this is the company in 2009 that got hacked, and they found out that they were storing their passwords in clear text, like it wasn't encrypted, it wasn't hashed. And then what's the beauty of RACU, it was used for people that want to go outside of their marriages. You know, they want to see other people and they're still married. So I don't know if you remember that, but somebody got pissed off and decided to hack them and now expose everything online. Anyway, so there is like a database of millions of known common passwords that people use. This right here, like it's a lot of them. Like when I say million, I mean millions, right? So I can use that as well, or I can set up something of myself, something like this. Where you go online, you find out like a common passwords people use, then you put those here. Once you have both of those, then you can get the cracking going. So the way this will work will be something like this. You say hashcat. I'm going to use the executable, and then I am tabbing on my keyboard. So I'm hitting tab to finish the whole thing because I don't want to misspell anything. I will say dash M. And if you remember, dash M was for the hash type. So I can say, okay, dash M, I want to use MD5, dash 0 for the MD5. Then I can say dash A for the attack mode, if you remember. And I can just say 0 again for the straight mode, right? And then I can specify, all right, hey, look, I want you to do this kind of attack, and I'm using MD5 hashes, and let's do that from MD5. Then I want you to be comparing with what's in MD5 to what's in the password, for example. This password list, that right there. These are the two things that I'm comparing. Remember, you cannot crack hashes. Remember that. You can only compare to see what's gonna match. That's what I'm doing right now. All right, I hit enter. The hashcat goes in and does what it does. And I don't think this worked. Yeah, this didn't work because of my GPU. I'm having a little issue with the fan speed, which is like not supported. That's why like hashcat is very sensitive when it comes to that GPU, right? The GPU thing. You have to have a computer that supports the GPU that this thing requires. But anyway, it would have went on and then come back and said, hey, look, we did this thing, and then we were able to find these hashes, and they match these passwords. Okay, which I don't see anything here because of that right there. But so this is a hashcat. Okay. Any questions for me?
So for those password lists, you have to create those on your own, or just go out to the web and capture some MD5 list or password list.
Yeah, just go on the web and just grab anything. But Shayla, imagine if you were doing this to your significant other. You can just list the stuff you think they're interested in. Like hockey, like this and that. You have like 10 keywords. You go from there. Hey, you didn't hear that from me. All right. Yeah. So literally, we don't do cracking passwords and stuff unless you have a written permission. I want to emphasize that. When you get certifications such as the ethical hacking, the CEH, literally there is a code of conduct. Like you have to agree you're not going to use these skills for evil, right? Keep that in mind. All right, where were we? So we talked about all these. Cool. So authentication management, hardware, software solutions, they both exist. You can have a hardware and software solutions that does this for us. Password key, we have the USB token, we have NFC. This is the near field communication. We will talk about this, but this is commonly used with your Google Pay, Apple Pay, Android Pay. This is the technology that they use, but we can use this for password reasons as well. You have password vaults as well. These are like your password manager. There is one. I'm just gonna show you the name. Don't ever use it because they don't really care about security. They've been hacked just this year. They've been hacked about like 3 times. It's known as LastPass. If you ever heard about LastPass or you've ever used LastPass, don't use them anymore because literally they got to take their security serious. So, but this is a password manager. Let me show you the one that you probably want to use. 1Password. 1Password is great. I am myself, as we speak, I am going from LastPass going to 1Password. The thing about LastPass was free, so they had a free version, and these guys don't. But anyway, so this is a password manager where you can create just one master password and then have like a vault where you put all the most common stuff you sign in. Then you can generate another password for each one of these applications, and you don't have to remember those other passwords. The only password you got to remember is just one, the master password, right? And then every app gets its own password, a very secure password, and you don't have to remember that. That's the beauty of this. I highly recommend you use it because using the same password for multiple applications, it's also not good. Right? If I capture your Facebook password and then I'm able to get into your Instagram, YouTube, and everything else you use, not good. So use something like a password manager to help you manage those passwords. There's the FIPS, there's the Federal Information Processing Standard for this. This is for government as well. Cool. All right, we are 12. Okay, so let's take another quickly break. Once we come back, we'll finish up this. Looks like it's a little bit long chapter. We'll finish up this and go to lunch. So take about 10 minutes. I'll see you guys in 10. All right. Topic C, it's implementing authentication technologies. So let's look at a way of implementing this. 2.4, 3.8 from that exam objective. We might talk about the hardware security module, the HSM hardware security module from 3.3. It's another way of implementing authentication. All right, first way, it's authentication smart cards. People are familiar with these things. There's really not much to talk about here. Other than this thing have a chip, and that chip is what hold on to your private key, correct? So everything you go, you swipe, you get in. That's because there's the private key. And then the public key that corresponded with this, it's in that self certificate server, the PKI, the private PKI that we talked about earlier. So that's smart cards sort of authentication. We talked about Kerberos. Kerberos is when you literally sign in, like for example, within your Windows login page, you sign in, but on your network. As soon as you sign in, you get a ticket, and that ticket is used for the session for about 8 hours. Some of the Kerberos systems can kick you out if they don't see any inactivity for about a certain amount of minutes. If you've ever authenticated into a computer and then all of a sudden after like 1 hour, you come back and you no longer sign in, well, that's Kerberos. So if I don't see any activity, let me sign you out. So you have to re-authenticate for you to get another ticket and then be using that as well. For smart cards, you must have a card reader. That's what they have on those doors when you do that. Cards stores the private key. I've mentioned that because whenever you're using this, you're using the certificates. You're not using no password. Like this is the most secure way of authenticating someone, assuming they will keep this thing secure. Sometimes these cards are protected by a PIN. So let me ask you this: if the if the business asks you to swipe your card and then ask you for a PIN, will that be considered multi-factor authentication?
No.
We have a no.
Nope.
2 no's. There's no yes, all no's.
I was thinking yes.
So it's 1 yes. All right, for those who say no, please tell me why. Those who say yes, please chime in and tell us why.
Because for the username, they're asking for your username and your PIN. So it's more of a 2-factor authentication.
Okay, so it's not multi-factor.
I agree with Mike.
Okay. Okay. And you guys are right. You guys are right. I'm not saying wrong. You're right. But I'm glad I asked this question because it looks like I didn't really make this clear. So multi-factor authentication can be 2-factor. All right. There is no really like the only difference between a 2-factor and a multi-factor, it's when you go over 2. Right? When you use more than 2, then these have to be literally identified as multi-factor authentication. But if you use 2 way of authenticating, it can be 2FA or it can be MFA. It can be multi-factor authentication as well. I don't want you to be thinking as if they're like 2 completely different things. So this right here, guys, it will definitely be a yes, because you have the smart card and then you have the PIN. PIN is something you know, the smart card is something you have. So that will be multi-factor authentication or 2-factor authentication. Great. 2 other things. Key management devices. So eventually, if you are doing this, you have to provision the keys. So you have to keep the private key private, the public key private, the public key public. You have to be able to share that with anybody. So provision keys with risk of insider threat reduced. So again, guys, keep the private key within maybe the smart card, for example, or we can, other than putting the private key into the smart card, maybe we can have the key into another device, something like this guy and something like this guy. So I want to understand this, specifically these 2, because they will pop up on that exam. So one, it's a TPM. TPM is a trusted platform module. This right here, guys, is a chip on your motherboard. You guys know what a motherboard is, right? Everybody knows what a motherboard is, correct? On your computer. Good. So this is a chip on your motherboard. It's not removable. You can't take that away from that actual motherboard. I want you to understand that. But we use the TPM, the Trusted Platform Module, to help us manage the keys. It basically store the private keys. Okay. So if we want to authenticate on our computer, not using the password, we can set this up. Right? If we want to, for example, do a full disk encryption of your entire hard drive, you will have to have a TPM on your motherboard for this to work. Okay. So that's one. Takeaway, it's not removable. It's attached to the motherboard. That's how the CompTIA is going to ask you the questions. Which one is the following? You cannot remove it. It's a TPM. HSM, hardware security module, is this thing that you're looking at right here. It looks like just like a switch. This one is removable. You can attach this to your entire network. And it's literally designed for your keys, your private keys. You can even use this as the key escrow. If you remember when we talked about key escrow for backing up your keys, the key backups, you can use HSM as a way of backing up your keys. It's big, it's removable, it can be attached to the entire network. HSM, hardware security module. There are different plug-in cards that you can, plug on the back of this thing to make it more robust. Again, it's used for cryptographic purposes. It's very fast for encryption, decryption. It's fantastic. So if you have devices, let's say that you have servers that are very old and that doesn't have a TPM motherboard, well, then you have to use this guy. If you want to, to start, authenticating with those servers without using passwords, if you want to use the keys, if you want to use the private and public, if you want to use the PKI, the public key infrastructure. Okay. Extensible Authentication Protocol, EAP. If you remember earlier, I told you we're going to talk about this one. Here we are. So this is another protocol that you will use to authenticate, and this is the most secure way of authenticating stuff to your environment. So EAP can be used to authenticate user at the network. All right, as people are trying to access the Wi-Fi, the network, they can use EAP. So EAP is going to be the protocol. And remember, a protocol is like a language. Like this is what we use we're using the English protocol right now to communicate, right? English. So when you're authenticating, you can use EAP as the way of authenticating, as the language of authenticating. But on the switch, you will have to configure something known as 802.1x. 802.1x, it's also known as a port security right here. Port-based network access control. It's known as like port security. What this means is that you tell the switch, hey, Mr. Switch, if anybody ever plugged their computer into this port, I want you to ask them who they are. What's their name? What's their password? I want them to authenticate first before you give them access to the network. Before they can connect it to that Wi-Fi. Ask them who they are. And the EAP, Extensible Authentication Protocol, it's going to be that protocol that's going to be used for the authentication process, basically for that whole conversation to take place. It's going to be carried over by EAP. It's super secure. It's used pretty much everywhere. There are different variations of EAP, different implementations of EAP, and I think we're going to talk about those in the later chapters. And as you're doing this, you will need a few things. You need a supplicant. Then you will need like they said, NAS, but really you really don't need that. But you need an AAA server. AA server is the authentication, authorization, accounting server. This is the server with a bunch of the username and passwords. Yeah, we're gonna, EAP is gonna check with these guys and like, hey, do you happen to have this guy, username this, password this? He's trying to authenticate. AAA is gonna be like, yeah, I do. Here is, this is it. But remember, 802.1x, it's configured on the switch. Remember that. So for you to be able to get this to work, like I said, you will need an AAA server. Here's another thing you got to remember for that exam. AAA server, it's a server that does authentication, authorization, accounting. Basically, it does all the authentication stuff for us. One such a server is known as a Radius. Radius, this guy. Radius stands for Remote Authentication Dial-In User Service. Yeah. Don't ask me who came up with the name, but this is great. It's sort of like open source. I probably should say open source because that sounds like it's free. But Radius, it's used by different companies. It doesn't belong to anybody. Right? Anybody can use it. So we will use this to do the authentication. We will use Radius as the AAA server. So people try to authenticate it to our network. AAA is gonna be able to think that we use to ask them, who are you? All that good stuff. Remember, radius is used by different vendors. If you are a company, you are using a product from Checkpoint, Cisco, Juniper, Microsoft, all these other places, you will probably want to use radius because it's used by different vendors. And I'm pointing that out because that's how the exam is going to ask you those questions. Like, okay, a company is using this and multiple vendors are involved. What should we use? Radius. So Cisco, as everything Cisco, they said, okay, to hell with you, radius. We're gonna come up with our own. So they did come up with what they call a TACAX. Yeah, literally TACAX, which stands for Terminal Access Controller, Access Control System. Yeah, right. Like, who come up with these names? Anyway, so it's known as a TACAX Plus. And the reason why they came up with this is because there is some limitation with the radius. For example, radius doesn't use a TCP. Radius uses a UDP. If you know the difference between the two, TCP or UDP, if you know the difference between the two, that's great. Not, I'm going to have a section where we're going to kind of go back a little bit to that networking section. But anyway, so radius uses a TCP. Radius, it doesn't do a full encryption. Radius only is going to encrypt the password. It's not going to encrypt the entire conversation. So as you're trying to do the authentication, radius is not going to encrypt the entire conversation. It's just going to encrypt the password. But TACAX Plus encrypts the whole thing. TACAX Plus uses a TCP, which is reliable compared to UDP. Okay. So TACAX Plus is better than radius, but but TACAX Plus belongs to Cisco. I want you to understand that the company Cisco. So if a company have a bunch of a Cisco product, yeah, then go with the TACAX Plus. Right? If they have a different products, then use radius. As far as the security goes, TACAX Plus is better than radius, right? Token keys and static code. I don't know if you know anything about this, but yeah, these are the RSAID that we used to use before smartphones, basically taking over. So there's what the number called a one-time password, and there is the time-based password. So one-time password, it's just the number that gets generated, you can use that just one time. This is the RSAID. There are some that are known as static code. These are like dumb static cards where it doesn't change, but you can only use that one time. So not really that secure, really. But what we had though was this right here. This is what's new right now. And this is what, I don't know if it might pop up. It might pop up, it might not pop up on that exam, but I will probably remember this. There's the hashed MAC media access control. This is not MAC. This is not the media access control. This is the message authentication code, right? Hashed message authentication code. That's what that stands for. Not that important. What's important though is this one-time passcode. So we usually call this HAT-P, right? HAT-P, which is, like I said, HMAC-based one-time passcode algorithm. So this is a one-time password. One time. HAT-P is one time, meaning these are the RSA, where there is some sort of like a password, and you can only use that one time. Then there's the TAT-P, which is time-based. I want to remember these two things, one time and time-based. One you can use just one time. It doesn't change until you use it. This one, however, TAT-P, it's time-based, one time. It's just going to expire every 30 seconds, for example. Right? if you've seen this Google Authenticator, and I keep saying that, but I gotta show you a picture. These Google Authenticators, that's what they do. That's what they use. Microsoft have these. A lot of companies have these now. It's just like an app in your phone that give you like these number. There's the little kind of a time based that goes around. It reaches 30 seconds. These number have to change. All of them, number have to change. So this is the hot P, that right there. Right. Actually, that's the TOT P. Excuse me. That's the TOT P, the time based one-time password. It's time based. Okay. All right, two-step verification. This is really easy peasy stuff, right? Two-step verification. You transmit code via an out-of-band channel, like you can get an SMS. Don't be using your SMS because hackers can easily clone your SIM card, or they can call the company, the AT&T, the Verizons. They can call them impersonating you. Hey, this is me. I forgot my this, and can you please reset my thing? And I lost my number, and just transfer this to my new number. The only thing these people are going to ask you is, okay, what is the security challenge question? It's like, okay, what is your mother maiden name? Right? Or what is this? And then hackers can easily find that online about people. So SMS is okay. It's okay. I'm not saying you should use SMS as a part of your two-step verification or two-factor. But all I'm saying, it's not as secure as you will use, let's say, Google Authenticator, right? Where they just give you the code, and the code is within you and in your phone. All right, there we go. Got a phone call. If they change the phone number, this is not gonna matter. You got push notification. This is very common with Google, where you sign in into your phone, into your Gmail. Now you're trying to sign in into your computer. They send you a notification, and then you just have to agree to the number. You click yes or something, right? Make it a lot easier for you. I'll be careful with that kind of stuff. It could be a hacker trying to reset your password. Like if you go to google.com right now and just say, I forgot my password, you put in the email, and then you try to reset the password, they might give you a push notification asking you, hey, is this you who trying to reset your password? You hit yes, you're done. You're done. So I'll probably not do that. You have an email account, definitely going to send you an email to try to do the verification stuff. So there's a possibility of interception. Like I said, they can change your SIM card, they can change your phone number, all that good stuff. I will be careful with this. If you want to use the phone for these sort of things, use the thing we just finished talking about. This guy, time-based one time. Google Authenticator, they have some device that they sell that does this as well. That's going to keep expiring those numbers. Any questions for me? No, we're good. We're good. Cool. Let's finalize this. Topic D, summarizing barometric. This is barometric. It's going to be straightforward because we've talked about a lot of these. You guys know a lot about this as well. So let's dive right in. 2.4 on that exam objective. So biometric authentication. First, before we can authenticate you based on who you are, based on the bio, well, we need to enroll you. There's the enrollment. Enrollment basically is just taking a picture of your hand, your finger, your retina scan. We take that, we put that somewhere in a database. Next time you show up, we compare the two, right? The thing we were talking about earlier is, what if that get hacked? Then you're done. So that's the only thing I really I don't like about this. So here's a few other things you need to consider. I will probably remember this and this and this for the exam. It might not pop up, but let me talk about this. So there is what they normally call efficacy rates you need to be aware of. One of it's false rejection rate, FRR, also known as a type 1 error. False rejection. This is when we were supposed to allow you, but we reject you. It's a false rejection. Folks tend to get this confused. You show up, you scan your finger. We were supposed to let you in, but we do not do that. That's a type 1 error. There is false acceptance rate, FAR. That's a type 2 error. We were supposed to not let you in, but we let you in. We falsely accepted you. So false acceptance rate. Let me ask you guys this. Which one do you think is the worst between the two?
I would say the false acceptance.
Yeah, I agree.
I agree.
Okay. Perfect. This one, it's very annoying, false rejection, right? Because imagine I'm trying to go in and then you're not letting me in. But this is the worst. So guess what companies do? They do this. Crossover error rate. Well, this is where these two meet. So imagine if this is the system right here, and that's the false rejection, that's the false, acceptance. Well, we want to be right here, right there. Too much of each one of these is not good. So CER, crossover error rate, is where they actually meet. So we want to configure the barometric system to come down to that right there. Right? So I will remember that for the exam. The speed also matters, especially at the airport. A lot of the barometric stuff, you'll find them at the airport, right? It got to be fast. In Atlanta, I think we have one of the busiest airports in the US. They have the latest barometric stuff. The last time I was reading on it. The throughput really matters a lot. Failure to enroll rate. This is when we cannot enroll someone. Extremely expensive to implement barometric. There's also the privacy concern, the Shayla concerns, right? Why should you have my face in your database, right? Privacy concerns. There's also the accessibility concerns as well. Right, so I'll remember those 3 things. Other stuff, definitely straightforward. Fingerprint recognition. Everybody knows what that is. It's a fingerprint. You scan your finger, you get in. There's vein matching. Apparently, now they can find the uniqueness in the vein of your body. The way maybe the blood flow from one location to another, there is some uniqueness into that. Yeah, guys, don't ask me anything about that. But yeah, eventually, right, there is the vein matching there. Facial recognition, very common. Everybody knows about this one. We enroll you're good to go. Retina scan, we're scanning the blood, vessels of your retina, your eye. Iris scan, we're scanning your eye surface. This is easier to scan, but it's more vulnerable. I heard that if we do facial recognition, for example, if you would take like a very PhD image, you present that like a very clear picture of yourself, you present that to the thing, to the camera, it might let you in. Literally ever heard stuff like that. So I'll be careful. Other stuff, you have some behavior technologies that can be used. And this is something that you do. We talked about this, the voice gait. There we go. This right here, you have to remember this for your exam. Gait analysis. This is the way you walk. It's a new one. It's a new one. They introduced this in the 601 exam, the CompTIA 601 exam. So gait analysis, the way you walk, voice recognition. You probably have seen this in the Mission Impossible movies. That's the Benji guy. I don't know if you've seen the Mission Impossible movies, but they use a lot of this stuff in there. A signature recognition. I talked about this. The way you sign, there's some uniqueness in the way you sign. Typing, the speed of which you type, there's some uniqueness in that. Maybe this is here to answer Shayla's question. If you don't want them to take your face or anything like that, maybe you can use one of these. But it's expensive to implement this stuff. All right, other uses then authentication. You can use this for identification purposes as well as continuous authentication and account locking. Yeah. Right. Behavior technology. Just remember gait analysis, maybe voice recognition as well. Any questions for me? All right, so let me check your understanding, then we're going to go to lunch, okay? You guys can read, rotate just like before.
That's it.
After entering a username and password, an administrator must draw a gesture on a touchscreen. Which of the following demonstrates what the administrator is providing?
Something you can do.
All right, we got something you can do. Okay, well, I'll keep it here. Sorry about that, guys. So that's 2FA. And tell me why this is 2FA.
The username and password.
Yes. You got the username and password, then you got the something you can do, which was the drawing of the gesture, right? Next question.
Security engineer needs to implement the following requirements. All layer 2 switches should leverage Active Directory for authentication. All layer 2 switches should use local fallback authentication of Active Directory is offline. All layer 2 switches are not the same and are manufactured by several vendors. Which of the following actions should the engineer take to meet these requirements? Choose 2. I'm going to go out on a limb and say implement TACACS plus.
Yeah.
Yeah, I'll say that one. And I guess radius.
I'd say 1 and 2.
Radius and configure AAA on the switch.
I'll go and say 1 and 4.
Radius and TACACS. All right, cool. Let's see. Yep. So radius it is. Why radius? Because 3 of you picked the radius.
Well, immediately they spoke about the 2 switches. So since radius is actually securing parts of the switch, that's why I chose that.
Isn't it also the multiple people, the multiple vendors?
That's it. That's actually what I was looking for. They say it was manufactured. You mentioned about the switches, Shayla, but they were manufactured by several vendors. It cannot be Cisco. TACACS Plus is Cisco, right? And then Radius and TACACS Plus, they're the same, so you can just pick. This is like literally picking the same thing. But you couldn't go with TACACS Plus because the several vendors manufacture. You're using switches from several vendors. That's one. Another one, I think Shayla picked 2, which was very close. But look, we don't. The Radius is the AAA server, so you don't do that on the switch. Right? What we do, however, is port security, and port security is the 802.1x. 802.1x. I told you to write that down because that will pop up on that exam. So this is where you tell the switch to ask people who they are before you can authenticate them. Right? So right here, they're talking about, oh, if the Active Directory is not working, well, let's have the switch does the magic. Okay. Good stuff. Next question.
A consultant is configuring a vulnerability scan for a large global organization in multiple countries. The consultant will be using a service account to scan systems with administrative privileges on a weekly basis. But there's a concern that hackers could gain access to the account and pivot throughout the global network. Which of the following would be best to help mitigate this concern?
I'm going to go with create one local administrator account and enforce Kerberos authentication.
Okay,
I agree.
got 2 votes,
Same for me.
3 votes. One global account. Nate, anything different?
I'm still just thinking. I don't know. This is a tough one.
Yep.
I feel like it's one of those ones where all of them are a little right.
They say the best.
I mean, if you're waiting on me, I'll just say the same one.
Okay. I was waiting on you. Here we go. Yeah, this one is A.
Okay.
Yeah. Go ahead.
I got to thinking about it after I answered that. It didn't say anything about the ticket based for the Kerberos authentication. So,
Yeah.
yeah.
Oh yeah. So anything ticketing, then you go with Kerberos. But right now, look, they're looking consultants configure vulnerability scanner for a large global organization. So this is within multiple countries. If you create one, like one global administrator account, that's a problem because if they attack this account, now they have access to what? The entire global network. And right here, they said they're using the service account to scan systems within the administrators on a weekly basis. But there's a concern that hackers could gain access to the account and pivot. Pivot, it's going from one computer to another computer from within the same network. That's the concern. So what you're going to do, create different accounts for each region, meaning segmentation. If one region to get attacked, is there a problem? All right. It's not, is there a problem? All right, let them deal with it. Then obviously MFA, right? MFA notification as well. Good stuff. Next question.
A user enters a password to log into a workstation and is then prompted to enter an authentication code. Which of the following MFA factors or attributes are being utilized in the authentication process? Choose 2.
Something you have and something you know.
Something you have and something you know. Where are you? Something you know. There you are.
Agreed.
Agreed. Okay. Everybody agrees?
Yes.
Okay. There we go. Good job. All right. Those who agree, can you tell me why?
Yep. Something you have would be the smart card. Something you know would be the PIN.
Bingo. Good job. Next question.
Which of the following would satisfy three-factor authentication?
Password, hard token, and NFC card.
I'll say password, retina, and NFC.
Right. Password, retina, and NFC. Got passport, token, where are you? And NFC.
I'm going to go with one.
One. Shayla, got a different answer for me?
Oh, no, I was going with number one. I agree with Nate.
Okay. And that one will be. All right, Nate, why one?
Because you've got the password, that's something you know, and then the retina would be the biometric, something you have, and then the NFC is kind of no, that'd be something you have, right? Yeah, something you know, something you are, something you have, right?
Bingo. Yes. Yep. So this was a tricky question because they say three-factor. Remember, anything beyond two is multi-factor, but it can be called a whatever. Three-factor, four-factor, it doesn't matter. Okay. Yo, this is a big one.
An organization is developing an authentication service for use at the entry and exit ports of country borders. The service will use data feeds obtained from passport systems, passenger manifests, and high-definition video feed from CCTV systems that are located at the ports. The service will incorporate machine learning techniques to eliminate biometric enrollment processes while still allowing authorities to identify passengers, which increasing accuracy over time. The more frequent passengers travel, the most accurately the service will identify them. Which of the following biometrics will most likely be used without the need for enrollment? Choose two. I'm going to go with facial and gait.
The face and the gate.
Yeah, I agree with both of those.
Okay.
It doesn't say anything about the way you walk, so I'm gonna. Actually, yes, it does. So let's do gait, and then let's do facial.
Okay. All right. So that better be right. And bingo. Yep. Good job. All right. One of you tell me why gate, why facial.
It's due to the high-definition video feed.
Okay. And when you read close, they talked about there's no enrollment. and they want this thing to improve over time, like the accuracy to improve. So the way people walk, their face, yeah, all these other ones require you to enroll somebody. Right? Yeah. Imagine at the airport and people are making noises. Yeah, it'll be fun. All right, that's it. So not terribly bad, huh? All right, cool stuff. Well, it will get easier as we go, right? The only thing that, the application section is the one that's all God. But the rest of the other ones are straightforward. You'll see. You will prove me wrong. Keep going.
After installing a Windows server, a cybersecurity administrator needs to harden it. Following security best practices, which of the following will achieve the administrator's goal? Choose two.
I would say one of them would be enabling NTLM. No, I take that back. Don't. Never mind.
So no, not that guy. Okay.
I would say storing land hash values.
Storing land hash value, land manager.
And disable guest accounts.
Disable guest.
I'll say disable service accounts and net BIOS over TCP/IP.
Okay, so we got different answers for this one. Let's see. And yep, close enough. Disabling guest accounts and net BIOS. So what does harden something mean? When you're hardening something, what are you exactly doing? Have you guys heard about this word before?
You're making it more secure by disabling some of the features that you're not going to use.
Yes. Yes. Let me tell you a funny thing. Do you know why Microsoft is always get caught up with all the security stuff? It's because they turn on a lot of stuff that you literally don't need, right? That's like that's the difference between Microsoft and Apple, or Microsoft and Linux. Linux, what they do, they remove everything. If you want it, you turn it on by yourself. That's why people are like, oh, it's too hard to use Linux. No, it's not. It just, it's not user friendly, right? All the stuff is not turned on. So like Mike said, hardening something, guys, it's going into removing all the junk, all the stuff you don't need. So every hacker in the world knows that every operating system have a guest account. There's a guest account, but there's also the admin account. Well, part of hardening this is by going in, disabling the guest accounts, or at least renaming the guest accounts, disabling the admin account, or rename it to something else other than admin. NetBIOS, it's very old. So thank you, Net, for saying this one. NetBIOS is very old. It works just like how DNS works. DNS. So it allows you to kind of be able to resolve names and stuff within the same network. Bad, very bad. If this is turned on, you are in big trouble. This actually works the same way MBS. I'm gonna just say this one. This is the message MSB. Okay, there is a message block. All right, I'll come back to it. Anyway, but if this turned on, you're in big trouble. It's the same thing with the NetBIOS. All right, so that's it. We will talk more about that, and definitely enabling NTLM. That would be a bad idea. We talked about NTLM. It's not secure. Turning this on is committing a suicide. And then storing your password as a LAN manager, you don't want to do that. A LAN manager uses NTLM. There's this LAN manager, like literally this, the last part of NTLM stands for LAN manager, that guy, right? So it's the same thing. It's bad news. The password is a 7-character, and 7 character is nothing to the computing power of today. Yeah. And then enabling network sharing, yeah, right. You don't want to do that. Let's keep going. 3.7, 5.3 from that exam objective. All right, so identity management controls. There are different ways that we do these identity management controls. One way being the certificates with the smart cards. We talked about that. This is where it goes to the public key, private key, all that good stuff in between. So this is the most secure of managing your identity, because you're not creating usernames and passwords. You're not doing none of that. Right? You left everything to the computers themselves. So this is the best way to do this stuff. Token and tokenization is also great, because you could give something a token, and that token is going to contain the username and passwords within the token itself. And we will look at the protocols that does this sort of stuff later on today. So this is great if you want to do something like a single sign-on. So Karen will sign in, and then it will give Karen a token, similar to how the ticketing works with the Kerberos. We just finished talking about that. It's the same way that a token works. Username and passwords are within the token. Then whoever asks you, hey, who are you? Well, you provide the token, and then you get in. You don't have to keep signing in again and again and again. Now, if you're going to be doing this, you're going to need an identity provider, right? We talked about this. We talked about the AAAA. That was a lot of A's, but 3 A's. The identification, right. The authentication, authorization, and accounting. That's an identity sort of like provider. That's a system that we can use to provision and manage accounts. We can create accounts with this. We can manage them, we can process the authentication, and so on and so forth. The idea of federated identity management, it's something that I want you to hold on to it. We will come back to it later on. Like there's like a section where we're going to talk about this one. But guys, look, the federated identity is the idea of having multiple systems talk to each other as far as identity and authentication goes, that will not normally talk to each other. Imagine if Google and Microsoft, these are completely 2 different companies, 2 different systems. Imagine if you can sign in into something and then be able to have access to both of these. This thing you're signing into it, it's what we normally call a federated identity management. It allows you to communicate within the 2 different systems that were completely different. Hold on to that as we dive in. So if we're going to be adding people to our environment, right, we will have to bring them in first. So this is HR, yeah, human resources. They do this kind of stuff. You don't. So they might do background check before they hire somebody, absolutely. Now, as far as onboarding goes, usually HR is going to kick in and let us know, hey, we hired this guy. This is their names. This is who they are. IT, we go in, we're going to create their accounts. We're going to provision their accounts. We're going to sort of give them their credentials and give them their laptops and all that good stuff. And if there's some sort of like a training, like security awareness training, we'll provide that to them as well. Any policies that they need to sign that involves IT, the non-disclosure agreement, the different non-disclosure agreement, NDA, or there's the other one, the memorandum of understanding.
Authorized use.
Authorized use. There we go. That's it. Right? That will also need to be signed. Tell you, look, this is this is our laptop, but you can use it for your own stuff. Just don't be visiting these websites. We'll all that it's as part of that onboarding process. All right, remember, onboarding process, we're adding somebody. Offboarding, we're removing them. CompTIA might be asking you that stuff. Onboarding, we're creating their users. Offboarding, we're taking them out. Personal policies and privileged management. So to mitigate insider threats, there's a lot of things we can do. And some of them is what you're looking at here. Remember these things for your exam. These will pop up in a lot of certifications, exams. Like I said, I took the CISSP, all this stuff was all up in there. And I just took it like late last year, like I think it was October. So if somebody decides to become like an insider threat, we are worried about these people doing anything. Well, why don't we go in and do separation of duty? Right? Separation of duty, it's us kind of separating stuff. Right? We're identifying and then we're getting potential single point of a failure. We are separating what people actually do. And once we do that, there is like no single point of a failure, meaning we don't have one person doing everything. Right? It's good to prevent users from getting more privileges than they should have. So in other words, shared authority. I usually tell you, and I think I mentioned this last time, if you can print the check, then you can sign the check, you can give out the check. There's nothing that's going to stop you from giving yourself a bigger check. You can usually just sign yourself a bigger check. So when I do separation of duty, meaning you print the check, another person is going to sign it, and another person is going to give those away. That's separation of duty. Least privileges. It's all about giving somebody permission they need to do their job and nothing less and nothing more. Least privileges. I tell you guys, a lot of the issues in cyber comes because of this right here. Like literally, you see how easy this is? This is just so hard to implement in practice that it's not even funny. There was an attack with Marriott Hotel. If you've ever been into Marriott, please don't stop going over there. Although they've been hacked like every year, I don't think they take security serious. So Marriott Hotel attack in 2020. Come on. So I just want to show you like an example of not doing a list privileges. What could actually mean? There we go. This one right here, right? 5.2 million guest information were compromised. This literally, like, whenever this happened in 2020, it got my attention. I was like, what? Does this stuff actually still happen? And the answer was obviously yes. Let me tell you what happened, and we're going to move on. What am I doing? Dropping all that stuff in the wrong location. There we go. Here we are. So what happened, right? Hackers compromised 2 accounts of Marriott Hotel employees. It's like if I get Michael's account and then Karen's account, just 2 accounts. And then hackers were able to get access to the 5.2 million guest information from just those 2 employees. They obtained 2 login of employees of Marriott. Please read over this if time allows. It's fascinating. From these just 2 accounts, they were able to get access to 5.2 million guest accounts. So the question is, are these 2 employees literally serving all these people? And the answer is no. They're not serving all the 5 million people. So what do they missing here is that list of privileges that we're talking about. It's that just giving somebody the permission they need to do their job and nothing more and nothing less. Eventually, they try to make IT a lot easier for them, giving somebody too much permission and not take that away. Hey, I've been a victim of that myself, so I'm not pointing fingers. Right? When things are not working, it's a lot easier just to make somebody the administrator than go on with your life. But really, that's not a good thing. Job rotation, yes. This is like rotating jobs, and this is great for a lot of reasons because we don't want to depend on anybody really who knows pretty much everything. It's sort of like separation of duty, but a little bit different. Separation of duty is like you have too much power. Job rotation is like, we don't want you to have too much power by knowing everything. If you quit, then we can't function. Besides, we can do job rotation so we can detect insider threat. If we assume you were doing something malicious, well, let's bring in Shayla to do your job for a week, then see what else you've been up to. Job rotation. Okay. And it's not really all bad. It could be good for knowledge transfer as well, right? Me, Karen, we work in the same place. She has to know at least some of what I know, because if I miss, take over. Mandatory vacation, this one is interesting. This is where a company give you 2 weeks of paid. Usually they will give you a paid 2 weeks of paid vacation, but it's mandatory. It's not like, oh, I can't take this. No, you will have to take it. And the other thing is, you can't have any contact with anybody who works at the company within the mandatory vacation. It's like, I can't call Michael at work and like, hey man, I forgot to do this. No. So you're not gonna have any contact with anybody you work with. The beauty of mandatory vacation, though, we were able to detect the insider threat again. Right? A lot of US banks, the United States banks, they do this a lot. If you ever wonder why, banks don't get hacked as often, they have a lot of money. I mean, they do a lot for security. They do security the right way. Just put it that way. And mandatory vacation, it's like you're managing this branch, and all of a sudden they tell you one day out of nowhere, hey, from now on, go take a vacation. We're going to have somebody else coming managing this branch. If you're doing anything illegal, they're going to cut you there. Right? Mandatory vacation. So remember each one of those for your exam. All right, offboarding. It's removing someone from the computer systems. Right? There's really nothing else to talk about here. This is just literally removing the employee. I tell you, companies don't do this. If you're not going to remove them, at least disable their account, especially if there are IT. I tell you guys, IT, we have too much power, let alone cybersecurity. I remember when I was working for THT, I could read the CEO email. Like, who else have that kind of power in an organization? Just IT people. So whenever we fire an IT person, let's remove their account. Like if they say 10, like 4 p.m., that account needs to be disabled by 4 p.m. Right? They have too much power. They have access to a little bit too much. Right? Offboarding, remove them. Account, security account types and credential management. So standard users, these are different account types that we can create within the environment. Standard users, these are regular users. They have limited access, limited privileges. Usually we want the people that are working for us to have a standard account. Actually, Microsoft only have 2. They have standard account, and then they have the administrator account. These are the most common ones. Obviously, they do have the guest accounts also, but most of the time, nobody really uses this. So you just maybe turn this thing off, right? Because nobody really uses it. But standard account, this is why you want to be using this right here. If anybody works for the company, give them this access. And if they want to do anything that that require an elevated privileges, then they need to ask IT, and they need to sort of, with IT involved, because within a standard account, they cannot change. Yeah, should not be able to change the system config, meaning you cannot install a tool, you can't remove stuff, you can't. There's a lot of things you cannot do. You can only just use what you're given. Okay. When I was working for Virginia College as a system administrator, this is what they had us to do. So basically, day to day, we will use a standard account. We were admin. We were just IT admin. Day to day, we will use just the admin. And from time to time, we will use the administrator whenever we want to make changes to the account, to the system, to the computer. And I tell you, from a security perspective, this is a really good practice. When a hacker hack your account and they hack this thing, yeah, I mean, that's not a good thing, but that's okay. They also have a limited access to certain things. But if they hack the admin account, then you're in big trouble. And whenever attackers get you into your environment, they want that admin access. So on Windows, this is how it is. On Linux, let me bring up my Linux box. Let me show you this. On Linux, we call this a sudo. Type in sudo, but let me do Kali. So I'm signing in right now. I am signing in as my regular personnel, like Kali, and I can go to the terminal here and you'll be able to see it in a second. Come on. There we go. Come on. There we go. That's it. All right, make that a little bit bigger for you. Make that big. There we go. So you can see username Kali, right? This is the person who's using this. So if I do print working directory, you can see I am Kali. I am Kali. So what if I want to become the admin? Well, I just need to do sudo su, and I can put a dash if I wanted to. But this is literally like switch user. Su means a switch user with a dot, meaning take me home. So I do that, they're gonna ask me, who are you? I put in the password. Well, it looks like I typed in the wrong password there. There we go. Now I became root. Root on Linux is the equivalent of the administrator on Windows. You see how literally they put this in red? Because it's very dangerous to use the Linux as root. I can screw things up a lot quicker with root. For example, I can access the password file that we were talking about a minute ago. So if I do cat and I go to the extra, etc., and then go to the shadow, look at that. I can see, oh, we have a username known as Kali, and this is the hash of Kali. We have another username of, if I go up, root is always at the top. We have a username of root, and this is the hash of root. If I was signing as Kali, I was not going to have access to this. Okay, so basically, I'm telling you this to tell you that whenever you go to work, use the. It's not a convenient, but sort of preach the idea of just use less privileges accounts. Okay. Security group based privileges. Eventually, on the bigger companies, we want to put people into different groups. So we can so it will be a lot easier for us to assign permission. So user assigned privileges are okay, but they become unmanageable if number of users goes up, which is sort of makes sense. It's okay if you have 5 people, but if you have 100, yeah, good luck, doing that manually to one person. So what we do, we use a technology known as Active Directory. You have heard about AD? Active Directory, some of you have, good. So Active Directory with the help from its little brother known as a GPO. So you ever have heard about GPO? GPO, that's a group policy. Right. Cool. So these are the technology that we use to do this sort of stuff. Group-based privileges. Basically, it's like a role-based, literally. I hate this, like group-based. It's like role-based. We create a role. We say everybody are in sales. This is the sales department. So we create a group known as the sales. Then we add salespeople into this group. Then we can assign permission and privileges to the group instead of to the individual. Okay. That's how they do it in the real world. So users are going to inherit the permissions that get assigned to the group as well. All right, I've mentioned this already. So the administrator or root accounts, guys, you should never use these unless you are making a change to a system. And as soon as you finish, go back to the regular account, right? They attack you, you were signing as the admin, they also have access to the admin account, right? Then you have your service accounts. Service accounts are accounts of services that are within your environment. These are not users' account. Imagine if you have like a SQL server, SQL server. Well, you have a service account of that SQL server. We usually don't see this. We usually don't look at it when this account is being used, but this is used behind the scene. So there are ways of securing this one as well. It gets complex. We're not going to go there. But within Windows, you have a system, local, network. There are a bunch of services accounts operating on these places. They're really good to help you run services and authenticate services behind the scene. The biggest issue with the service accounts, a bunch of them use the default stuff, whatever that is, default stuff. So sometime when something is critical, we might want to go into the service account and then make changes to the way it uses the service to authenticate. Okay. Then you have your shared generic accounts. If you have a shared account, this goes against everything we do in cybersecurity. All right, shared accounts, they're not good. Because how are you going to hold somebody accountable when this account is used by 10 people? Now, you can't. You can just be like, oh, Karen did it. And it's like, it's me, and then there's 10 more, right, using the same account. So we don't know for sure. So we don't want any shared accounts. We should discourage using these or disable them if we can. Generic accounts, these are like the service accounts. These are like the accounts that are created automatically. We want to change the default passwords for these, right? If we can. Risks from shared or in the generic accounts, it really breaks the principle of non-repudiation. What is non-repudiation, anybody? What is non-repudiation?
It's like you're valid, right?
It's like you're valid. I didn't hear the
Yeah.
last part.
Yeah.
Anybody else want to chime in?
Whereas subjects can't deny creating or modifying data.
That's it. You cannot deny taking some sort of action, right? So yeah, shared accounts breaks that because it's 10 of us. Now I can't deny it. You're like, how do you know it's me? There's 10 more using this account, right? So you see how these little keywords keeps on coming back and coming back? That's because they're going to be on that exam. All right, good stuff. Okay, going. Secure shell keys and third-party credentials. All right, what if we have third-party credentials, or what if we are accessing the cloud? People now are working from home, right? They want to remote into AWS from home. What can we do? Well, first of all, we can use cryptography. Remember, cryptography is what secures the internet, is what secures everything. All those keys, the private, public keys and stuff. So one of the protocol we can use is SSH. This stands for secure shell, right? This one is used to remote into Linux computers. I'm going to say this Linux. What is a port number associated with SSH? Anybody?
$22.
22. Thank you. Good job. 22. So that's SSH. Again, remoting into Linux computer. The equivalent of SSH on Windows is R what?
P.
RDP. RDP. So we talked about RDP. I told you RDP is used to remote into Windows machine. Well, this is another way of a security remoting into a Linux machine using SSH, secure shell. It's 3389. That's the protocol number for RDP. I'm writing these out. Hopefully you're taking note on these because these are going to be on that exam. And the other thing, this was on one of my interview. I went to apply for a job and they're like, okay, well, imagine you are working with a Windows machine, but you want to remote it into a Linux machine securely. How would you do that on a Windows machine? And the answer was PuTTY. Although SSH is used on Linux, we can use a program called PuTTY. I think I have it here installed. Yeah, there we go. PuTTY, this little guy that you see here. And I want to just highlight a few things. You can see, first of all, the port number is what? 22. Then you can see it's literally saying I'm going to be connecting using SSH. So I'm on Windows right now. This program is on Windows right now, but I want to be able to SSH into a Linux box, into a Linux machine. I can use this guy. Now, the beauty of PuTTY, it allows me to do what they're talking about here, keys. So I can go to the SSH, and I can go to the OAuth. There we go. This right here, SSH keys. And I can bring in my private key right there. I click on that. I've generated my private key. I bring that in. Then it's going to allow me to authenticate with whoever I want to authenticate to without typing in the password, which is what they're talking about here. That's the best way of authenticating, the best way of doing this. So if we're going to be communicating with the third parties like cloud providers and stuff like that, passwords are weak. We want to set up SSH using keys, private and public keys, and then authenticate that way. Remember, for exam, SSH is 22 port number. And the equivalent of that on Windows is RDP, Remote Desktop Protocol. And that is port 3389. Good stuff. Any questions for me? All right, stay with me. Topic B, account policies, piece of papers. So 3.7 from that exam objective. All right, account attributes and access policies. So you got account attributes, which involves different things, including security ID. Literally every account on your Windows environment must have a security ID. We're not gonna go there. There's the account names, obviously. And there's the in-app settings. There is the extended profile attributes. There's like, these are just different things that identify the account, basically. And some of the policies, including the permissions, the access rights, the group policy. This is the Active Directory group policy objective, which we use this to assign permissions, to assign policies to different things. It could be user, it could be accounts, it could be printers, it could be computers, it could be literally anything. There's thousands of policies within group policy that we can use. And then I will show you some of that as well later on. Right. Personal policy, like I said, so you want to have some policies, and these are like technical policies. I say piece of paper, but literally these are technical policies. These are the things that we put in place that are implemented by technology. So we have these right here, policies that goes in and tell us the length of the password, the complexity, right? Character combination, special character, all that good stuff. Aging is like how long you're gonna keep this password for. Companies usually do 90 days, which a lot of companies are running away from this. Because what they did 90 days for was based on the seasons, so that they can create passwords like summer 2020, or winter 2022. You just look outside, oh, it's summer, so my password must be summer 2022. So that was, the 90-day policy. A lot of companies are running away from this one. But so this is how long, you got to have your password until you can change it. Password history is interesting. This is how many passwords you have to type in before you can reuse the old passwords. So how many you have to remember. So some companies might have 5. They have 5, that means you have to use a unique 5 passwords before you can go back to that very first one you started with. And all of these are policies within group policy. NIST does have some guidelines and guidance regarding this. Right? And then get your password hint. So within group policy, let me show you this. If I go to my account here and go to group policy, every Windows machine have this. It's not just mine. So you have your local group policy. This is different than the big guy, the big policy. Make this a little bit bigger for you. Give me fire. Come on. There we go. So this is the policy here. So I can go to user, Windows. I'm trying to see password policy. Ooh. So this is what I was telling you. They got like thousands of these. Oh, is that within the software? No. Windows settings. Ah, all right. Well, I can't remember where they're located. Oh, there we go. Account policies, then password policy. So this is what we are talking about right now, this right here. So these are the policy. If I were to turn these on, some of these on, then it's going to reinforce what we're talking about. So enforce password history. As you can see, I have a 0 here. If I were to double click on that and just say 5, for example, then it's going to remember the last 5 passwords, meaning if I try to reuse my last password, it's not going to work. And then you have the maximum password age, meaning before you can change this password, how old this password have to be. 42 days. I don't know who put that there. You have the minimum password age. What is the minimum? Then you have the minimum password length. This is actually the good stuff. This right here. I recommend your password to be at least 12 character. If you have a password that's less than 12 character, please, you're in cybersecurity. Let's start changing that. Let's start changing that because your 8 character, your 7 characters is no longer good. So 12 character, if you can do more than this, that's better. So I like this one specifically. Length, right? You can define the length of the password. The complexity, you can turn this on, and that means they're going to require special characters and numeric and all that good stuff. So you got it. So these are the policies that we're talking about. This is the local group policy, but in an actual environment, you have the group policy for Active Directory, and it's amazing. Way better than this. Okay, so account restrictions. You have people logging in from their network. So we can give them access or deny them access based on where they're located on the network. It could be from the virtual LAN, VLANs, from based on where they are, where their IP address is connecting from, right? Again, they're on the network. It could be remote. It could be like they're on the network. We restrict them based on where they are. We could restrict them based on location based, not just on the network, but based on where they are globally. This is the geofencing and geotagging, or also geolocation. This is the GPS, right? So geofencing, it's like where they're located. It's like, and I did this with the Trenton Health team. This was in New Jersey. That's where the company was. So when the pandemic happened, we didn't want people to just be on vacation and then lying to everybody that we are working hard. Guess what? We implemented geofencing. If you are in Jersey, you had to stay in Jersey. You couldn't carry that laptop outside of Jersey. It's not going to let you authenticate. It was fun. A lot of people were pissed off. They're like, hey, is there a way around this thing? Like, I don't know. You tell me, right? And then geotagging, it's like a tag that gets attached to it. This is the location stuff, guys. Like I said, they keep watching what you're doing. And if you are on the clock and they pay you every hour you doing this, yeah, right. Right. Time-based restrictions. I had fun with this in in college, early in college, and this is literally a feature you do in Active Directory. You can say, you are not allowed to authenticate until it's 8 a.m. Yeah, 8 a.m. They showed up, they try to authenticate, it's not gonna let them authenticate. This is actually really good because usually hackers, they try to hack your account, they try to hack your environment when people are, they're gone. So if somebody's trying to authenticate at 2 a.m. in the morning, you're like, you know, what's going on here? If we have this thing turned on, it's not going to let them sign in. But again, if people are now working from home, you can't just turn this thing on because it might be 2 a.m., but they might want to be doing something. Never know. All right, so accounts audit. Basically, this is detecting, keeping track of how people are using these accounts. So we're going in and we're auditing it. We're trying to see if we're giving people too much permission that they need. We're trying to see some failed login. This is actually a really classic attack here. Whenever you see so much failed attempt login, yeah, you should pay attention to that. And this is how it looks like. Literally, it's going to go in and tell you audit, failure, and it tell you like who tried to log in and what they try to log into and all that stuff. This doesn't look nice. There's a system we use, is called Sysmon. There you go. Yeah, Sysmon. Write that down, Sysmon. We're not going to talk about Sysmon in this class. It's a little bit advanced. But Sysmon, it's going to clean up these logs a little bit better, so you will see it better. It will tell you who's logging in, who they're accessing, and all that stuff. And we talked about all this. Account permissions. Again, guys, look, we got to manage these accounts right. We don't want to be like the Marriott Hotel, giving people too much permissions, right? So impact of improperly configured accounts, it could be insufficient permission, or it could be unnecessary permission. That's why we have to audit these accounts to determine if people need an extra permission or if we should take that away. Usage audit, we're going in, we're auditing how they're using that, the account. That's why I said, if you are working for a company, then you are using their computer, don't do anything you don't want them to see, because they basically see everything, right? So don't go over there be like, oh, I'm looking for a new job, and be like, there was this lady I was working with, and we're IT, so she was always on LinkedIn and just looking for jobs and applying. And this one day we were working from home, we're trying to remote into her computer to be able to do the updates and all that good stuff. And then all that stuff popped up. But what's funny, she was still there. So she was like, is this you in my computer? I'm like, yeah, but I didn't see anything, right? But yeah, so really, computers logs everything that is happening, guys. And usually the best way, really good security people go back and audit that stuff. They go back and ask the computers, okay, what did you see? Did anybody was abusing you? Did you visit anything you shouldn't be visiting, right? What did the antivirus program says, right? What did the host firewall says? This is the Windows Defender. If you guys have heard about Windows Defender, host-based firewall. On Linux, we call this guy IP table. We will talk about this. I have a section on firewalls. It's coming up. So hold on to those as we get there. All right, account lockout. This is pretty good stuff. If somebody mistyped their password 3 times, let's lock their account. Right? What will the attacker do to sort of to not get restricted with this policy here? What kind of attack that the attacker can do for this not to work for them?
A brute force?
A brute force of what? Of the username or the password?
The username.
The username. Love it. So we usually call that password spraying. We talked about that. That's why I brought it up, to see if you were with me. And I badly asked that question. Wasn't a good way of asking. So password spraying, right? They're going in, they're using the same password, but they're trying different usernames. That's gonna kick this thing into it. All right, so disablement. Disable the account until they call the help desk. It's another good thing to do. Any questions for me? No, just taking a lot of notes. Stay with me. It's not hard, I believe. It's just a lot. All right. 8C, implement authorization solution. Authorization. What is an authorization? Anybody?
It's like an approval.
Approval. What are you allowed to do? Thank you. I welcome you to my house. You don't have access to everything. 2.4, 3.8 from that exam objective. So let's talk about this. And these you have to remember for that exam. Oh my God. There is this these are models. These are models. And let's just talk about it. There's one known as discretionary access control. All right, discretionary access control, also known as a DAC. This is, whenever you see DAC, I want to start thinking about ownership. All right. This is, you own something, then you're giving access to someone, but you're the owner of that thing. So this is how literally like your Microsoft Windows, it's based on the DAC, the DAC model. Because within Microsoft, you will create a folder. You're the owner of that folder. Then you can decide who to give permission to. I'd be like, hey, this is my folder. I added stuff here. Then let me give access to, Karen. Let me give access to Shayla. Give access to Nate. That's the DAC model. It's based on ownership. You own this stuff. You're going to create what we normally call the access control list, ACLs. where you specifically said, okay, I am allowing this person to access this folder. Your question might be, okay, what is the issue with this? The issue with this, it doesn't scale very well. It's not scalable. It's okay if you have 5 employees, but what if you have 20? What if you have 30, 100, 200, 1,000? A dark model becomes useless. That's where the role-based, it's gonna kick in. Right? Role-based is gonna kick in. This is a role-based access control, or RBAC. It's non-discretionary, meaning you don't own this stuff. It's more centralized, and you have a central location, and then everybody can access that thing based on their roles. This is just like the group stuff we talked about, like the group account thing we just finished talking about. It's the same thing. So permissions are given out based on the roles, and the user can only inherit permissions that are within those roles. So this is really good. This is scalable. We can just add, we have 50 employees in sales, we just dump them into the same group, and then we give that group a permission. Simple. Remember DAC and RBAC for your exam. Any questions with these two? You guys are taking a lot of notes. All right. Well, I'm hoping you're not writing what's on my slides here. Hopefully, sort of like summarizing what I'm saying, what's on my slides. You guys have access to the same slides. So I won't be writing this, just sort of what you're understanding based on me talking all this stuff. File system security. So whenever you are using the DAC model, the discretionary access control, you will have to give people permission. That's known as ACL, access control list. The ACL, you will use that using ACE. Actually, I hate talking about this in the context of a DAC, because once we talk about firewalls, I'm going to come back to ACL, and I'm going to need you to forget what I just said right now. All right, so let me just ACE is this thing that you're looking at right here, like this thing right here. This is the access control entry from Microsoft, right? And as far as ACL, please just forget that I even say this one. I'm going to tell you what it is from router's perspective, not from what this Microsoft wants you to know. What I want to talk about, however, is this right here, the Linux permissions. You got to understand this, because this is the security of Linux. And let me bring up my Linux so I can show you this in the real world. All right, cool. Let me go here. There we go. Or if I clear my screen by typing in clear, it's how Linux is literally you're talking the English language. I say clear, it's going to clear my screen. And then I can create a folder. Let me say ls. But there's some stuff. Let me keep that. Let me keep that. So let me create a file. Let me call this touch. Touch is a way of creating something. I'm going to touch. Well, I'm just say Francois.txt. If I ls again, now I have a Francois.txt. Right? It's in here. Just create a text. Here's the thing. I can, if I want to see the permission within Linux, I can ls. This is ls is list. It's literally like list everything that's right here right now. If I do ls-l, I'm like, okay, well, I want you to show me everything that's in here, but list all the permissions and everything. Let me make this a little bit bigger. And you see on the left-hand side how there's these RWR ... stuff. That's what you see right here. All right, there's the R, there's the W, there's the X. All right, same thing that we see here. So, well, it's actually not a good presentation. Let me go back to the Kali, and then ls-l. So you see, desktops and all that good stuff. This is better than that stuff. So right here, you can see I have something as Demi, and it is the desktop. This is the folders, and there is the private keys that I've created before. There's this guy right here. And these on the left-hand side, there are the permissions. So here is how the permission works in Linux. There's read, there's write, there's execute. Read, write, execute. Read is 4, write is 2, execute is 1. What does this equal to if you add them up?
7.
7. Thank you. So each one of these, right? The RWX, that's 7. There's another RWX, that's another 7. There's another RWX, that's another 7. And then here's another thing you need to remember. The first RWX belongs to the user. User being the person who is signed in. So that's their permission to this file, to this folder, to this whatever this thing is. The second permission, the second thing that you're looking at right there, belongs to the group. The group that this sign-in user happened to be a member of. All right, so that's the second one. The last one, this last RWX, belongs to everyone. So everyone that ever uses this computer, well, they have access, that's some permission there. That's why whenever you see these other things like these right here, there's only read and read. There's no write or execute in any of them. Right? So your question might be, okay, well, then what does this chmod thing has to do? Or how do I change this permission within Linux? And that's where that chmod comes in. So let's do that quickly. Let's create something. Let's touch with the screen. Let's touch Francois text again. If I do ls, now there's Francois here. If I do ls-l, we can see Francois is right here, but I want you to pay attention to the Francois permission. That right there. What does he have? Read, write for himself. He doesn't have any execute because this is not an executable file. There is read for the group he belongs in. There is the read for everyone else who uses this machine. So everyone else who uses this machine can read this file. So the way you change the permission is by typing in chmod. Chmod stands for change module. Chmod, then you can use the number. That's the beauty. So you can use the symbol if you wanted to, read, write, execute, or you can use the number. I tend to just use numbers. So what we can do, we can say, hey, chmod 777, 777. Then we can just say to Francois. Oops, I'm gonna make a space here. To Francois dot text. Tell me what's gonna happen with 777. What do you think is gonna happen?
You're gonna have everything.
Absolutely. So let's verify that. I hit enter. Let's verify that. ls-l again. Now take a look at Francois now. You see the permissions? Now everything is turned on. Well, what if we didn't want that? Well, we can go back to Francois again, and we can change this. We can just say, what if we say 651, for example? I hit enter. I do ls again, bring that stuff back. Now here's the Francois permission. There's a read, write, and there's like again, I play around with this and all that good stuff. So this, my friends, this is all the security you need to know about Linux. Literally, it's this easy. All right, that's it. All right, well, let me get out of there. So the only thing you probably need to remember for that exam is Shmod. They might ask you, okay, which one of the following tool would you use to change permission on Linux? Shmod. All right, mandatory and attribute-based access control. Talk about this before we go to a break. All right, mandatory. I told you that DOC, the discretionary access control, was based on ownership. Like, I own the file, I can give a permission to anybody that I want. Here is the thing about mandatory. Mandatory, it's based on labels. There's just one thing you need to write it down, is this right here. It's based on labels. We have files, we have these things, we can label them. This is where all the military stuff comes in. Top secret, secret, need to know, public, all that stuff. That's all math, right? You don't own any of this stuff, but you are given permission based on the labels. Labels. So that's mandatory. That's mandatory access control. I don't know if you've seen, but we probably have had a 3 Macs already. Like literally things that are known as Mac. It's 3 of them. I want you to pay attention. There's the first Mac of a media access control. I want you to differentiating this. Some students get confused with this. This is the media access control. This is what comes with your NIC card, your network interface card, right? This is the MAC address on your network interface card. There was the other MAC that we saw with HMAC. That's another one. That was the, I can't remember what that thing stands for now that I'm here. But and then now there is this MAC. So I would not worry about the HMAC maybe, but you need to understand the difference between mandatory access control and the media access control. They're completely 2 different things. Whenever you see a word that says label on that exam, they're talking about this, right? Whenever you see a word that is ownership on that exam, they're talking about discretionary, DAC, discretionary access control. Okay. All right, attribute-based access control. This is the attribute ABAC. So the access decision is based on the combination of the subject and the object and everything in between. This is the most complicated of them all, right? It's also known as a conditional access. And some people have a fancy word for this now. I don't know, you probably have heard of this one because this one is everywhere. It's known as a zero trust. You guys have heard about zero trust, right? Trust but verify. I usually just call this attribute-based access control because what happened with attribute-based, before we authenticate you or before we give you access to anything, we give you access based on different attributes. For example, where are you connecting from? What is the MAC address that you're using? Which computer are you using? Which IP address you're using? So there's a bunch of different attributes that gets incorporated before we give you access to certain things. And that's the idea of zero trust. If you know what that is clear, if not, I will talk about that later on. So this is the most complicated one, ABAC, to implement. This is mandatory. It's very common in military, with the security clearance and the need to know, right? Based on the labels and stuff. Then a DAC is what we have in our computer. Like if you have a Windows machine, you are using DAC right now, the discretionary access control. Cool. Then you have a rule-based access control, and this is another one that's confusing. I would not worry about this one because this is the other RBAC. I know, RBAC. I've told you there's another RBAC early. And the other RBAC was the role-based, not rule-based, it was role-based. We give you access based on your role within the company. This right here is rule-based. It's a system kind of a control. Right? This is where the system goes in and like, oh, wait a minute. Right? You're not supposed to be installing this thing. Right? That's a rule-based. You trigger some rules within the operating system, then the operating system might bring up the AUC. This is the user account control, where he asks you, hey, who are you? What's your username? What's your password? AUC, let me show you what AUC is. So you can sort of remember what rule-based it's all about. It's another long chapter. Probably need to move a little bit quicker. UAC, why I keep saying AUC? This thing, if you've ever tried to do something, then this thing pops up. Maybe when you try to install a program and there's the user account control thing pops up. This is a system rule-based. Right? That thing right there. It's a Microsoft technology. All right, so let me do these three, then we're gonna go to a break. All right, another one we have here is directory services. This is all about Active Directory. AD, Active Directory. Active Directory is just a database of a bunch of stuff, including users, computers, printers, security groups, roles, you name it. Everything is within the Active Directory. It's a database of a bunch of stuff. Now, within this database, we have to access it. So there is that ACL, the access control list of who has access to what, who is in what group, and what do they have access to. They have access to this printer. Like, all that stuff is within the Active Directory. I usually jokingly tell people that this is probably the technology that made Bill Gates the richest man alive. Because I cannot imagine any company running without Active Directory. It is just a database of everything within your environment. So how do you access Active Directory? You use what we normally call LDAP. LDAP, it's a protocol, guys, it's a protocol. And it's based on the X500. This is different than the X509. X509 was the cryptography stuff, the certificate. This is the X.500, which is LDAP, the lightweight directory access protocol, which is used to access Active Directory. I would not worry about this as much. The only thing probably I will worry about is if they ask you, okay, which one of the following protocol you will use to access Active Directory, then you will, LDAP. Right? If they brought any of that up, really, that's very specific. And the LDAP is not secure, but like I said, always we have secure version of this. So there's LDAP S, which is the security version of LDAP. Yeah. Federation and attestation. So federated identity access management, I mentioned this one earlier. So networks under separate administrative controls share users. That's important for you to know. So federated environment is when we're trying to connecting users' accounts across the systems of multiple enterprises. I will probably write that down. Right? Multiple companies that are completely different, but we want to share the users between the two. So we have to federate that identity and access management. So what happened here is that the user will be authenticated to the identity provider, and the identity provider will validate who the user is. Now the user will have access between the companies, the organizations as well. Okay. Federation. Remember that one for exam. Last one that might a little bit confuse you, we'll see how it goes, is the security attestation markup language, SAML. SAML. This one, it's a single sign-on. That's one of those things I want you to write it down. It's a single sign-on. It's a single sign-on, but for back-end applications. Single sign-on for back-end applications. Right? So it's like a standardized way to tell external applications and services that a user is who they say they are. So you can use a SAML to authenticate, but you can authenticate just into one application, and then you get access to different back-end applications. I keep saying back-end, but what is this back-end stuff? Well, imagine you authenticate into your Wells Fargo bank account. Bank. Imagine if Wells Fargo is connected to your retirement account, right? Your 401k. Imagine if Wells Fargo is also connected to your just say Roth Roth RIA, something like that, right? One of those investment accounts. Well, once you've authenticated within your bank, if they're using SAML, there will be just a little thing you click on, you click on their icon, and then it will take you to that retirement account. You will not have to type in your username and password again. If that had ever happened to anybody, that's what we're talking about here. Right? If like a lot of the time this happened within ADP, the human resource application that they use. I would have went there right now to show you this because this is hard to understand unless you have that. Oh, actually, there's a good videos about this. Let me share that with you. You guys are going to break after this. Looks like we might just end up finishing just this chapter and that's it. All right. SAML. There is a video about this guy. His name is Ned. If you're curious about this, I'll watch this video. I can't tell you how many times I've watched it, and I'm still confused after watching the video. This guy is good. I like this guy, but I like this other guy better. Don't tell me they deleted the video. Ah, come on. Was from Opera. Oh, there we go. This gentleman right here.
Using information about them online. So my goal with this talk is to just cut through kind of the jargon, cut through the technical speak, and try to explain how these protocols work just in quick. Try to just make it really easy to understand. And we're going to get into some of the technical stuff today because we have a little bit of extra time. But
by far, this is the only explanation that I've seen on SAML, OpenID, OAuth that sort of makes sense. So if you're curious, the exam doesn't really dive that deep into any of these. If you're curious after this lesson, I'll put the link in there. Please check that gentleman out. He did a fantastic job of explaining this stuff. But so back to what I was saying. So you got the backend applications. You're trying to do single sign-on on those. SAML is the thing that they use, is the protocol that they use. It's used to implement secure authentication to a third party. That's the keyword, third-party websites without the user's passwords. That's why it's a single sign-on. If I were you to write that down as well, used to implement secure authentication to third parties websites without the user to re-enter in the password. If you are wondering, so how does this, SAML does this? It uses XML. This is the extensible markup language. Again, it's used to store stuff, there will be basically a token that's going to get created. And that token is what's going to be shared between the two different websites in the backend applications that we're talking about. What are they going to use for communication purposes? Obviously, HTTPS. It has to be HTTPS because this is insanely secure, very secure. SOAP is another way that they can use to communicate. So SOAP is the simple object access protocol. It's just another way of passing information between applications in the XML format. So this is like a newer way of doing XML, like a newer way. And this is also secure. Yeah. All right. So I'm going to pause here. Actually, let me just ask you this. Do you have any questions on this? No. All right. Last thing that I'm going to give you 10 minutes. It's OAuth. OAuth is a user-centric federated services better suited for consumer websites. So here is the thing. SAML is really good for back-end stuff, for like companies communicating with other companies. But what about you trying to connect, Facebook to your website, a consumer-facing website? Then you can use OAuth. And OAuth is like a framework, right? That comes with a bunch of API. API is the application programming interface. API is a way of one application talking to another application. So they can use RESTful API, this guy right here, and then, a bunch of other stuff as well. So there is OAuth 2 version, 2.0. This one provides authorization. That's the keyword. If I were to write anything down, I'll write it this one right here, authorization, between those web applications. And I will show you this. Have you ever been to a website and then there's the little thing that says sign in with Google, sign in with Microsoft account, and sign in with Facebook account? Yeah, that's what we're talking about here. That's OAuth, right? It's OAuth and OpenID Connect. I haven't got to that one yet, but that's what we're talking about right now. So OAuth handles the authorization, and then OpenID handles the authentication. Let me see if the OpenID is here. Yeah, there we go. So OpenID Connect works with OAuth 2, which allows clients to verify the identity. So the authentication process gets handled by OpenID. They work together, by the way. They work together. So OpenID handles the authentication. It's going to ask you, who are you? This is me, blah, blah, blah. Then OAuth is going to handle the authentication. I mixed them up. OpenID handles the authentication of asking you, who are you? Then OAuth handles the authorization. What are you authorized to do? And a great example, then we'll go into lunch, will be these guys. I'll go to Udemy. If you've never heard about Udemy, you should. It's a fantastic company for you to basically learn a lot of the stuff that I'm teaching you on your own, if you enjoy that kind of stuff. So if you go to Udemy and click on sign in, right? There you go. This is it. See right here where it says authenticate, log in with Google, Facebook, Apple, all that stuff. This is OpenID Connect. So as soon as I click on this one, OpenID is going to go in and be like, okay, well, who are you? Like, you want to do this with Google, who are you? Tell me what's your username. And I don't know if you can see it though in the browser there. Let me magnify this. There is that guy. So I don't know if you can see it in the browser there, but do you see right there where it says OAuth 2, right? Literally in the URL of Google. That's what is happening. OpenID is going to Google. Hey, Google, please authenticate this guy. Ask him, Google is the identity provider, and I'm just trying to authenticate it to Udemy. So it's going in, it's like, okay, well, let's authenticate this guy, who he is. After I put in my username and password, things get kicked to OAuth. Now OAuth is going to be like, okay, well, you've authenticated. Now what are you authorized to do? So the biggest takeaway from this conversation, the biggest takeaway I want you to remember is this. And I'm trying my very best here to make it a little bit easier for you to remember this. So the biggest thing is, remember, OpenID is for authentication, right? It goes in, it does the identification, the authentication, all that good stuff. And then OAuth goes in, do the authentication. Excuse me. OAuth goes in to do the authorization. Okay, if you can remember those, that would be great. Just remember, whenever they're talking about OAuth, OpenID, it's a sign in with Google, sign in with Facebook, all that good stuff. There is a JSON token that gets passed. I didn't get into that, but usually Udemy was asking to Google, let's authenticate this guy. Once I authenticate, there's a token that gets sent back to Udemy. That guy in the video is going to explain way better if you get a chance to watch that. Okay. But for the sake of the exam, because this is all application stuff, we don't do this in cybersecurity, guys, unless you are specifically dealing with the applications. If you're a programmer, you want to secure applications, then you deal with this. If you don't secure applications, you don't get to see this. Okay. All right, let's take a 10-minute. Keeping you here for too long. Then we'll finish this section. I'll see you guys in 10. Let's keep going. Cool. Topic D, explain the importance of personal policies. But you all can see me, see the screen okay and hear me okay? And okay, all right. Importance of personal policies. Let's see what's going on. 5.3 from that exam objective is what we're talking about. So personal policies. There is the acceptable use. This is what I was looking for early on here. When we hire somebody, there is what's acceptable for them to do with our computer, right? Our computer, our software, as their employers. These are rules. Right? We're going to have them sign this piece of paper that says you're allowed to do this, but you're not allowed to do this other thing. Rules of behavior and the social media analysis, you'll be surprised what people share on social media about their job. Right? And all that stuff, hackers can do reconnaissance, recon. We talked about recon, and to find out that information easily. So I don't like companies spying on their employees on social media, but employees should be trained on what to share, not to share on social media. Use of personal owned devices, BYOD, right? BYOD, bring your own devices. A lot of companies are doing this. I will be sharing, we have a chapter that talks about mobile devices. I will come back to this. But companies are trying to save money. Instead of them buying you the hardware, they want you to bring your own. It sounds all right, but it's not a good thing. It's a nightmare from cybersecurity people. Then you have your shadow IT. This is when the regular users are trying to do what IT people do. They're shadowing the IT team. Right? It's not a good thing, actually. It's a bad thing. They're installing tools, but they have no clue what they're supposed to be installing. Clean desk. Have anybody worked in an environment where they enforce clean desk policies? How was it? Did like a middle manager walk around and be like, remove the sticky notes?
No, it's kind of on an honor system, but basically people are watching, but they're not saying anything. But if it's a violation, they'll let you know.
Gotcha.
If they see it.
If they see it, okay. but you're not storing any passwords on sticky notes and put them under your keyboard and
But that happens.
okay. All right, so companies will have policies about all these things. User and role-based training, impacts and risk from untrained users. Remember, guys, it's still that 80% of all the attack starts with social engineering. Guess who they're social engineering? Regular users, untrained users. Security is not a job of just you. Besides, I want you to don't come into this industry thinking you're gonna be securing everybody. It doesn't work like that. I know it's a team sport. You know, security is a team sport. It involves everybody. Everybody have to do their job to secure the company. Right? So topics for security awareness, including, you know, talking about the policies, talking about how we're going to respond to any incidents, the procedures, how we need to be handling the data, how we should be managing the passwords. Obviously, be aware of social engineering. This one is huge. Be aware of malicious activity on your machine. Be aware of a browser acting up or receiving emails with links, right? All that stuff. They have to be trained. So this is sort of like a general training for everybody. If we want to be effective, we can do role-based training. And on these exams, they're going to ask you, why should a company do this? This is to change behavior. This is to change how people behave. You're not training them for them to become security professionals. No, you're training them to sort of change the way they see an email. As soon as they see the email, they start thinking, okay, well, I should be careful with this thing. You're trying to change how they behave. So it could be role-based training, because obviously this is boring for people who are not into security. They don't like to do this stuff, guys. I'll be honest. I've been in an environment where the manager had to force us to do the training physically instead of those automated training where they receive like some kind of email and they have to complete the training. They never do that. And if they do that, they're not paying attention, right? So got to figure out a way of motivating them. What I've seen the companies do, they're going to do some sort of like a diversify this. They're going to have some sort of like a gamification. We're like, okay, well, Mike, if you win, you will get this laptop, right? If you don't click on this phishing email, they will use, okay, if this team doesn't do this, they're going to get raised. If this other team doesn't do this, so basically trying to motivate you into doing this sort of stuff. Okay, so there's that. There's capture the flag. I don't know if you guys have heard about CTF, capture the flags. These are activities. They're sort of like, I don't want to say competition because they're not, but these are activities that you could do to learn your hands-on skills. Basically, they're going to hide something. It's known as a flag. And you're going to have to find it using your knowledge, your skills. You have to find it. This is one of the best way to learn to get your hands dirty with cybersecurity. So if we wanted to train our people, especially cybersecurity people, we could use that. There's 2 platforms. Let me share these with you. There's more, but I'll give you probably just 2. There's Hack the Box. Share this like I know all that stuff already. Been there. So there's Hack the Box. It's one of them. Hack the Box is a bit more advanced. So before I go to Hack the Box, I will start with the Try Hack Me. It's another one I'm going to share with you in a minute. But really, Hack the Box, it's the CTF. It's literally like they have the capture the flags. You go here, they have a bunch of vulnerable servers. Then you learn how to hack these things, if that's your sort of things. And then there's the Try Hack Me. I'm putting these in the chat, guys. Feel free to come back to them later. So try Hack Me, it's fantastic. It's really good for beginners, and they have skills for everybody. Hack the Box is more for red teaming. It's more for ethical hackers, Hack the Box. But try Hack Me, they have some things for the blue team. If you want to become a SOC analyst, for example, for the defense, which is pretty good. They have some other things for the beginner as well. If you ever want to take the CompTIA Pentest Plus, they have that stuff for you. Right? And it's a lot of this is free, but if you end up paying, you're probably going to pay like $80 or $10 a month. It's not bad. So I recommended this instead of doing what I did with the VirtualBox, because sometimes this stuff doesn't work. This is great because you're doing everything from scratch, but this is better because everything is within the browser. So if I were to go here and just we go to learn, search. For example, let me say I want to learn about Nmap, right? You go right here, you grab one of the Nmap, then you can turn on the attack machine. Like this is a Kali machine that you can start attacking. You turn on that thing and then you have your start attack box. This is like your machine that you're gonna use. You don't need to install anything. Everything it's within the browser. Highly recommend try Hack Me first, then you get into the Hack the Box. And then you can include these on your resume for those who are gonna be looking for jobs. Like literally a lot of hiring managers have this now. If you do this, it shows you're passionate about this stuff. You went under and beyond. Okay. And let me give you one more. Yes, we're done. It's range force. So if you don't want to focus on the red teaming and stuff like that, range force is fantastic. The school that I'm running, I have my own school. We use range force for additional labs. I love their labs. That's why we're using them. We used to use range force within Cybercraft, but we don't do that anymore. Let me share that with you. Here we go. So that's range force. I think range force is paid, but it got pretty good stuff. I cannot recommend this enough. And everything is within the browser as well. And their salespeople tended to bamboozle people. So what you want to do is tell them to give you some sort of a discount because it's really expensive, per year. What I love the most, they have these things organized into path. Going to focus on cloud. They have all stuff over there for you. Right? Cool stuff. So that's the training. Companies might buy that for their employees. I just want to train people. Any questions for me? Questions? No? All right, let me check your understanding and talk about the last thing, and then we will get out of here. All right, you guys can rotate and read and
Which of the following policies would help an organization identify and mitigate potential single points of failure in the company's IT security operations?
I'm going to say separation of duties.
everybody agrees?
Yes.
Okay. Separation of duty it is. Good job. Next question.
A retail executive recently accepted a job with a major competitor. The following week, a security analyst reviews the security logs and identifies successful logon attempts to access the departed executive's account.
Mhm.
Which of the following security practices would have addressed this issue? I would say offboarding.
Yeah, I agree.
Boarding. Good job. Good job. They're going to work for a competition, kick them out, right? Get rid of them. Get rid of them. Next question.
The following are the logs of a successful attack. Which of the following controls would be best to use to prevent such a breach in the future?
Account lockout.
Okay. Everybody agrees? I see Ned nodding. And account lockout it is. So how did you show the account lockout? I want to make sure you are able to read this log here.
Because it gave a successful completion for one of them
Mhm.
after 5 attempts.
In less than 1 second.
Yeah.
Yeah.
Love it. Same username, right? Different passwords, less than 1 second, 5 attempts. Account lockout would definitely have stopped that. Next question.
A systems administrator needs to implement an access control scheme that will allow an object's access policy to be determined by its owner. Which of the following access control schemes best fits the requirements?
Discretionary.
Jack, okay. Good job, you guys. This is good stuff. All right, why wasn't mandatory access control?
Because it was determined by the owner.
That's the key
Yeah.
word.
Mandatory would be done by the system.
That's the key word. Good job. Next question. Who haven't read yet?
A company processes highly sensitive data and senior management wants to protect the sensitive data by utilizing classification labels. Which of the following access control schemes would be best for the company to implement? Role-based.
Role-based.
Yeah, I got to go with role-based.
Role-based.
Wild card. I'll say rule based.
Okay.
Actually, I'm sorry. Can I redact that?
Yeah.
I'm going to go with the mandatory. The role-based would have been my second option, though.
All right. So I was like, why are they picking role-based? So Karen, why did you change your answer?
Okay, because I went back in my notes and I was looking at Mac and it had to do with the labels and the clearance.
Yes. Bingo.
But initially, when I see highly sensitive, without looking in my notes, I went strictly to role-based.
Okay.
I think for that one, the senior management threw me off.
Gotcha. Yeah, so role-based, guys, this is role. This is just based on the role within the company. It doesn't really have to be sensitive or anything. It could be the cleaning crew, group. And we just add all the cleaning crew people in that group. That's based on their role, right? So you see classification, you see label specifically. It's MAC. And here they didn't say the whole thing. They said mandatory. Similar to discretionary, sometimes they might just say discretionary, not the whole thing. They're talking about the same thing. Okay.
This would be like the Marriott case essentially, right?
That was giving them, that was access control, right? They give them too much privileges. It wasn't on need to know. Next question.
The concept of connecting a user account across the systems of multiple enterprises is best known as federation.
Everybody agrees?
Agreed.
Good job. So not bad, not bad. You guys are great. Like it. All right, good. Going. Cool. You can hear me okay. You can see the screen. You can see the recording going. Cool. All right, let's dive right in. So lesson number 9, implementing secure network designs. Let me tell you something before we get started. You in cybersecurity are going to inherit a network that is already designed, right? I think I've mentioned that in the beginning, and you need to kind of make peace with that. You will inherit a network that's already designed. The issue you will have is to think as if they included the security when they were designing the network, which is not true. The network engineers, they don't know security. So when they're designing networks, they just putting things together so they can work. So what you will need to do is ask them, hey, can I see the network diagram? Not because you want to be the network engineers or anything like that, just because you want to make sure that they've segmented the network, that there's some security within the routers, within the firewalls, within all these other things. So this chapter really, it's all about that. We're going to take a step back, look at the devices on the network that we will use to secure the network. But I don't want you to think as if the network you're going to inherit is secure by default, because it's not. Right? So we'll start from the design of the network, and I have a pop quiz before we dive in.
After segmenting the network manager wants to control the traffic between the segments. Which of the following should the manager use to control the network traffic?
I'm gonna have to go with DMZ.
Yeah, I agree.
DMZ. Okay. VLAN. Wait, this question. After segmenting the network manager wants to control the traffic between the segments. Which of the following should network manager use? No, actually, this is a mistake. I made a mistake here, guys. It should be in D. Right? It should be in this one. I will change the answer. Sorry. It should be in D. D is access control list. See, VLAN, virtual LAN, is what you will use to segment the network. You're creating a virtual local area network. That's what this stands for, virtual local area network. Once you've done that, that means you've segmented the network. So you can have, let's say you have 3 different departments. It's okay, this is VLAN 1, and this belongs to sales department. This is VLAN 2, that's the marketing department. This is VLAN 3, and this is the management department. These are all different segments of different networks. If sales get attacked, we're okay in marketing and management. That's the whole idea of segmenting your network. So once you've done that, what you will need to do to control, that's what do you want to control the traffic between the segments is putting in access control list. Are you controlling how the traffic flow within the network? Are you like, okay, well, the IP address from here can now communicate with the IP address from here. Access control list is going to do that. Now, some of you have said DMZ. This is the demilitarized zone. This is just a section on your network. It's a segment of your network that you allow the people from the outside to come in. That's what a DMZ is. So within a DMZ, you will put in a web server because you want people to access your website from the internet to access your website. So you will put that in the DMZ. You will put in your email server. Maybe you want people to access the emails. So you will put that in a DMZ. We will talk more about this. And then this is a VPN, virtual private network, which is a way to connect to a network securely from unsecure location. We'll talk more about that. But let me change this before I forget. Okay. Come on, that's it. Perfect. All right, so 3.3, given a scenario implementing a network design on that exam objective. Let's get busy. So secure network design. So there's a lot of problems that arise from a weak network. So again, remember guys, when it comes to security, it's one of those things that they've been trying to put on top of the things that they've established already, right? Even when you look at these old protocols, they're not secure. A lot of these old protocols, that's because when they were developing these things, security wasn't really top, it wasn't really in their mind. It's something that they're trying to sort of put on top of everything else that they have. So there are some issues with the way people design network. One, single point of failure. Who can tell me what this is? What is a single point of failure?
Say that if the only, I would say, interest and exit point of a system. So if it fails, then the entire system goes down.
Thank you. Thank you. Yes, it's just having one thing and we depend on that thing for a lot of stuff. It could be a server that is very critical to us, that does a lot of stuff for us. If that thing dies, we die with it. So we don't want to design a network that have a single point of failure, where there's one thing so important. Another one, we don't want to make a network too complex. See, in the beginning, when we started this class, I told you that you need visibility in your network. You want to know what is happening within your network. For you to do that, your network have to be easy to understand. You got to know how traffic flow from point A to point B. 3, availability over confidentiality. This is actually interesting, this right here. There is this idea that when it comes to security, there is 2 things that we need to balance. One is security, another one is functionality. See, cybersecurity people, we want to secure everything. But what happens when you make an environment too secure? People start going around it. Right? Imagining if you're requiring people to change their password every 70 days. Every 7 days, like every week. They're going to start writing those passwords down, right? That's just too much. And that's going to evade the purpose of security in the first place. So what we do and what I want you to do, or once you get hired, is think about these 2 things, security and functionality. You want to make a system secure, but you also want to make it usable. So you have to balance the two, right? Don't be like, Marriott Hotel last night where, 2 people had access to over 5 million people, guest records. That's just too much functionality, right? So you got to balance the two, and that's how we win in cybersecurity. So usually CEO, they want availability. They want things to work. They want things to be there when they need them to be there. But you as a security personnel, you don't want too much availability, right? You don't want too much functionality. So we have to balance this availability, confidentiality, integrity, and kind of come to some sort of a balance. Documentation is huge when it comes to network design. I had a mentor who said, if it's not documented, it didn't happen, right? Which was interesting. Got to document everything. If somebody make a change to the network, they change the IP address, we need to know about that. We got to know about any changes that is happening. Overdependence on a perimeter security. A perimeter security is what we're going to talk about in this chapter. These are the firewalls, the routers, the things that usually secure us. We don't want to overdepend on them because they will fail. Once they fail, then what? Imagine if you have a firewall. You didn't have any other security after the firewall. Well, what if somebody gets in? Well, your computer doesn't have any antivirus or some sort of like an EDR, something to protect itself. So a secure network is a network that does not overdepend on perimeter security. Actually, to make this a lot easier, the best network design is a defense in depth, right? Defense in depth network design. Have anybody here heard about the defense in depth, the idea of defense in depth? No, defense in depth. All right. So the idea of defense in depth, guys, is that so you have the design of the network, you are integrating security in the different layers of the network because you believe that one thing is going to fail, but you have another thing waiting for that thing to fail. You guys remember the OSI model, right? OSI model, the 7 layers of the OSI model, right? Some of you does. Okay. So there's this idea of 7 layers, right? From the application all the way to physical. Defense in depth or a secure network is a network that we include the security in the physical, we include the security on layer 2, we include the security on layer 3, we include security on layer 4. That way, if a physical fails, layer 2 is waiting. And then we have talked about some of this stuff already. Actually, this chapter is going to help kind of sync everything. Last night, we talked about the 802.1x. 802.1x, it's port security. You can do this on the switch, where if people want access to the Wi-Fi or to your network, you're like, hold on a minute, who are you? What's your name? You authenticate them. Well, imagine if this was the building and somebody managed to get into the building. Like they managed to social engineer, like physical security have failed. The door failed, the security guard failed, all that stuff failed. They managed to get in. So as soon as they get into the building, now they're trying to connect their attacking machine into your Wi-Fi. Well, there has to be a sort of like some security. If you configure 802.1x, it's going to kick in and be like, hold on a minute. What is your name? They're already in the building, but now, layer 2 kicked in with the security. So that's the defense in depth, applying security on the different layers of the USI model. If you remember what that is, great. If not, we will come back to it. So Cisco came up with what they call a safe architecture, which is like, again, that defense in depth, the sort of like best practices that you will use if you're designing a secure network. That was a lot of talking. None of this is going to be on that exam. This is just me telling you real world sort of stuff. All right, so business workflow and network architecture, where you have what we call a corporate network. Corporate network, this is your private network. This is where you have all the private stuff, your email, your file transfer, your Active Directory, your all that corporate stuff. This has to be segmented. Segmented is separation, has to be separated from other sort of networks. But you need to know how the data flows from one point to another, and then controlling who has access to what. It's very important. Cool. So here's that defense in depth that I was talking about, this right here, sort of. So let me actually just take a minute and talk about that too, because it's going to be a little bit hard to understand the rest of this if you don't understand that. So there's this idea of the OSI model, which says that there are 7 layers of a network, right? And this is the idea of how you understand the network you're talking to each other. Right? We understand that based on this OSI model. And it goes something like this. Layer 7 is the application layer. Layer 6 is the presentation layer. Layer 5 is the session layer. Layer 4 is the transport layer. Transport. Layer 3 is the network layer. Network. Layer 2 is the data link layer. Data link. And layer 1 is the presentation layer. So you're taking Security Plus. This is not as important as it is for the exam, but this is very important for you to understand how networks talk to each other, how computers talk to each other on the network. So stay with me. On the application layer right here, this is you using the application right here. This is the user using the application, right? That's right here. On the transport layer, layer 4, this is where we have the TCP. You've probably heard me talking about TCP and the UDP. I will talk about this. This is the transport control protocol. This is the user datagram protocol. That's on layer 4. On layer 3, this is where we have IP, the internet protocol. Right. On layer 2, this is where we have MAC, the media access control, the MAC address. Right there. And on layer 1, this is where we have bits and bytes, bits and bytes. These are the binary, the ones and zeros right here. So stay with me. On each one of these layers, guys, there are some appliances, some devices that we can put on this. Actually, these devices, they function on a different layers. They function on different layers, which helps with security because there are some security we can do within each one of these devices. So for example, with the physical layer, layer 1, this is the physical security. Why do I have a this is the physical security here. It's the physical layer. Right? I keep saying physical security, but this is the physical layer here. So some of the things that we can do here are the physical stuff. Some of the security we can do at the physical layer are the physical stuff. Door, security guards, CCTV cameras, make sure the cable are hidden, right? All that stuff, like anything you can touch and feel, that happens at the physical layer. Cyber people, normally we don't do a lot of this. It's okay to know that it's taking place, but this is done by the building managers or the people who manage the facility, the physical layer. So that's the security we can do here. Fences outside, the signage, all that stuff, it's a physical layer. Now here is what I want you to understand when it comes to these network appliances. We have a device known as a switch. How many people here have heard about a switch? Yes. So a switch is literally designed to allow your computers to talk to each other. So switch allows you to connect like tens of different computers on the same network. That's what a switch does. A switch can be found at the layer 2 of the OSI model, the data link layer. Right here, you can see CompTIA did say that too. Right here, switch. That's the device. Now, as you design a secure network, you need to know the kind of security you can do at the switch. That's the whole idea of this conversation. So one of the security you can do at the switch is what they have, right? VLAN, virtual LAN, virtual local area network. So what do we use a VLAN for, guys?
Segmentation.
Segmentation. Thank you. So at the switch, we can literally chunk this switch into small pieces and be like, okay, this portion of a switch belongs to management. We can segment it. Thank you, Shayla. Then we can say, oh, this other portion of the switch belongs to sales. And this other portion of the switch belongs to marketing. That's segmentation. That's security. If they hack sales, is within the same switch, but they're not hacking the whole thing. They're just hacking sales. Another security thing we can do here is what we talked about last night. It's port security, 802.1x. I keep bringing these up because this is going to be on that exam, 802.1x. That's another security we can do at the switch. That's when we can tell one of these port here. Like, hey, look, if anybody connected to you, ask them who they are first. Ask them their username, their password, before you give them access to the Wi-Fi, the network. So there is that here. At the data link, you can also find an access point. Access point is the device that gives us the Wi-Fi, right? Access point. Cool. Now, layer 3 of the OSI model, this is where you will find a router. A router, this guy. Right here. What is the job of a router, guys?
To transpond the signal.
Sorry, can you repeat that for me?
To transpond the signal.
Transpond the signal. You mean like from one network to another network?
Yes.
I will give you that one. Thank you. Yeah, so a router like allows us to communicate with other networks, right? So a switch allows us to talk to ourselves locally, like within the same local area network. But what if we want to go outside of that network? Then we're going to go to the router. A router takes us outside of our network. We can communicate with another network using a router. That's why we call, we say default gateway, it's the router's IP address. So that is on layer 3 of the OSI model. So your question might be, okay, I got it. So what are some of the security we can do at the router? Well, I'll give you one. A, C, L. I don't know if you remember last night, I told you don't think about this ACL from whatever they were talking about. This is the access control list. We can configure this in the router, and then it'd be like, okay, well, this IP address is not allowed to go to this IP address, or this IP address cannot communicate with this other IP address. Access control list. That's another thing we can do here at the router. All right, another one, and this is the last one, guys, I'm gonna keep going, is the TCP, It's the layer 4, the transport layer. On the layer 4, we have things such as firewalls. I don't know if you've heard about firewalls. If you haven't, that's okay. We're gonna talk about that in this class. Firewalls can be found at it's sort of like in between, because on the firewall, we can also configure ACL on the firewalls. That's why you see this is between layer 3 and 4, That's because you can configure access control list on the firewall as well. But access control lists are mainly configured within the router. But so some of the security we can do at the firewall, I've said one already, ACL, access control list. Or we can configure firewall rules, like a regular firewall rules. Right? And basically a firewall, it's known to be that security device. It does a lot of security, but usually a lot of it's just a bunch of rules that just need to be, sort of like enforced within the firewall. But that's on the layer 4 of the OSI model, the transport layer. Okay. And then as far as the application goes, we have a bunch of other stuff that works within the application. I will talk about those once we get there. But I wanted to give you just this. These are the physical device. These right here are the physical device that made up our network. And if we want to design a secure network, one, we want to look, is the network segmented? Yes, if it is, good. Two, what are some of the security we can do within the device that are within our network? That's exactly what I just finished talking about. Once you do all this, you have what we call a defense in depth. If somebody hack you, they're not just gonna keep progressing in your network like that. No, there are some other things in place that's gonna stop them from moving forward. Have you guys heard about the Target attack in 2014, I believe, the Target breach? So some of you have not? Okay, well, let me talk about this because it's literally, like they literally made the mistake of what we're talking about. So in 2014, 2013, I think it was 2014. It might have started 2013. And this is what sort of like woke up a lot of people, woke up a lot of CEOs, right? Because they saw this on CNN and they're like, okay, well, what do we need to do to keep my name out of the news? Because this was everywhere. This was everywhere and it was interesting. Anyway, so here's what happened quickly with the Target. So Target had an HVAC system. So they have a vendor that they use in their stores for their AC. And what they did, which was a really bad network design, they allow the AC to communicate with the register. So from the AC, you could ping the register. You could talk to the register. So the hacker hacked the AC system. They started pinging the registers. And pinging the register, they were stealing credit card information. It wasn't just a ping, it was them exfiltrating, like stealing the credit card information. This was a classic attack that goes against everything that we're talking about. One, the question is, why is the HVAC communicating with the register? That means there's no segmentation. There's no segmentation. Second is, if the HVAC is pinging the register, that looks weird. Like, why would the HVAC be pinging the register again? Right? So that's what happened. And oh my God, it's a classic study. Everybody talks about it. It was one of those, a lot of people got fired, by the way. Yeah, the CISO got fired. A lot of people, they had to show them the door. But it was sort of like a classic study of sort of like a bad network design. So we have these routers. Oh, I copied this and I didn't put this here. So for you to maybe read up a little bit on that Target breach. I like stuff like this because it helps you reinforce the concepts. So if you read about it, you will more likely to remember it than anything else. There we go. So routing and switching, right? So really not much to talk about here, but there are protocols that we use when we're dealing with this, either routing or switching. Within the switching, we have ARP. ARP is the address resolution protocol, and we talked about this one. I told you that ARP is used to map IP addresses and their corresponding MAC addresses. right? That's what ARP does. It's a protocol that is used at the switch to do this sort of stuff. Then you have IP. IP works on layer 3 routing. So within IP, we have two versions. There's IPv4 and there's IP version 6. Right? Version 4 is what we've been using. 10.this, right? That's the IPv4. IPv6, however, it's in hexadecimal. Let me go to CMD, my command prompt, and then bring up my IP config. I'll do /all, so you get to see pretty much everything. If I show you my Wi-Fi here, and at the bottom, you can see my IPv4. Where are you, buddy? Well, let me just show you my, is that my Wi-Fi? It is my Wi-Fi. Yeah, here's my IPv4. 192.168.111.142, right? That's my IPv4. But my IPv6 is also turned on. And you can see that from this right here. What am I looking at? I don't know what's going on. It's still too early for me to now see this. So this is IPv6 right here. This is supposed to be the next generation. Believe it or not, this thing, like literally, they came up with this back in '96. It's sort of like crazy how these have not become mainstream yet. Like nobody's using it yet as much. But I'll tell you why, because there is this technology known as NAT, which I'm going to talk about in this class. Network address translation, which is what have been keeping IPv4 in business for this long time. Anyway, I just wanted to show you these, how they look like as well. So this happens at layer 3 at the router. Routers is the one that deals with IPv6, but also with the subnet mask. Subnet mask is that 255 stuff. I don't know if you've seen it. If you did, great. If you did not, it's okay. This is not a networking class. Both of these are used for forwarding stuff. So layer 2 forward MAC stuff, layer 3 forward IP stuff. None of this is going to be on that exam, right? I will specifically point out what's going to be on that exam. Network segmentation, absolutely, you got to understand the idea behind this. So we can go in and sort of like segment the network. Traditionally, guys, the way we used to segment the network is by having like physical switches. You can place them in different locations and then the network is segmented that way. But now we have a virtual LANs, VLANs. So you can configure virtual LANs on managed switches. Managed switches means it's a switch that have a brain. It's a switch you can configure and change some things to it. Like those are Cisco switches. These are enterprise switches. So you can configure virtual LANs to do the segmentation, the separating the network. Okay. Once you segment a network, you have to use a subnet. Subnet basically means you're giving this network a different IP address so that they won't be able to talk to each other. You're separating them. Okay. All right, so network topologies and zones. So as you're looking at segmenting this network, you can do that physically or logically. Yeah. So zones represents the isolated segments for hosts that have the same security requirements. Really what they're saying here is a zone, it's a part of a network that have been segmented. It's like by saying, okay, these people are on VLAN 10. Well, that's zone, whatever that is. So the traffic between zones can be filtered. That's the beauty of this. That's why we do the segmentation. So we'll be able to filter the traffic and be able to control who is communicating with who. So here are the three main zones. If you're going to be designing a network that you need to keep in mind, and this is how most companies do it. I will show you what some of the people that are doing this in the real world, what they do. But let's talk about what most companies do. Most companies are going to have what they call an intranet, also known as a private zone. A private zone, if you ever worked for one of these, companies, this is where you will find users on the intranet. This is where you will find printers and computers and stuff. Everything is within that corporate, that private network, which is hidden behind other stuff. So that's one, intranet. It's a private network of the corporation. Then you have your extranet. Extranet is what you guys were referring to a minute ago as the DMZ. DMZ, demilitarized zone. That's the extranet. This is the location, this is a zone on your network. You allow the outside people to come in. So you put in stuff that people from the internet can access, like a website. You want people from the internet to access your website. So you put a web server in the DMZ. And then obviously you have your internet. So this is public. Anything that's on the internet should not be trusted, right, until you do your verification and stuff. So they have these three zones, most companies. A mentor of mine said, for security reasons, you want to put another zone between the intranet and the extranet. And that zone is known as a middleware. We will talk about this. Like a middleware. And if I'm spelling this right. But a middleware meaning you will put in like a proxy server. If you know what a proxy does, a proxy is a device that's going to make a request on the behalf of someone or behalf of something. That's what a proxy does. I have a section on a proxy, but I just want to introduce that right now. So that's going to be like a separate, like a completely separate zone. And the reason why you put a proxy here is because you don't want people from the intranet to directly communicate to the extranet. But you want them to go through the proxy. It's like the conversation will go from the private to the proxy, and the proxy is going to be like, hold on for me, stay right here. I will go get what you're looking for. I will bring it back and give it to you. That's what a proxy does. It makes the request on your behalf. So make sure you have a zone separate just for that. This is really good for security because look, in a DMZ, you are allowing people from the outside to access this, which means bad people can also show up. Hackers can show up in your DMZ. You don't want the people from your private network right here to directly communicate with these guys because potentially there could be like a malware or something here as well. Guys, this whole idea, everything that they're talking about here, it's the idea of a secure network is a network that is designed in zones, is a network that is basically segmented. Right? That's what this whole conversation is really all about. We don't want to be Target that had like a flat network. Everything was communicating with everything. We don't want to be like Target. All right, so the DMZ, the demilitarized zone, right, is an isolated host or network that is internet facing. This is CompTIA description now, right? And I've told you, it's just a portion of your network that the outside people can come in and access. The communication between a DMZ and a private should be not allowed. Even CompTIA agrees. You shouldn't be able to just go into your DMZ like that. You should go through proxies. Ideally, use a proxy to rebuild the packets for forwarding from a private to the DMZ. Okay. Devices that we're going to put in a DMZ, we call those Bashan hosts. Bashan hosts are not fully trusted, so they run minimal services and do not store local network account credentials in these things. Like I said, web servers. So what we're going to do, we're going to shut down everything else except the web stuff into the web server. You're going to put that in a DMZ. We can also use the different DMZ for different functions. Okay. I'm hoping I'm not moving a little bit too fast. So please let me know if I am, so I can slow down. I think I've slowed down enough. Good stuff. All right, so this is a DMZ typology here, right? Kind of showing you. So you have this portion of a network and this portion of a network. There is this DMZ, the extranet here. Then you have the servers. It could be a web server. I've mentioned this. Let's just keep going. All right, another one we have, it's what we normally call a screened host. Screened host is a SOHO DMZ. SOHO stands for small office, home office, right? This is for small companies, right? Screened host is a small, it's like a very small network. It's like having like one firewall that is protecting you from everything. Or like your router at the house. You know, like the router you have at the house, that's a SOHO router. Because it does more than just routing. It acts as your access point because you can connect it to it via Wi-Fi. It acts as your firewall. You can configure like a basic firewall stuff within the same router. It acts as your switch. Maybe your router has like 4 ports on the back of it, you know, the little 4 ports, you can connect other stuff to it. So that's a small office, home office, right? So it's designed to allow stuff from the internet. Like I said, it's going to be acting like your router here, this guy right here. Again, screened host or SOHO DMZ, used for small businesses and people in their houses, right? Home or small businesses. All right, so IPv4 is great. IP version 4 is great. And they've been around for a long time. But in 2011, 2014, I'm still thinking about Target. 2011, we ran out of IPv4, right? So when they developed IPv4, it's a 32-bit. I'm not gonna go into the techie stuff of this, but it's a 32-bit version of this. What this basically means is that there is roughly 4.3 billion billion IP addresses that we can assign it to people and things, right? That's when they developed IPv4, this was the max. So as soon as the internet took off, they didn't know the internet was gonna take off the way it did. So that's when they started developing IPv6, by the way. So in 2011, the ICANN is the company that manage IP addresses. They signed the last IPv4, and that lead company to start upgrading to IPv6. It's still taking a long time for them to upgrade because some other things I'm going to talk about later on here. But IPv6 is all right. It's great. It's nice. There is, I should probably mention this. IPv6 is 128-bit, right? Compared to IPv4, which was just 32. And IPv6 is unlimited. There's little things you can say unlimited on. IPv6 is one of those. The way they designed IPv6, they said, we don't want to run out of number ever again. So there's last time I was reading about this, they said, with a population of 8 billion people around the world, each one of us can have like 1 million IP addresses and we will still have enough left. That's how big IPv6 is. Right? I wish this was a network class so we can dig deeper, but for now, just know that stuff, right? All right, so the implications with IPv6. One, it's enabled by default. I think it was enabled. I think Microsoft turned it back off. Because, oh my God, IPv6 introduced what they normally call NDP. NDP is Network Discovery Protocol. Network Discovery Protocol. this was enabled, like they said here, by default. And this was the issue because it's a network discovery. You can discover other stuff on the network by default. So that was the issue. Many times, if this is turned on, you gotta just have to turn it off. And the other thing is IPv6 and IPv4, they don't like each other. It's like you have to use one or the other. There's no, we can use both and none of that. They try to come up with other things that will help you use both of them. It didn't work. So I'm just gonna leave it there, guys. It's, if anything pops up on the exam about IPv6, is that NDP, the Network Discovery Protocol. If this thing is turned on by default, there is an issue of NDP because you are exposed. They can discover stuff. They can discover your, things. All right, other secure network design considerations. Well, companies are moving into the cloud. I will tell you guys, if you are looking to jump into security with your 2 feet, go into the cloud. I literally just don't think about it. Just trust me on this one. Jump into the cloud, because like a lot of organizations been moving into the cloud. I have a cloud section. It's we're going to talk about that. But really, a lot of systems that you're going to be securing, a lot of things you're going to be protecting are going to be in the cloud. That's how it is right now. But so cloud is great because it saves company a lot of money. Companies that still have data centers, some big companies still do. There's this idea of east-west traffic, which means east-west traffic is the traffic that is between the servers, like the servers within the same data center. It's like, who come up with these names? East-west means it's traffic between 2 things that are within the same data center, right? And there's a reason why we're talking about this. Security-wise is whenever you are inside of a data center, you tend to just do whatever you want. Like everything within the data center will trust you once you're already inside. And they don't want that. Right? They don't want that. So that's why, there is like sort of like a problem for security inspections and filtering. Yeah. Once you're inside of an environment, you tend to be trusted. And like they said earlier, the design of the old networks focused on perimeter security, meaning they rely on the firewalls, meaning once you pass that firewall, you're free. That is the issue. That's why this east-west, I will not worry about this. What I worry about though, it's the zero trust. That's why they came up with the zero trust, because they didn't want to rely on the perimeter security, the firewalls. They didn't want to rely on these things to just protect them. It's like, okay, well, you got into the environment, sweet. Now let's monitor how you behave. Let's re-authenticate you. Let's keep asking you some things to make sure you are who you say you are. If you remember last night, I told you this was the context-based authentication, the ABAC. It was attribute-based access control, I believe. That's what that stands for. That's literally the idea of a zero trust, meaning you are we're going to continuously monitor how you behave, continuously re-authenticating you here and there, because we don't want this trust anymore. We don't want this trust that you therefore you have access to everything. So there is a micro-segmentation based on how you've authenticated. We can, using code. This is done by using code. There's micro-segmentation that gets put in place. All this stuff is new, guys. I doubt if this is going to be on the CompTIA 601. But if I were you, I will start looking up things such as cloud and the zero trust. Every company now, literally, if you go to their website right now, it's like, we are a zero trust company. Yeah, it's like a buzzword right now. It's like a marketing term. It simply means I like the idea behind zero trust. Let me just put it that way. Micro segmentation, it's great. You get attacked, it's okay. They just have this portion, not the whole thing. That's zero trust. Any questions for me? Sweet. Topic B, implementing secure switching and routing. 1.4, 3.3 on the exam objective. So 1, man in the middle. We talked about this. This is also known as an on-path attack. This is when someone is intercepting and modifying the communication between two things. They're on the path between two things. So you could be man in the middle or on the path doing snooping. Snooping, I want you to understand, snooping is different than spoofing. Right here. Don't this remind you of Snoop Dogg? The guy? Right. So snooping. Snooping is just like sniffing. And if you remember what sniffing was, it's just listening to conversation. You could be listening to conversation with a bad intention. For example, using Wireshark. Wireshark is a packet sniffer. You're listening to conversation, you're capturing the conversation. And the spoofing, on the other hand, is pretending to be someone else that you're not. That's spoofing. So computer A can be communicating with computer B, while computer A is acting as if it's computer, Z. That's spoofing. That's impersonation. If you remember when we're talking about impersonation, you're impersonating someone or something. That's this spoofing. MAC address cloning is something that I'm going to come back to. MAC address cloning and spoofing, same thing. You're pretending to be someone else by cloning their MAC address. You guys know what a MAC address is, right? Because I keep mentioning this, and it's going to be on that exam, and I don't know if you guys know what this is. You guys know what a MAC address is? All right, let me show you what this thing is.
It's your hardware address. Is that it?
That's it. Good job. Yeah, well, I don't like this. All right, let's do IP config /. Yeah, that's the hardware address. Thank you, Shayla. That's the hardware address. If I can find it here somewhere. There you go. This right here, physical address. This guy. It's known as a physical address. It's known as a couple names, but this number right here, this is the MAC address. Every computer must have one of these. You don't assign these. These are assigned by the manufacturer of the computer. So Dell do this. HP do this. Right? And by the way, whenever you commit a crime, this is how they know exactly where you're located. Because this is unique to your computer, this right here. And this is going to point them exactly your building, where that hardware, where that device is located. So on your switch, right, the switch that we talked about, this is how the switch knows which computer to send information to. MAC address. So right now within my home network, right, the kids are watching TV, wife got the phone and all that stuff. Everything's connected to the same network. The question is, whenever we're all going on the internet, how does the router knows who to send the information to? The switch knows who to send the information to. How does it know the computer I'm sitting on right now is the one that's requesting the information? MAC address. Okay, very important. So what the bad guys could do, they could clone this. It's called MAC address cloning, where they'd be like, oh okay, from now on, anything that goes to this computer, send it to me. Right? And they could spoof, meaning pretending, impersonating their legitimate machine. So ARP, like I showed you, ARP is the protocol that does the mapping. So if I do ARP-A, you can see this right here. If I do ARP-A, remember ARP, you can see the IP address and its corresponding MAC address. So whenever they're talking about MAC address cloning, it's when I figure out, okay, this MAC address and be like, okay, any traffic that gets sent to this IP address, I want that to come to me instead of going to this other guy. Yeah, I cannot emphasize this enough. So let's get going. So ARP, there we go, we're talking about ARP. So ARP presenting is when we present the cache table. Once you see this right here, it's an ARP table. This right here, it's an ARP table. So which has IP addresses and physical addresses or MAC addresses. Somebody can present this. They can literally come right here and be like, okay, anything that gets sent right here, I want that to go to me instead of going to that guy. Okay. All right, so broadcasting unsolicited ARP, yeah, so what we can do once they've present this, they can broadcast everything, meaning sending everything to everybody, including the bad, the attack machine that is right here. Another thing that they can do with this is what is known as a MAC flooding. This is when they overwhelm the switch because the switch have a memory. That's how a switch remembers who to talk to, right? What they can do, they can overwhelm the switch with the bogus MAC addresses, with a bunch of MAC addresses that they come up with. Try to get the switch to forget the legitimate MAC addresses. So they can overwhelm the switch so that the switch will stop do what we normally call a unicast, and the switch will start doing broadcast. And it's going to forget everything it knows. Then it's going to send everything to everybody, which is not good because the hackers do this when they're already on the network also listening. That's when they overwhelm the switch so that the switch can start sending conversation to everybody. And they themselves will get a copy of that conversation. Right? And they will sniff it, so they will capture it. Cool. All right, so one thing that happens is this. Actually, I told you about this when we were talking about routers. This was like last week. I told you that routers have what we normally call a TTL. TTL was time to leave. So if a router receives a packet and doesn't know where it belongs, it's just going to kill that packet. There's like a time to leave of that packet. That's different with the switch. A switch doesn't have a TTL. A switch have what we normally call STP. This you need to remember for that exam. STP. STP is the spanning tree protocol. You don't really have to do much. You just need to turn this thing on. It's not turned on by default, but you just got to turn it on. So STP is going to prevent broadcast storm. Right? Broadcast storm is when a switch gets flooded. Well, probably let me take that back. Is when a switch receives a conversation and it doesn't know where that conversation is supposed to go. You're just gonna looping. Actually, that's what they call this loop prevention. So a switch receives a conversation, it doesn't know who to send it out to, it's gonna just keep looping around. Going around. So what STP does, STP does not allow this to happen, right? The frame in the switch is gonna go, once it gets to where it came from, the root bridge, STP is going to have what they normally call BPDUs. These are the Bridged Protocol Data Unit. Think of these as guards, as little police. Little police that keeps on walking around looking for any loop, looking for any traffic that doesn't know where it's supposed to be going. So what happened in the switch when STP is turned on, it also turned on the BPDUs, the Bridged Protocol Data Units. And what these guys are going to do, they're going to kill the loop. They're going to kill the packets, the frames that doesn't know where they're supposed to be going. Okay. So basically, this is equivalent to TTL in a router, time to leave. Think about time to leave is going to be like, okay, well, you got about 30 seconds. If you can't find where you belong in 30 seconds, I'm going to kill you. And the STP is like, okay, well, if I've seen you before, then I'm going to kill you because you don't know where you're supposed to be going. I'm going to kill you, then we're going to ask whoever that sends you to send another one because clearly you have no clue where you're supposed to be going. So BPDUs can disable the port on the switch. They can do so much. Just remember, STP on the switch, spanning tree protocol, is designed to prevent a loop from happening, from a packet to keep looping. All right, keep going. Port security. We sort of talked about this. I say port security, but physical port security. Port security, we talked about this. I told you this was the 802.1x. Remember that, keep mentioning this, it's gonna be on that exam. So we can use this to ask people to authenticate. When it comes to physical port security, we can maybe disable the port if we're not using it. This is physically securing the port on the switch, this right here, okay? What we can do, it's also MAC filtering. MAC filtering is great, but it's not really like security. If somebody knows what they're doing, they can clone the MAC address. We're just talking about cloning the MAC address. So MAC filtering, also known as MAC limiting, is when you tell the port on the switch, like, hey, look, only this MAC address is allowed. Only this number of MAC addresses are allowed. Right? So we'll configure permitted MAC addresses. The issue with this, though, like I said, hackers can easily clone the MAC address. And then come back and be like, hey, now I have the real MAC address. Can you let me in now? And they get in. So this is okay to slow them down, but if they know what they're doing, yeah, this is almost useless. But it's all right for script kiddies, right? The kids who don't know what they're doing, right? Cool. We'll talk about DSCP in the later sections. NAC. This is a network access control. Network access control. It's one of those technologies that is not used right. I don't know why. So I've mentioned the idea of defense in depth. I've told you it's like having multiple things securing you. That's what defense in depth is. Multiple security in place. And we have talked about 802.1x already, which is port security, right? So what NAC is network access. Whenever you're doing defense in depth, whenever you're doing port security, you're literally accomplishing a portion of NAC. Because you're like, okay, hold on a minute. Before we give you access to the network, let's know who you are. So NAC, it's also technology that is not used the right way. Literally, I haven't seen a company that used this the right way. It's a cool technology that usually, whenever people are trying to communicate with your network, you ask them first who they are through this guy, or you can also set up a NAC server, which is going to have a bunch of policies. And those policies are going to ask these devices, these computers, as they try to connect, hey, who are you? Hey, are you healthy? Actually, I like that, this right here. Healthy meaning you as the phone, you as the device, you as the computer. Do you have the latest updates? Do you have antivirus program installed? If you don't have this, I'm not going to let you to the network. You're not going to have access to the network. So that's what NAC does. So there's two ways of doing this. There's the agent-based. This is when you install the agent into the actual phone, into the actual laptop computer. Or it could be agentless, where you have like a NAC server and that thing is doing like device pooling, where you're trying to get access to the network. It's gonna, the policy is gonna kick in. It's gonna ask that hardware, hey, hold on a minute, let's check these things and making sure you're good to go. To be honest with you guys, this is like the best technology for BYOD. Right? BYOD. And then, ask me why. People with the BYOD come with the different devices, different phones, different versions, different this, different that. You can implement NAC that's going to ask those phones, those laptops, those things. You have a policy, rules that they have to obey. As soon as they try to connect, you'd be like, okay, hold on a minute. Do you have this? Do you have this? Do you have this? Do you have this? Before I let you connect to the network. So this is a network access control. It's in the name. We're controlling access to the network. We're doing that via agent, meaning we install this into the device itself. It's known as a persistence because it's installed, or agentless, where we have like a NAC server that's scanning for those devices as they're connected to the network. Okay. Router security. When it comes to the router, guys, there's really little you can do as far as security goes. The only thing you need to do is keeping the router up to date. So patch that router. That's it. That's all. Routers, not much you can do there. So if you patch the router, it's going to prevent router injection. It's going to make sure hackers don't have access to those routing tables. So patch the router. And then hardening that router, meaning remove anything that shouldn't be there in the first place. Any questions for me? Any questions? All right, let's finish this chapter before we go to a break. So lesson 9. We're still on lesson 9. C. Implementing wireless. This is actually good because you can literally take the knowledge from this section and then they apply this to your Wi-Fi. Hopefully. Hopefully you do that, right? All right, 9C. 1.4, 3.4 from that exam objective. This is all Wi-Fi. We'll talk about what it is and everything in between. So wireless network installations, things you need to consider. There is a couple of things you need to consider. First of all, if you're going to be installing a wireless, you need to know if you will get the signals, right? If you will get the speed that you want. So the first thing you need to do is site survey. Probably this is not the only thing, but you got to remember this for your exam. Site survey, it's when you survey the environment and know the speed, like how fast the Wi-Fi is going to be. You might have what then we call heat maps. It depends on the program you're using for this. It's going to help you know a couple of things as far as the speed and the availability, right? Like how, like in what places will the Wi-Fi be available? Site survey will give you that, and it's just an app that you can install that will give you that. All right, so this is all great stuff, but let's talk about the things that might pop up on the exam. So you will have an access point. Access point is the device that give you Wi-Fi, right? Device that give you the Wi-Fi that allows you to connect it to your internet via wireless radio frequencies, radio waves, connected via wire. So for you to be able to do that, you're going to have a Wi-Fi name. We usually call that thing SSID, Service Set Identifier. So this is the Wi-Fi's name, your Wi-Fi name, SSID. Remember that for your exam. Then you have your BSSID, your Basic Service Set Identifier. This is like used for a group of access points. I'll come back to this. So if you're like at the airport, they might have like a BSSID. They might have like a SSID, just one Wi-Fi name. You can walk for like 5 miles within the same airport and still be connected to the same Wi-Fi net. Like, how is that possible? It's BSSID. So they have a bunch of these access points all over the places. They're sharing the same name, all of it configured the right way. Okay. At the airport, that's where I've seen they do that sort of stuff. Frequencies. We have usually two frequencies. We have the 2.4 gigahertz, then you have the 5 gigahertz. Those are the two frequencies. 2.4 been around for a while, and we use this quite a lot. And 5 is becoming very common, especially with the newer phones. Got the iPhone 14, and now they start kicking in with the 5 gigahertz, which tend to be faster, uses a different antennas, multiple antennas and all that good stuff. All right, interferences. Look, as you connect to these frequencies, there are some channels that the government have given the FCC, the entity that is in charge of these radio waves and stuff. So there are some channels that they given to us, and it's from 0 all the way to 15. You don't need to remember the 0 to 15, but you need to remember 1, 6, and 11, literally for that exam. They're gonna ask you this on the exam. Which ones of the following channels that doesn't have any interference issues? Right? Channels without interferences issues is gonna be channel 1, channel 6, channel 11. And the way it works is like this. If this is you right here, and this is your neighbor's Wi-Fi, and this is your other neighbor's Wi-Fi, you both need to use different channels. So you're gonna have to use channel 1. This neighbor is gonna use channel 6. This neighbor is gonna use channel 11. If, for example, you use 1 and this neighbor uses channel 2, if you're standing right here where there's the connection terminates, you're gonna have some interferences issues. So your Wi-Fi is not gonna work. Okay. If they're using like channel 2, if they're using 6, it's okay. So these are the channels that doesn't have any interferences. The question on the exam is going to be: you are configuring a Wi-Fi for a building. What do you need to? Where are the channels you need to make sure you are doing? This is it. These channels. Okay. Anything else I need to mention here? No, that's it. What to remember for the exam? Remember the name of the Wi-Fi, SSID. Remember the channels, and that's it. Really, you don't need to remember the frequencies. You don't need to remember that. You might want to remember the site survey as the first thing you need to do before you set up the Wi-Fi. So you need to do a site survey and know where you're gonna place the Wi-Fi and the speed, all that good stuff. All right, you might have a controller. All right, controller. Controller is like the brain of access points. So what if you have a multiple access points, wireless access point? What can you do? Well, you're gonna need a controller. You're gonna need something that tells these access points what to do. This is what the airport did. So if you ever travel through airports and stuff, then you have like Wi-Fi from Terminal 1, the same Wi-Fi from Terminal G, and the same Wi-Fi from Terminal F. That's what they did. They have a controller that give instructions to a bunch of access points that they've deployed in different locations. So the controller could be a hardware. Most of the time it has to be a hardware, or it could be a software, which means even the hardware will have a software, right? And the access points could be a fat or a thin access points. Fat access point is an access point that it's like a repeater. It's an access point that just receives instructions from the controller, and that's it. It doesn't have any brain. It doesn't do anything else. The controller tells it what to do. The thin access point, it's more of like a regular access point, really. It can stand on itself, but it can also receive instructions from the controller. Once you have the controller, you will need to deploy, you will have like a management interface where you will use to communicate with these access points. Here, the only thing you need to remember for the exam is that the controller gives instructions to other access points, basically control your Wi-Fi. And let me share this with you guys. If you've ever wanted to upgrade your Wi-Fi, use these guys. That's what I use. And let me show you the speed test of my Wi-Fi. There we go. So that's like okay, because I have a little bit older computer. It should be giving me a gig, but this is not bad at all. Or for the Wi-Fi, right? So usually you could be paying for a gig, but you're not getting a gig. One of the reasons is because your hardware. So what you need to do is go to Unify. Unify, it's one of those companies that I love. If you want to upgrade your Wi-Fi to the next level, go to these guys. I recently upgraded to mine, by the way, so I'm not. And so right here, they have a couple access points, and they have the controller. Like the interface is really great. It's easy to use. You can monitor this stuff. You can see what's going on from your phone app and all that good stuff. If you have little kids like me, one of the reasons I did this, you can see what they're accessing. If you don't want your son to be on video games 24/7, you can turn that stuff off. There's some parental controls. If you want them to go to bed at 9 o'clock, you can turn the Wi-Fi off at 9 o'clock. You can schedule this thing to turn itself off at 9 o'clock. So I love Ubiquiti. I can't really stress that enough. So they have a couple of things. They have these things known as and even if you want to turn your home into a smart home, they do that as well, which is why I got their stuff. Oh, well.
How's it going, Francois?
It's going well. Hey, Dennis.
Great. How's everybody doing today?
Doing well.
Right.
Doing good.
Great, great. Wonderful. I just wanted to stop in and say hi. I was just doing some videos and looks like you guys are into it. Learn about IoT.
Yeah, still talking about Wi-Fi controllers and stuff.
That's amazing how much it changes. Even when the test was written, now we have Wi-Fi 6 and a lot of it's outdated from the test. But great. Well, fantastic. Well, I hope the class goes well today. I just want to say hi, guys, and make sure you check out the resources we have. I don't know, have you guys looked at the videos we have on cybercrafttraining.com?
Yes, sir.
Great, great. And we have those PBQs. I got a question. Michael was asking me for the exam voucher. Just want to let you know real quick. All we ask that you do is complete the PBQs in the CompTIA Learn Lab environment, and then complete the 2 final assessment tests we have on cybercrafttraining.com. Those 2 assessment tests are located at the end of the video course, and they're going to be really similar to the actual exam. So there's a mix of PBQs and multiple choice questions in there. We just ask that you attempt those tests. You don't have to pass them. It's going to take you about 90 minutes, just like the real test, to do those. And then the PBQs, we have those PBQs in the Cert Master or the Learn Lab environment. I ask that you do all of those. They really help prepare you for the PBQs you're going to see on the exam. So once you do those 2 things, just reach out to me. I'll send you your voucher. And then we do guarantee that first time pass. So if you don't pass on the first try, don't worry about it. We're going to get you that second voucher too. But with Francois, you guys are going to pass on the first try.
All right, cool.
Thank you. That's very helpful.
Thank you, sir.
No problem. All right, guys, take care. I don't want to take up your class time. Have a wonderful class and have a great weekend, the rest of your weekend.
Thank you, Dennis. All right, guys, let's get going. All right, so we were talking about Wi-Fi, and I was basically marketing Ubiquiti, marketing these guys. If you want to upgrade your Wi-Fi, go with them. You're not going to regret it. You're going to thank me later. Right. All right, cool. So what if you want to protect your Wi-Fi? What can you do? Well, long time ago, I'm talking about when Wi-Fi came out, they used to have what they normally call a WEP, WEP. This is the Wi-Fi equivalent privacy. Yeah, that's what this thing was called. This was not good, no good at all. And then they came up with WPA version 1. The PA version 1 was okay. Actually, it was great because we're still using this still. But what was the problem was the algorithm they use. RC4 was the algorithm they use with TKIP. So RC4 was the problem. So for version 1, not good. You can use this to protect your Wi-Fi. Then they come up with the Wi-Fi protected access 2, WPA 2. This one is great. We're still using this one. Right now, I'm using this one. A lot of people uses this one, right? One of the reasons is because they replaced the RC4 with AES, the Advanced Encryption Standard. Actually, let me show you my Wi-Fi stuff. There is this tool known as the Insider. There we go. Oh, excuse me. So they replaced RC4 with AES, which was better, and they replaced TKIP with the CCMP. Try really not to remember what this stands for. It stands for Counter Mode with Cipher Block Chaining Message Authentication Code Protocol. Yep. So CCMP replaced TKIP, but it also allowed people to set up enterprise authentication. Enterprise authentication meaning we're going to ask people who they are, names and passwords, before giving them access to the Wi-Fi. Okay. Or you can configure this in a personal mode, like this. Like this is what you have at home. WPA2 personal, meaning you're just going to connect it to the Wi-Fi via your password, your Wi-Fi password. I hope everybody have set up a password to their Wi-Fi, right? No one have an open Wi-Fi, a free Wi-Fi. So there is this tool we were talking about doing like a Wi-Fi analyzer earlier. You can use Insider. Insider is a tool. It's a great tool that you can use to, look up your neighbor's Wi-Fi and see if he's secure or not. You didn't hear that from me. I had a friend who literally didn't pay for his Wi-Fi because he was using his neighbor's. And was through using tools such as Insider to be able to see which Wi-Fi is open, is free, and then just be using that one. Looks like this thing is not coming. Well, maybe I put in the wrong. And it's free. They have a paid version, but you can get a free Insider. INSSID, the SSIDER. All right, it's not coming. I wanted to show you the security, all that good stuff of my Wi-Fi and some other Wi-Fis that are around me right now. So WPA2 is still secure. So on that exam, really, WPA2 is still secure. Then in 2018, they came up with WPA3, right? 2018. And one of the reasons they did is because a lot of people were working from home, people were working from Starbucks, coffee shops, so they were using free Wi-Fi, and free Wi-Fi wasn't secure at all, right? Anybody could be there capturing your traffic. So WPA3 literally came to enhance open Wi-Fi, right? Enhanced open Wi-Fi meaning enhanced free Wi-Fi. What are the enhancements that they did? Really, like nobody knows. We just know that if you're using free Wi-Fi, it's better to use WPA3 than WPA2. Another thing that they did, and this is what you need to remember for the exam with Wi-Fi 3, is this. I keep saying Wi-Fi 3, but literally it's not Wi-Fi 3. It's literally, this is Wi-Fi 6, but it's Wi-Fi Protected Access 3, WPA3. Right. Another thing they introduced, it's SAE, right? Simultaneous authentication of equals. On that exam, if they ask you, so somebody is setting up like a new Wi-Fi and they want to set up the latest and the greatest of the Wi-Fi, it's going to be WPA3. And if they ask, okay, which one of the following they need to configure within WPA3, it's going to be SAE. Right? SAE is one of those things that they introduced with Wi-Fi. WPA3, which is great. It has an updated cryptography, meaning better cryptography. It still uses AES. It still uses AES. It still uses a couple other things that are within Wi-Fi 2 as well. Okay. So authentication methods. WPA2 uses a pre-shared key for authentication. So there's this PMK or pairwise master key, which is sort of like used from a paraphrase. There's the four-way handshake. Don't worry about all this, and so on and so forth. Basically, that's how Wi-Fi 2 was authenticating you as you type in your pre-shared key or Wi-Fi password. Now, WPA3 personal have basically replaced some of these. This is the up-to-date cryptography that I was talking about. So they have PAKE, Password Authentication Key Exchange, which is good and interesting. It's a way of exchanging, sort of like passwords. It's not your password. This is the computer, the device is communicating, your phone communicating with the access point and exchanging stuff before they even talk to each other. So this is good. SAE came back. This is going to be on that exam. If you're talking about WPA3, SAE will be the answer. It was used to replace the four-way handshake, which was used in the Wi-Fi WPA2. There's the Dragonfly handshake, which is also kind of was introduced, part of the up-to-date algorithm. All right, to remember for that exam, WPA2 is still secure. It's not like there's some issues with it. Just WPA3 is better. They're preparing for the future. And there's this other thing that they had. A lot of companies had to roll back. It's known as a Wi-Fi protected setup. WPS is different than WPA. Remember that. WPS is just a button, literally, you push on your router. And it was literally designed to make it easier for you to connect it to your Wi-Fi without using your password. That was the reason they designed this. And there was a lot of issues with this because you can easily brute force it. You could easily guess what the password code was. So the manufacturer of routers had to roll back. Over access point have to roll back and like, no, let's not. Let's turn this thing off. Again, remember, Wi-Fi protected setup was a way of let you set up your phone to the Wi-Fi without typing in the password. You will push a button. There will be some passcode, some number that showed up, and then you connect it that way. Okay. Because of the vulnerabilities of that, this was turned off. But with the newer updates, though, now they have this thing known as Easy Connect or Device Provisioning Protocol. Yeah, this is literally that guy, newer. Will you see this on the exam? Probably not. If you see WPS, just think about it's an easy way of allowing a user to connect it to the Wi-Fi. It's not secure at all, right? But it's an easy way of allowing people to connect to the Wi-Fi. All right, open authentication meaning it's a free Wi-Fi. It's open, there is no encryption, there is no authentication, there's no password and nothing like that. Captive portal you have to remember for your exam. right? Captive portal is the portal. Basically, it's like the page that you go to agree to the terms of service, for example, to agree to the terms before they give you access to the Wi-Fi. So let me the easiest way to explain a captive portal, because it's going to be on that exam, is by me showing you this. If you ever been to the airport, airport have these as well. But if you ever been to hotels, coffee shops, you probably have seen this. You try to connect it to the Wi-Fi, they direct you to some sort of a portal where you have to agree to the terms, or you give them your email, stuff like that. Well, that's captive portal, right? The Wi-Fi is still free. The Wi-Fi is still free, but before they give you access to it, you have to agree to the terms. So stuff like that is what it's what WPS 3 came to enhance. Right? It's what Wi-Fi 3 came to enhance. I'll tell you, if you connect it to a free Wi-Fi or you connect it to a captive portal type of a Wi-Fi, always use a VPN, virtual private network. VPN is going to create a tunnel. We'll talk about the tunnel. It's going to create a secure tunnel that allows anybody who's connected to that same network to not be able to see what you are doing. Right? We're going to talk about VPN in more depth. Some people are familiar with the VPN already. What if you're connecting this to the enterprise? What if you want to connect it to the enterprise within your Wi-Fi? Well, first of all, you're going to need a protocol that's going to allow you to authenticate. That's where EAP is going to come in. We sort of talked about this last night. The extensible authentication protocol. It's a protocol that is used to authenticate. So there is this EAPOW. This is EAP over wireless, over Wi-Fi. So this is going to be the protocol, but you will also need an AAA server. AA server that holds on to the usernames and passwords. Well, that's going to be the Radius or TACACS. What is the difference between Radius and TACACS Plus? See if you remember that from our conversation.
TACACS is Cisco's router.
Literally, I was just looking for that one. Thank you. If you can remember TACACS is Cisco, you're going to do okay on that exam when it comes to these two. Okay. All right, so you're going to need that as people are authenticating to the Wi-Fi, and you might configure 802.1x, which allows you to have these things, Radius and maybe Active Directory or whatever that you're using. Basically, you want people to authenticate. You want people to say, my username is this, my password is this. This is enterprise, right? Literally, you will pick WPA2 enterprise when you're configuring this stuff. EAP, let's talk about EAP a little bit more in more depth. So the biggest thing I want you to remember about EAP is a protocol that is used for authentication purposes, right? It's designed to provide interoperability, interoperable security devices and software. In another word, it allows devices that are manufactured by different vendors to be able to authenticate, right? To be able to authenticate. So EAP is great. EAP is super secure. So they have different versions of this. There's EAP over TLS. I haven't talked about TLS yet. I think yesterday I introduced this. I will talk about this in more depth. But TLS is the transport layer security. I told you last night, this is the protocol that is used to secure other protocols, TLS and SSL. But I told you TLS was better than SSL, right? So we can run EAP over TLS, which makes this thing even more secure because TLS is amazing, right? We use TLS to secure the internet, the web. HTTP it's secure through TLS, which becomes HTTPS. So there are some certificates, smart cards can get involved with this, where you swipe your smart card and now you're authenticated with everything. That's because this is doing the magic behind the scene. Both server supplicant must have the certificate. There's also the mutual authentication. And basically, this is the best authentication of them all. Best way of implementing EAP. There are a few other though, you know. So Cisco actually was like, oh, no, to hell with you. I'm going to come up with my own version of this. So they came up with EAP Fast. This is all Cisco. EAP Fast. But before that, there was a protected EAP from what's called Microsoft. So this is known as a PEEP. It's great. It's still secure. The only issue with this is that the server was the only one with the certificate, not the client. Right. So that was the issue with this. So they try to patch it up and come up with the different versions of this. But what most people end up doing was EAP TLS, the one we just finished talking about, or using EAP TTLS, which is similar to PEEP. This guy protected EAP, but give you more flexibility when it comes to authentication. And Cisco said, no, thank you. I will come up with my own version. They took the same technology, made their own, and then just call it EAP Fast with their own stuff. What do you need to know about all this? I doubt if this is probably on that exam, but you need to know EAP as the protocol used for authentication purposes. No matter which flavor we're using, just know we use this for authentication purposes. Last night, we talked about federation, and we also talked about radius. So radius federation, you need to know this is the AAA federated sort of like authentication solution, federated identity solution. If you remember federation and what we said, this is a way of allowing different institutions, different companies do the authentication. So radius federation is when we have radius servers that are used by different companies for authentication purposes, companies that are completely different. Okay. I think radius and federation might pop up. Remember, radius, because different vendors. Radius is AAA for different vendors, and federation is the idea of allowing different companies to share the authentication mechanisms. Rogue. Rogue is something that is not authorized, right? If somebody says, oh, this is a rogue switch, that means nobody put it there. That thing, I mean, somebody had to put it there, but that means it's not supposed to be there. It's not authorized. So a rogue access point is an access point that is not allowed. It wasn't supposed to be there. Maybe hackers put this, set this up. You'll be surprised. Hackers can actually go into the parking lot and set this stuff up. Set up like a rogue access point. Then as people are working in the building, they will connect to this thing and not knowing they're doing that. So rogue access point, troubleshooting access point to misconfigurations, disable unused devices and interfaces. What they're saying here, this is something that's not authorized. We should always scan the network to look for anything that's not authorized, including access points. Evo Twin, you got to remember this for the exam. Rogue access point, remember that for the exam. Evo Twin, remember that for the exam. Evo Twin is a rogue access point that is sort of like acting as the legitimate stuff. And what this actually means is that it's using the same Wi-Fi name, right? So whatever the name of your Wi-Fi at home, imagine if there's another Wi-Fi that is using the same name. It's like a twin. Like it's like people are twins, right? But it's evil. It's trying to trick you into connecting to the name. Okay. So we might use Wi-Fi analyzer. Wi-Fi analyzer, it's like Insider, the tool that I was showing. I didn't actually show you. Let me see if the tool ever came. Well, it never did. Maybe I forgot the password. So the Wi-Fi analyzer is a tool you can use to be able to see the rogue access points, to be able to see Wi-Fi names, and sort of be able to see who is copying your actually SSID, who is copying your Wi-Fi name in terms of EvoTwin. Remember EvoTwin for your exam. A bad Wi-Fi that is using the same SSID as yours. The same Wi-Fi name. Disassociation and replay attacks. Disassociation is when the bad guys are sort of like send a spoofed death packet. What that actually means is that they try to kick you outside of the Wi-Fi, like to get you to disconnect, right? So to get you to sort of like re-authenticate again. It's like, okay, you connected via your Wi-Fi, and then you receive this packet that kick you out of that Wi-Fi. And they do that to cause denial of a service, DOS. And if I kick you out of your Wi-Fi, then you don't have access anymore. Denial of a service. I'm denying the service. And they usually do this if they've set up like a rogue access point or something in hope you're gonna connect again, then connect it to their stuff instead of what you were connecting on, connected on. So disassociation attack, it's like the, kind of a, what's called de-authentication. Similar, but just cause station or disassociate. Yeah. Same stuff. Okay, we talked about IEV. I'm not gonna go into it right now. And this is not gonna be on that exam. This is just there. Jamming. This might pop up on the exam. Jamming is when you jam the signal, basically. So jam the signal so that legitimate stuff cannot connect. You're denying you're denying the service. You're doing DOS attack. It's like denying the signal so people won't be able to connect it to the Wi-Fi. Then you do that when you want to promote your EvoTwin. You want to promote your own Wi-Fi as the bad guy. How do we detect the jamming? We can use a spectrum analyzer. Spectrum analyzer can help us locate the source of the jam. Okay. Any questions? All right, let me go through D and I'll check your understanding and we'll go to our first break. 1.4 and 3.3 from that exam objective. All right, DDoS. Before we talk about DDoS, let's talk about DOS. DOS is the deny of a service. Deny of a service. So deny of a service meaning I can hack you into denying you a service. Right? For example, like I hack this computer to shut it down. I'm denying the service. Now it's not connected anymore. If anybody want to access it, they won't be able to do that. So DOS attack, it's when you do this to a machine. So a distributed denial of a service attack is when we're leveraging bandwidth from compromised computers to attack something. Usually there's the C2, the CNC, the command and control. Basically, these compromised computers receive instructions from command and control from the hacker's computer. So compromised host installed with bots, coming to this one, that can run automated scripts. So coordinated by the CNC network as botnet. This is the thing I hate about this, CompTIA stuff. When you just read over this, it's hard to understand what they're trying to say. But no, that's okay. So what they're talking about here, guys, is that your computer might get compromised and become sort of like a robot, right? Where it just receives instructions from some attacking group who've compromised that computer. So a bot is one computer that have been compromised that is just receiving instructions, and it's being used as part of this DDoS attack. Just know that a computer is one machine that is part of that army of these robots, army of these bots. And a botnet is that army of bunch of bots. So this could be like 1 million of computers. And what does this have to do with that? Well, imagine if you're using 1 million computers to talk to just one server. What do you think is going to happen to this one server? It's going to shut down. It's not going to be able to handle all the requests. So that's the idea of botnet. And then whatever this shuts down, well, that's the DDoS we're talking about. Overwhelmed with the superior bandwidth, number of bots, consumer resources with the spoof session request or scene flood. Yeah, so that's what they can do. So the hacker can tell these robots, we usually call them zombies, botnet. We usually call them zombies. It can tell these bots, hey, I want you to send a ping or scene flood to just this guy. This guy's receiving millions of those, it's gonna shut down. Distributed is distributed because we're using an army of these robots, an army of these little botnet. So how do you mitigate this? The one thing you need to know before you can mitigate this is that if you just block the IP address of where this is coming from, you probably will be wrong because they're gonna spoof that IP address. They have spoofed that IP address. So if you block that IP address, you're blocking the legitimate IP address. They can use like a cloud, right? Imagine if they use like a Amazon AWS IP to hack your computer that is in the Microsoft Azure. Well, you're not just going to go and block the AWS IP address. That's not good. You're blocking even legitimate stuff. So there's a couple of things we can do. One, bang this guy right here, sinkhole. Sinkhole means, okay, we're going to allow these things to come in, these little zombie communication come in, but we're not going to entertain them. We're just going to keep sending them into a sinkhole, like a hole that doesn't have an end. And keep going there, thinking they're going somewhere, but they're going nowhere. Okay. We can also configure an access control list, sort of if we know where it's coming from, and we know it's who is actually attacking us. Like I say, you got to be careful because the IP address could have been spoofed. But if we know, we can then configure access control list to slow down the traffic or denying the traffic and so on and so forth. Last mitigation is by just having everything in the cloud. The beauty of the cloud, guys, it can scale up and scale down. So they send you a lot of traffic, you can scale up to meet the demand. It's going to be expensive, but at least you can scale up. Cool. Load balancer. When we're talking about availability, part of that CIA, I mentioned load balancer. They said a load balancer is that device that's going to distribute the load. Distributed the load, meaning you don't want to have one server doing everything. You may have 3 servers that are configured the same way and then distribute the load between them. This is how the Google works, guys. Do you think Google, like all the requests, all the Google searches goes to one server? No, that thing has Google has millions of these servers. So your request go to this, my request go to the other one that's not busy, and so on and so forth. So they have a load balancer that distributed those loads. Okay. So a load balancer is going to be on layer 4 of the OSI model. Now that I introduced the OSI model, hopefully you remember what I'm talking about here. And then what you can do, there's a few things you can do. So you can do the round robin where it just pick itself, basically. Or you can tell this guy, hey, look, just want you to just send it to anybody, like a round robin thing. Or you can have the load balancer look for the best response time. Basically look at who is not busy. Who between these servers is not too busy. Let's send the request to them first. And for that to work, you're going to have what we normally call the source IP infinity, meaning you will configure the load balancer with the one IP address. All the requests are going to come to this IP address. Then you use the load balancer to basically distribute to the load. Okay. And these are going to have their own IP addresses, obviously, right? That's how you're going to be able to talk to them. Okay. Clustering. Clustering. Oh, Shayla, you raised your hand. Please go ahead.
Will the load balancer be on the switch or goes to the router?
Great question. So a load balancer is going to be on the layer 4. That's the transport layer. It's a completely different hardware, Shayla. It's not like a switch or router. Those two are great. They do what they do. A load balancer is completely different. A company that does this better than anybody, it's known as F5. Let me show it to you. And I don't know if you've noticed, but I'm just telling you what you need to know. I'm not going deep. So load balance, these F5 have these load balancers. This is what Google uses. Google uses F5 stuff. Right? And these are used for scalability. If you want the network to scale up, yeah, load balancers.
Thank you.
Mm-hmm. Oh, we're pretty much done. Good stuff. All right, so clustering. So configure nodes for failover. A cluster is just like similar stuff that we're talking about with the load balancer. Basically, what failover is that we don't want to depend on one thing, right? It's like that single point of a failure. We don't want that single point of a failure. We want to fail over something. So we're going to have to configure stuff where we have a redundancy. That's the word I was looking for. There we go. It's actually right here. So we have redundancy. So our clustering is like having a cluster of multiple things so that if one thing fails, there's another thing to take over. Right? So for that to happen, you might configure like a virtual IP. Virtual IP is going to be, you will use something like this one, the Common Addressing Redundancy Protocol. This is not going to be on that exam. It's just a, fancy way of saying you're configuring like a virtual IP, the infinity IP within a load balancer to help you with this stuff. The thing you would do though in a cluster, you might have, again, you'll have two of something, two or more of something. Once you have those two of something, you can configure them one to be active or another one to be passive, meaning one is being used, another one is just right there waiting for the first one to fail. Or it can be active, where they're both being used at the same time. They have the same stuff. Both of these are web servers. They're the same thing. Active passive means this one is being used, this one is on standby. It's just waiting for this to fail, and this is going to kick in. Right? Active means they're both being used. They're both, it's like that load balancer stuff we just finished talking about. We can also do the clustering with applications. again, we're trying to do the failover with the application, just like this, right? Multiple things. So the idea of a clustering, guys, I want you, whenever you see this, I want you to start thinking about redundancy. I want you to start thinking about using more than one thing. It provides sort of like redundancy, provides failover, provides availability. Last but not least, it's QoS. This you have to remember for that exam. Quality of service, QoS. So QoS goes by the idea of best effort of first in and first out, meaning, FIFO, right? What this actually means is that we can configure the bandwidth. Bandwidth, got to be here somewhere. Yeah, there we are. We can control the bandwidth and then prioritize the traffic. That's really what quality of service is all about. It's the prioritization of the bandwidth or the traffic. Okay, let me give you a good example, then we're going to move on. Imagine on your network, you have Zoom. People are using Zoom for video conferencing or, calling each other. Then imagine on the same network, you have email traffic. People are being sent email and stuff like that. Let me ask you this. Which one of these two traffic you will sort of like prefer over the others? Which one do you think needs more bandwidth? It doesn't like latency.
I would say Zoom.
And that would be correct, right? See, right now we are on Zoom. You want to see me talking to you right now, right this minute. You want to see how the lips, the mouth, I got everything like right now. Right? With the email, did nobody sit around and be like, is that email in the inbox? And just, right? So quality of service, we're going in, we are prioritizing the traffic. We're saying, okay, Zoom, you are real time. You are voice over IP. Therefore, let's give you more, bandwidth than email traffic. And we do this in the firewall. You can do quality of service in the firewall and in a router. Okay. So with this, you're going to have, traffic marking and traffic policing and so on and so forth. Really what this means is you're just you are prioritizing some traffic over the others. That's what really quality of service is all about. All right, any questions for me? Cool. Let me check your understanding and we'll go to a break.
A network administrator is setting up wireless access points in all the conference rooms and wants to authenticate devices using PKI. Which of the following should the administrator configure?
I said 802.
802. Michael agree.
Yes.
And that would be correct. Yep, it's PKI. They want to use cryptography. They want to use EAP, the extensible authentication protocol. If you do that, you start messing around with the certifications and stuff like that. 802.1x. Good job. Next question. Anybody else other than Karen can read for us?
I'll go. A user contacts the help desk to report the following. 2 days ago, a pop-up browser window prompted the user for a name and password after connecting to the corporate wireless SSID. This had never happened before, but the user entered the information as requested. The user was able to access the internet, but had trouble accessing the department share until the next day. The user is now getting notifications from a bank about unauthorized transactions. Which of the following attack vectors most likely used in this scenario?
I'm gonna go with the first one.
Was a rogue access point. That would be correct. Good job. There was an access point that's not authorized. They connected to it. They log in, meaning they give up the information basically. And now somebody took that information and went to the bank and helped themselves. That's exactly what happened. All right. Good job. Next question.
A local coffee shop runs a small Wi-Fi hotspot for its customers that utilizes WPA PSK, WPA2 PSK. The coffee shop would like to stay current with security trends and wants to implement WPA3 to make its Wi-Fi even more secure. Which of the following technologies will the coffee shop most likely use in place of the PSK?
I say SAE.
SAE. Good job. Good job. Next question.
A security analyst is investigating an incident that was first reported as an issue connecting to network shares and the internet. While reviewing logs and tool output, the analyst sees the following. And which of the following attacks has occurred?
MAC flooding, the third one.
That's the Mac.
Right.
Ooh, sorry. Did somebody say Mac flooding, you said? Okay. Yeah. This one is ARP poisoning. Right? So Mac flooding, it's when they flooded the switch with a bunch of different Macs. But what you're looking at here, my friends, this is an ARP table. Yep. ARP table. So what they probably went in, they poisoned this thing, and that's what that is. Okay. Next question.
After segmenting the network manager wants to control the traffic between the segments. Which of the following should the manager use to control the network traffic?
ACL.
Yeah, I got to choose this one too. It's just like the first one. All right, next question.
A security administrator is analyzing the corporate wireless network. The network only has 2 access points running on channels 1 and 11. While using an airdropping, the administrator notices other access points are running with the same corporate ESSID on all available channels and with the same BSSID of one of the legitimate access points. Which of the following attacks is happening on the corporate network?
Evil twin.
Evil twin. Yep. Oh yeah. Every time you see SAM, ESSID, BSSID, they're talking about the Wi-Fi name. Right. Good. Okay. Very good. All right, like I said, it's still information. So let's jump right into lesson number 10, implementing security network appliances. I sort of introduced some of those firewalls and all that good stuff during last lesson. So this is the section we're gonna dig a little bit deeper into. What is a firewall? Right? What is these other devices? What is a proxy? What a proxy does for security. So let's dive right in. Pop quiz.
Joe, a user at a company, clicked an email links that led to a website that infected his workstation. Joe was connected to the network and the virus spread to the network shares. The protective measures failed to stop this virus and it has continued to evade detection. Which of the following should a security administrator implement to protect the environment from this malware?
Say number 2.
Okay, so you're saying intrusion detection and prevention systems?
I say the last one.
You say Cosby? Okay. Karen, Nate? Anything different?
I'm gonna go with the third one.
You going with the C. Good choice. Yeah, good choice, Karen. So look, in the question, he clicked on the link, right? And he was connected on the network. Then the virus spread it to the network. They already have IDS IPS. So the protective measures failed it. So IDS IPS's antivirus programs, they all failed to stop this virus. And the virus have evaded, meaning has been successful into not being detected, they were unable to detect this virus. So which of the following should the security administrator implement now that a lot of these things have failed? You want to use heuristic or behavior-based detection. If you can detect something based on the signature, based on what's normal, you wanna detect that thing based on how it's behaving. And that's pretty good stuff. It could not have been CASB, because people call this CASB. It stands for something. I think it's oh God. I think it's like a common access security broker, something like that. But this is used to protect cloud. You see how like Amazon and AWS and Azure, like these things might not have the security you need. So you might use a CASB to give you those security. The cloud section, we're going to talk about that in that cloud section. All right, 3.3 on that exam objective. Let's start this conversation by talking about firewalls. Firewalls are interesting. Firewalls are mean devices, right? They're very mean because unless we tell them, hey, allow this to happen, usually firewalls just block everything. And they have a fancy word for that. It's known as implicity deny. We're gonna talk about that in a minute. Implicity deny. Implicity deny is implemented on firewalls by default to sort of like block everything. Like you, the person, have to go in there and be like, okay, hold on a minute, firewall. Let's allow this to happen. Let's allow that to happen. Let's allow that to happen. So you can do that based on access control list. We talked about this, right? Or you can do that by creating firewall rules. Those firewall rules are you're just going to select block or allow or deny, or that's literally accept or deny, block or allow. Simple as that. And what happened, the firewall is going to look at this firewall. It's going to look at, it's going to inspect the header of the packets, and it's going to look at the source and destination of IP address and the source and destination of the protocols. And then it's going to stop you or allow you based on what's in the header. So based on the IP address, based on the protocol and the port number, it's going to allow you or deny you based on that information. The beauty of a firewall, it does that on both the inbound and the outbound. Inbound is the traffic that is coming in. Outbound is the traffic that is going out. Right? So it's going to do on both. All right. So now that you know about firewalls, let's talk about this whole thing known as a packet filtering. So packet filtering firewalls, they're also known as stateless firewalls. I want you to understand that. They're known as a packet filtering and stateless firewalls because these were the very first versions of firewalls that they created. And these things literally did their job based on what you asked them to do. So you went in there and be like, allow this thing and deny this thing. Right? Look for this traffic. If this IP address and matches this IP address, allow or deny. So those are stateless. It doesn't deny stuff based on anything else other than those instructions you've given the firewall. That was the first version of the firewall. Then they came up with the second version. And this was a stateful. Right? The other one was a stateless. This was a stateful firewalls. I want you to remember that because they might ask you this, and I want you to remember the difference between the two. So this one was a stateful inspection, meaning it stores the conversation, it stores the connection as the devices are communicating from the inside or going outside. Okay. So the computer from the inside is communicating with the whatever that is outside. The firewall will remember that connection, will remember that conversation. So whatever packets that comes back, the firewall will only allow that to come in if there is an active connection. If there is something from the inside that I requested you, then I'll let you in. I'm not just going to let you in based on the rules. I'm going to let you in based on the connection that has been established. Think about weddings. You know, I don't know if you guys go to weddings and stuff, but in our African cultures and stuff, when there's a wedding, you must have an invitation. It's literally going to have a guy on the thing. But they used to do this in Africa. I don't know if they do it here. Where I came from, people can just show up to the wedding. You don't have to invite them just so they can eat. You know, so you had to have somebody at the door that asked them for the invitation. Like, okay, did they invite you? You know, the wedding people, did they invite you since you just showed up? You show the invitation, then you get in. You don't show the invitation, you get sent back where you came from. It's the same thing with the stateful inspection firewalls. You must have an active connection. Somebody from the inside have to request you before he will allow you to get in. Right? Then you have some that are like application layer or layer 7 sort of firewalls. We're gonna come back to these, but these were sort of inspecting the application traffic, meaning based on the actual application that is being used, I can stop you or allow you based on that. So these are specific, the application specific filtering. In high school, and this is what got my interest with computers. In high school, there was this lady who couldn't, like the librarian, you know, we could go to the library and do what we want to do with the library computers. She didn't want to let us do that. So she was blocking stuff. Then the students figured out how to go around it. And they share that with all of us. That's how I started knowing, oh my God, you can do this? So she will block YouTube and these video games websites, because when you connect it to them, it will go to HTTPS. So what we figured out was you can connect it to them using HTTP, not HTTPS. So then, you will go to it, then it will block you, then you will just remove the S, then it will let you in. That was like, when you're a kid in high school, that was like a dream coming true. So there are some applications where, okay, you want to go to YouTube. I'm not going to let you go to YouTube because you're going to YouTube, the application YouTube. You're trying to go to Facebook. I will not let you go to Facebook, not because I'm blocking HTTP or HTTPS. No, I'm not blocking HTTPS. I'm just not allowing you to go to Facebook.com. It's application aware. We will talk about this in more depth. Yep. But just remember those two, like specifically the stateful and the stateless. Stateful meaning it's going to remember the connection. Stateless, there's no connection. We just allow things. And as soon as you show up, if that thing says allow, you get in. There's nobody from the inside have to request it you. Then IP tables. IP table is Linux firewall. I want you to remember that. Linux firewall. That is host-based. So IP table, it's a Linux firewall that is host-based firewall on the Linux. Okay. So let me ask you this. What is the firewall on the Windows machines? What is the equivalent of IP tables on Windows machines?
Defender.
Defender. Thank you. Yep. So if you go here, just say Defender. I'm typing right. Defender. There you go. This Windows security, it's Windows Defender. You go right here, you can do some amazing stuff. You can allow things, block things, and configure those firewall rules we're talking about, and all that good stuff. Okay. All right, so how would you implement this firewall? Well, a couple ways. Firewalls appliances are usually found on layer 4 of the OSI model. But like I said, when you go to the router, you can maybe control, do access control list on the router. It doesn't mean the router is a firewall. It just simply means you can do that, the security, this ACL security at the router. You also have firewalls that are doing routing capabilities. It really depends on how the device is designed. Let me just put it that way. So we have appliances that are just firewalls. You have appliances that are like router firewalls integrated between them. You also have application-based firewalls. These are sometimes known as a host-based firewalls. Host-based firewalls are personal, meaning they are installed in your host, in your computer. Right? So the IP table that I just showed you, that's a host-based firewall. The Windows Defender that Shayla just mentioned, that's a host-based firewall. Okay. Then you have your application firewalls. Like I said, we're going to come back to these. These are application aware. But you also have your NOS, Network Operating System firewall. This is like the software that you will find in these firewalls appliances, like a proprietary software that is designed to do the firewall stuff. Okay. What do we use a firewall for this implementation? Well, we use that to segment the network. Remember, the firewall is the one that provides the security. When people are talking about security over the network, you start thinking about firewalls. It's true, because firewalls literally does the security. So we use this for segmentation. Once we segment the network, we have a DMZ, we have this zone, and with that zone, we put firewalls in between to help control how traffic flow within different zones. Then you have your proxies. Okay. I told you, the only thing you need to remember, probably not the only thing, but what you need to remember about proxy is a device that make request on the behalf of you, right? On the behalf of something else. So we have two different proxies. There is the forward proxy, right? Remember the use of a proxy, like I said, a proxy opens connections with external servers on the behalf of internal clients. Yes, yes, yes. So both the reverse and forward proxy, they do the same thing. They do the same thing. However, the forward proxy can do filtering, meaning there are some security we can do at the proxy. Yes, it's going to make some requests on the behalf of the clients. You're trying to go to google.com. It's like, hold on a second. You stay right here. I will go bring google.com and then I'll pass on Google to you. So because we are making the connection on the behalf of the client, we can then filter the traffic. We can double check to see what the client is asking. Like, hold on a minute. Are you trying to go to an inappropriate website? Right. So like there's some filtering that can happen, some sort of like a firewalling type of a stuff that can happen there. So that only happens with the forward proxy. The reverse proxy doesn't do any of that. The reverse proxy just do what proxies do. It just make connections on the behalf of the devices. Forward proxy is the most common one, by the way. So if you wonder, oh, what do usually companies use in the real world, is this guy, the forward proxy, because they can do some security to that thing. A little security there. You will configure ACL. I've been like, as we go on here, guys, you're going to start seeing some repetitive stuff, some stuff that I've mentioned already coming back. That's because it's going to be on that exam. And the reason why I mentioned it earlier is so you can start hearing it earlier. So ACL, we've talked about this over and over again, but these are rules that are created on the firewall or on the router. And the way it works is it's a top to bottom, meaning if you say deny everything at the top, that's going to be the end of that conversation. It's not going to get to the bottom. It's just going to deny everything. Right. And then, like I said, there's the implicity deny. Whenever you create these ACL in the firewall, there is an implicity deny, which simply means deny all. It's there, it's invisible, you don't see it. So by default, firewalls are configured to deny everything. We call that implicity deny. It's going to be on that exam. Okay. Deny everything. Again, whenever you make a changes to ACL, please document that. I'll probably, beg you, document. It would drive everybody crazy. For in a production, there's like hundreds of different rules, and you have no clue what they're doing. They tell you manage that network. You're like, oh God. Right. So, access control list. Another tech, it's NAT, right? NAT. Please remember, this is different than a NAC. NAC earlier was network access control, controlling who's accessing our network. This right here is the network translation. Remember earlier how I told you that IPv4, the last number with IPv4 was given out in 2011, but IPv4 is still in business? Like it's not going anywhere anytime soon? If you ever wondered why, it's because of this guy, NAT. So what they did, guys, look, what they did, they realized that they were running out of IPv4 and they were not ready to go to IPv6. So they came up with what they call a private IP addresses. Private. And these private IP addresses can be used by anybody. They don't have to be unique. They can be used by anybody. And then you can hide yourself. Like you can have like hundreds of things hidden behind just one public IP. All right, stay with me. So you have, let me go to CMD quickly. So right here, if I do IP config, actually, let me have you do this as well. Let's do this exercise together. I want you to tell me your Wi-Fi IP address. Does it start with the 192.168? Does it start with the 10.10 something? All right, each one of you can mute yourself and tell me what's your IP, or you can put that in the chat. I don't know if some of you are on your work computers. I know that some of these computers, they don't let you do that, but if you can just go into the CMD command prompt and type in IP config. If you are on the Mac, you will have to do IF config. Once you open up your terminal as well. You guys find it?
Yeah,
Okay. Karen, what is yours?
192.168.0.29.
0.29. Good job. Anybody else?
172.26.1124.
I like that. Let me note those down, guys. So Karen, yours was 192.168. I'm just gonna keep these two because this is the lesson. This is what I want to teach you. Yours, Shayla, was 172, right?
Yes.
Dot 16.
26.
Dot 26.
Mine also started at 192.168. Mine's the same as Karen's, so.
Gotcha. What about yours, Michael? 192 as well? All right. Yeah, me too is 192. So you can see we got the same numbers, right? So these are known as a private IP addresses. And let me go to Google and bring up a picture that's gonna help you understand all this better. Here's the 4 private. I'm not gonna spend too much time on this topic, guys, because, oh God, you can easily go into the rabbit hole. I want us to do that. If you get from what I just said, we are just gonna call it a day. If you do that, then you probably need to brush up your networking skills. Which is another thing. It's like, if you're gonna get into cybersecurity, you gotta learn the networking if you wanna do it, cybersecurity the right way. Because you're gonna be securing networks and you gotta know what they are. Okay, cool. So these are the private IP addresses that we're talking about. Again, remember, we're still talking about NAT, network address translation. I haven't tell you what that is yet because I want you to understand this. So with IPv4, guys, with IP version 4, the number can go from 0 all the way to 256. Let me teach you the right stuff. 256. And then some folks just will -2, then that's going to equal to 254. So any number you will see within IPv4, it goes from 0 all the way to 254. Let's not get into why we're -2. That's a conversation of another day, right? Just stay with me here. So the numbers that you're looking at here, the so-called private numbers, the one that begins with 10 or 172 or 192, these are within this range of 0 to 254. So what the government realized, we were running out of IPv4, and they said, hold on a minute. So let's do this. Any number that begins with a 10, we're going to make this private. Any number that begins with 172.16, we're going to make that private. Same thing with IPv, with this. So what they did, they introduced what we normally call classes. right? So they said, okay, well, you know, this with the 10 is class A, you know, with the 172 is class B, and 192 is class C. They also have class D and class E. Let's not go there. Just think about this, right? So this right here, these were private. And then they said anything else, unless it begins with what you see right here. And I highlighted just these two because these other stuff, it could be anything. Like for example, it could 192.168 all the way to anything here, and then it'll still be private. When I say anything, I'm talking about a number that goes from 0 all the way to 254. Right? They say 255. Let's not go there too. So, meaning if you see an IP address that begins with 1.1.1.1, that's a public IP. If you see an IP address that begins with a 2. Whatever, that's a public. If you see an IP address that begins with 11. Anything, that's public. If you see an IP address that begins with 10, that's private. Meaning anyone can use it. You can use it at home. I can use it at home. And guess what we're gonna do? We're gonna take all the computers that we have at home connected to this private IP address. We're going to hide them behind one public IP address. This is where the magic happens. This is where NAT has become the savior of IPv4. So what happens is you could have literally with this right here, I'm pointing on it like as if you're looking at it. With class C, this right here, you can have up to 65, I believe, like 65,000 computers. I'll bring that up. But with this right here, this class A, you can have up to 65 million computers. Like literally, this is what Walmart use. Like Walmart, it uses the 10 network because they have like a bigger network. So what this means is that you can literally, in theory, you can potentially hide 65 million computers behind one public IP address. That's what NAT, network address translation, allows you to do. Okay. So on to this conversation. Let me see if there's anything else I need to point out here. So everybody understands that if you see an IP address that begins with 110, it's a private. We're good on that, right? All right, so here's what I want to show you. Right now, if I go here and go to IP chicken, you can also do this. If you want to find out what your public IP address is, just go to IP chicken. They're basically spying on everybody. So if I go to IP chicken here quickly, this is my public IP address. For example, if I were to commit a crime using this computer I'm sitting on, yeah, I'm using AT&T. So AT&T have given me this. This is what you pay for. Every time you pay for the internet, you're paying for this. Now, though, at home, I have a TV on, I have a laptop on, I have a cell phones on, I'm sitting on this computer. We are using all of them at the same time. Each one of our computers are connected to a private IP address, but we're using this to get outside of our network. So we're using this public IP address to communicate on the internet. Okay, so my traffic, if I go to google.com, say I go to google.com, my computer went on the internet and get google.com. The traffic came back to me to this IP address, right? Because this is the only one that's routable, that is like on the internet, you can see this, you can send the stuff to this. But as this came back to me, you went to the router and the router was like, okay, well, it looks like it came from your computer. So let me go ahead and send that to your computer. And my computer happened to be on this IP address, 192.168.114.12142. If everything I said makes sense, great. If it doesn't make any sense, I would say that's okay as well. So let's go back here and try to make sense of a NAT quickly. So NAT is a network address translation. So NAT is the translator from private IP address to public IP addresses. All right. Remember, guys, how we said we said DNS, right? DNS. Then, you know, with the DNS, you can translate from what? Numbers to names, right? You know, domain names to IP addresses. Well, with the NAT, you can translate from private IP addresses to public IP addresses. Okay. So there are a couple of things you could do. You could use a source NAT, where you can maybe statically do that. You go into your router. NAT happens at the router, by the way. You're going into the router and configure this stuff, or you can let the router dynamically do this for you, right? Another thing you could do is PAT. Like, yeah, this can easily get advanced. I'm not gonna get into it, but this is literally using port address translation. It's like a cousin of NAT. The help NAT does what NAT does best. So in other words, guys, if my computer goes on the internet right now, it's literally taking the public IP address that I showed you, is going to the internet. But what happens if I want to use the phone at the same time? You know, that IP address is gone. My computer is using it for the time being. If I want to use the phone right now, somehow the phone also needs to get the conversation coming back to it. So that's where PAT comes in. It says, hey, hold on a minute. So instead of just keep using this IP address going out there, what if we use port numbers? That's where PAT comes in. These two technologies, NAT and PAT, are the reasons IPv4 is not going anywhere anytime soon. Right? So IPv4, it's here for, you know, for a good while. There are going to be some forwarding and, you know, obviously destinations and so on and so forth. Just remember, NAT is the address translation from private to public and public to private. Okay. All right, virtual firewalls. Like I mentioned earlier, everything is going into the cloud. So eventually everything have become virtualized, literally. Now, instead of having like a physical switch, a physical firewalls, a physical this, everything have becoming virtual this, virtual that. So these firewalls that we're talking about, oh God, there is a virtual firewalls. The company known as Palo Alto, which is like the best vendor of firewalls. If I go to AWS Marketplace, not that guy, this guy. There we go. If I go to the marketplace of a Palo Alto, I mean for AWS, and just search for firewalls. There we go. Palo Alto has this very famous firewall. It's right here, but this has been virtualized. Fortinet virtualized. Juniper virtualized. pfSense, this is free, virtualized. So what I can do, instead of buying the physical hardware, I can just spinning these up. But again, all the things that you're learning, it doesn't mean that they're useless. Once you spin it up, then you have to configure it. That's where all the other stuff we talked about comes in. It's just they are virtualizing everything. That's all. Because now everything is going to the cloud. They're virtualizing everything. Open source. Open source means it's free. I probably should say free. It means it's yeah, it's free. It's developed by the community. That's what open source means. And then proprietary means it belongs to a company. So the IP table firewall within Linux, that's open source. The Windows Defender, that's proprietary. That's closed source. It belongs to what? Microsoft. Right. So whenever they say open source, that means it's developed by the community, managed by the community. Everything is done by the community. Nobody gets paid. They're volunteering. Cool. Any questions with this section before I go on to the next one? Let's keep going. Topic B, implementing network security monitoring. This is the good stuff. 3.3 on that exam objective. So network monitoring. The first day of this class, I told you visibility was important. Like I told you the statistics of hackers staying in an environment for 23 months. It was unacceptable. There's no reason they should be staying in an environment for over 23 months and we don't know they're there. Part of the reason why they do that is because we're not watching, right? We want to be able, whenever something bad is happening on the network, we want to know it's happening. We need that visibility. So there are some devices that we use for that. One of it being the IDS, Intrusion Detection System. It's in the name, detection system, specifically designed to detect the bad stuff, detecting intrusion. And there is also intrusion prevention system. We'll talk about that. But for us to start detecting stuff, we need sensors. We need to put our sensors in different locations so they can capture stuff in real time as well. So IDS, it's a device. It could be hardware. It could also be a software. We will implement that in our environment. It's going to do like passive logging, where it's going to be watching things in real time and alerting us, telling us, this is what I see. You ask me to tell you if I see something bad. I just saw it. Here is a notification. That's the IDS. It's not going to stop anything. It's not going to do it. It's just going to let you know this is bad is happening. And I thought you might want to know this. So we would need to put sensors in places. So maybe inside of the firewall, in front of some sort of like a server. Like we just need to put and the sensor is like the collector of these, logs, if you will, right? So on the switch, we might want to do what we normally call a span, which in other words is like a mirroring port. We're going in and we're telling the switch, hey, look, everything you see, send a copy here. Right? Send a copy here so we can send this to the IDS to look at the traffic and see if this is good or not. Right? Passive tap and aggregation tap, again, we're tapping it, we're like literally just like telling the switch to mirror the traffic and just send it to us. So that's the IDS. Then you have your IPS, Intrusion Prevention System. So these are prevention. It's also in the name. It's going to detect the intrusions, but it's going to also prevent it from keep moving forward. So it's going to stop known malicious. The keyword here, it's known. So the way IDS and IPS do their job, it's based on the signature. I mean, they have a little database of known bad stuff. If it matches with what they have in a database, then they're like, oh, no. Here is the alert in case of IDS. In the case of IPS, it's going to tell you, it's going to stop it. So this one is a prevention system. It's an actively responding to threats. Just like the firewall, it has some filters and some things, and it can slow down the traffic, and it can modify the packets, and it can do a lot, basically. So the beauty of IPS, it's an inline, like we have to place this in line. In another word, it's like right there watching what is happening and then stop it in real time. It's inline the conversation. If you ever wondered, so what are two best that does this? Let me present this. There is a Zik. They used to call this thing bro. So if you're ever enjoying going into the blue team, the defense, everything we're talking about right now, it's our blue team. Zik is like open source, is free. It's the network security monitoring. Exactly what we're talking about. There is this Suricata. This is real world stuff, guys. Suricata, it's another one. And this one is both an intrusion detection and intrusion prevention system. And the beauty of Suricata, and the reason why a lot of people use it, it's because the logs that Suricata give you are small, like very tiny. So they don't fill up your storages and stuff. So people, they love Suricata so much. I like it. Right? It's pretty good. It's free. It's open source as well. So if we go back to this and look at how these do their job, literally, look, they do these things based on the signature, meaning they have a little database, a little kind of a database that have the signature of bad stuff, database of known attack. Then they match, they match with their database as things come in and go out. The issue with this is that the database must be up to date. The other issue with this is if there's a 0 day. What is a 0 day, everybody?
Where the vendor doesn't have a patch for it yet.
Absolutely. So if a 0 day shows up, there's no signature for it, that thing is gonna just walk right in. Okay, so that's the issue with this. So we can do detection. I mean, signature based are great, but we might want to do behavior based or anomaly based. Some of these IDS and IPS, they also support this, the anomaly based, where we train the sensor to know what's normal, like to know what is the baseline, to know like how this network usually behaves. So whenever it sees some sort of anomaly, then it can let you know. It can tell you, hey, this doesn't look normal at all. Okay. So I think there was a question at the beginning that, asked about this stuff. Where they're like, oh, it was trying to get in, nothing managed to stop it. What could have detected this thing or what could have stopped this thing? Well, if the IDS or the IPS was doing behavior or anomaly based, it would have stopped that because it would have seen this thing is behaving differently. What this does is establishes a baseline. A baseline is like what's normal to us. So normally when people are working, the traffic is at 50%. So it's gonna learn that. If one day the traffic goes up to 90%, that's not normal. It's then gonna kind of look at the thing that is making the traffic go into 90% and let you know about that thing. So this is great. It's being fueled by machine learning, the new technologies that they're doing. It's being fueled by artificial intelligence. They even have the UEBA. This is the user entity and behavior analytics. Great technology. I can't say enough good stuff about this. Literally, they have behavior in the name. It's hard to predict what humans do, but with this technology, we're getting closer to know this is how normally Michael behaves. So if we see Michael's account is behaving differently, then we need to investigate that. Okay. And that leads me to the next generations of firewalls. So we talked about content filtering firewalls. We talked about not content. We talked about stateless and then stateful firewalls. Both of these were great, but they said, you know what? I mean, we can just keep upgrading. So what they did, they said, okay, well, let's just make one and just be done with this. So they came up with the next generations firewalls, next gen firewalls. These are like the best of the best firewalls. These are the firewalls with all the bells and whistles, all the security you can imagine about firewalls is built into this thing. So it's an application aware, there's a filtering, there's user account based filtering, there's the intrusion prevention inside, there's a cloud inspections, there's all kinds of stuff inside of the next generation firewalls. Okay. So these are firewalls that are doing a little bit more. But then there's this other thing known as UTM. UTM are Unified Threat Management. Unified Threat Management is a device that act just like next generation firewall. UTM is a device that combines a bunch of security stuff into a single hardware or single platform. Okay. The way it differs from a firewall is that UTM can be acting as a firewall and as a lot of other things. right? A lot of other things. It can be doing the intrusion prevention, VPN, cloud, spam, filtering, DLP, data loss prevention, content filtering, URL filtering, you name it, it's in the UTM. Let me ask you this. If we have a device that does all this, what is the issue with that device from a security perspective?
You're putting all your trust in one system.
Yes. And then what is the issue with that? What happens if that thing dies?
You lose everything.
Yep. So there's that single point of a failure. Not good for security. It's okay for small businesses. Let me be clear. Small businesses, yes, right? Because buying these separately and configuring them is expensive. So you may want to buy one thing that does all that stuff for you. But not good. So remember UTM for your exam, Unified Threat Management. And content filtering, it does what it sounds like. We're filtering through content, URL, and stuff like that. All right, so the thing about the IDS, IPSs and stuff, so we have a network-based IDS and IPS. These are network-based, meaning we put them on the network. So basically, they watch the network, right? But then you have host-based. What is a host? Anybody?
That computer.
Your computer, right? So host-based IDS are just IDS that are installed in your machine, in your computer, right? So pretty good. They're really good for FIM, for fire integrity monitoring, meaning if somebody changes a file on that computer and you want this thing to alert you, it's going to alert you, right? But actually, we do this in the real world where we set up like a decoy of a file. Which is another way of capturing inside a threat. If you ever suspected that somebody's doing something they shouldn't be doing within the company, you set up a decoy. Like you set up a file, then you monitor that file. Then you will call that file finance or data, right? Something like that. And then they're gonna go in, try to open that thing. And as soon as they open it, bingo, we got him. Right. So even with the regular hackers, we do that. We set up like a file. We call that thing password. And then we just put that in a system somewhere. Once they get in, that's what they're gonna look at first. They're gonna scan your environment to see this thing known as password. They're gonna, ooh, let's open this up. They open it up. We receive a notification. Then we catch them that way. So that's decoy. So it's great to have these within the environment and then looking at who's making changes to the files. Right. And then we do that with, hashes and all that good stuff. Right. So with the host-based, we have host-based intrusion detection systems and host-based intrusion prevention system. I want to make sure that's clear. So we have HIPs and HEADs, then we have NIPs and NEADs, network-based or host-based. What about for your web applications? Well, we have firewalls that do nothing other than protecting your web application. We call these WAF. Web application firewalls. They're able to inspect the code. They're able to look at the HTTP packets. They're able to literally look at the software that is using the HTTP. These are designed to stop all the web attack. If you remember when we're talking about the OWASP top 10 attack, if you worry about those attack, just put this baby in place and you're done. Right? It's literally designed to stop web application attacks. Okay. Any questions? I'm going to bring up the OWASP top 10 and just share that.
Hey, Francois.
Yes.
So when you're talking about the decoy file. Is that another way you can call it a honeypot?
Good question. Actually, they call it a honey file.
Honey file. Okay.
Yeah, because a honeypot is a computer.
Okay.
That is acting as a decoy. So that would be like a honey file.
Okay.
Good question. All right, so this is the web top 10 web applications, right? Top 10 web application security risks. How you protect these? WAF, right? Web application firewalls. There was a guy, I don't know if I told you this already, who was tasked with securing a vulnerable server. I'm saying this as I'm sharing this. So the company hired him. They say, hey, look, this is a 2003 server. We want you, a web server. We want you to secure it. We don't want you to tell us to upgrade to the latest. We know that already, right? We know that. We don't want to do that. We want you to secure this vulnerable server. And guess what he did? He grabbed the WAF. He put that thing in front of the vulnerable web server, and then he stopped all the vulnerabilities. He protected from all the vulnerabilities. All right, good. We're almost done. Good stuff. All right, any questions about that section before I move on and talk about CIEM, SIEM? Great. Topic C, it's all about CIEM. Who is here have heard about Splunk? Splunk or Elastics, Elk or Elastic. All right, so let me show you this. A lot of the things that I tell you in this class, guys, it can easily become a career in itself. All right, that's why I told you in the beginning, once you finish with the Security Plus, specialize. Right? Talk to somebody who's been there, done that. Let them help you into the whole process. Don't go through this by yourself. You're going to spend so many years trying to figure this stuff out like we did. You don't want to do that. So specialize into some things. For example, you're going to become a Splunk engineer, literally, which if you, with the right focus, you can literally easily do this within like 6 months to a year. And these people are making like over $100,000 a year. And all they do, they literally just focus on implementing Splunk and pretty much like really good on Splunk. Right? And that's what that section it's going to be all about. But so that's just Splunk. You can become a firewall engineer and then be making some killer money. That depends on where you are. Well, in Georgia, they don't pay that much. Right? But it looks like you can easily like make some really good money by specializing in something. So understanding the overall, then just take one specialty and just focus on that. That's how you want to approach this career. All right, so Splunk. Splunk is a SIEM, it's a CIEM. A CIEM is like a search engine for your logs. It's like the Google for your company. If you want visibility, you want to know what is happening within your environment, you want to use a CIEM, a SIEM. And the Splunk, I keep mentioning Splunk. Splunk is because they own this market. They're the king of this stuff, right? So what they do, they give you a software that looks like this. Probably bring this up. And let me go to image. There we go. There we go. Not sure if you can see this, but if this is big enough. But they will give you a software that looks like this. And this is the CIEM that I'm talking about. CIEM. It's a centralized location for all of your logs. And the reason why I say it's the Google for your logs, you can search through them. So basically you can ask everything in your environment, hey, tell me, what do you see? Like what's been happening with you? Your firewalls are going to report the logs here. Your computers are going to report all their logs here. And all you have to do is just ask this guy, okay, what do you see? These things have dashboards that tells you how messed up things are, which device it's at risk, So basically give you that visibility that we were talking about. You have a visibility within your environment. And it looks kind of cool. I like the GUI compared to doing this from the command line. I like this better. So Splunk is one, and Splunk is not free. It's actually very expensive. That's why if you become the engineer, you make some good money. What's free is Elk. Elk from Elastic. So they made their stuff free. And if you ask a lot of people, they will tell you it's better than Splunk. I happen to believe that's true. Because it's, if you want to use their stuff, they have a cloud environment where you're going to have to pay them money. They have Elastic Cloud and you pay them money, you deploy all this. If you want to use their stuff for free, you will, which is not a bad recommendation. If you work for a small company, you want to recommend them using this as their SIEM. You deploy this, you become really good at this, you're going to be very employable. Security Onion. Let me go bring this up. So Security Onion, it's like the Kali. It's like the Kali Linux, but for all this stuff that I'm talking about. So it comes with your intrusion detection systems, intrusion prevention systems. It comes with your Wireshark for PCAP. It comes with your Elasticsearch, right? It comes with the CIEM that I was showing you, this Elastic stack. All of it's right here. This right here, Kibana, which is, right, this is Kibana right here. Out of that Elk. Whenever they say Elk actually stands for Kibana, Elastic, and Beats, and yeah, right. Anyway, so Security Onion, it's another one. Dropping all these right here, just in case you want to dig deeper. You can start maybe focusing on these. So you do this, you become the defender, you become the blue teamer. 85% of all the jobs in cybersecurity are in blue team. In blue teaming. Blue teaming means you are the defender. Okay, now let's get back to the lesson. So CIEM, 1.7, 3.3, 4.1 from that exam objective. So you want to monitor your environment, right? You want to make sure you have a visibility on your environment. Couple of things you could do, including capturing the packets. So you could use a sniffer, something like Wireshark. I showed you Wireshark. I showed you how to capture stuff with Wireshark. Use Wireshark, you capture stuff, then you analyze it. Good stuff. You get visibility that way. Now you know who is not using the secure protocol. You will know that from doing that. You could network monitoring, where you have some sort of like appliance that you're using on your environment. Like you have these appliances that you're using on your environment, and these things are reporting what they see. So your router is reporting, your switches is reporting, your firewalls is reporting, your IDS is reporting, your IPS is reporting, your computers, regular host machines are reporting. You collect all these logs, all these reports that they're reporting, you send them into the CIEM. You send them into Splunk. CIEM stands for something, we'll get to that. You send them into Splunk, you send them into Elk, the Elasticsearch, Elk, and you do the analysis from this location. Because I tell you, it will drive you crazy if you have to visit each one of these devices and do the analysis from them. You couldn't do it. It's hard to find what happened by doing that. That's why we will log everything and just have like a bird's eye view of like a centralized location of everything, and then just do it from there. So if you were wondering, okay, what does this SIEM thing stands for? This is it. Security Information and Event Management. All right, Security Information and Event Management. That's CIEM, SIEM. So literally, you are collecting the logs from different devices on your network. You are collecting them as events. And it depends on what's inside of the log, that can turn into an incident, to turn into something bad or something good. It depends on what's in the log itself. So, but how do you collect this? It could be agent-based, meaning you install some kind of an agent into computers, into firewalls, into these things. Right? So you can have like a Splunk agent installed into each one of the devices on your network. Or it could be through a listener, right? Using something like syslog. We'll talk about syslog, where syslog will collect the events, the logs, then it will send it out to the SIEM. You didn't install any agent. You're just listening by syslog sending that to you. It could be through sensor. We talked about IDS and how IDS have sensors and how we can put those sensors into different locations. Well, we could collect these events through sensors. Okay. Once we've collected the events, these logs, we have to aggregate them. Right? Again, that's done within the CIEM. Look, the logs from different locations are going to come with the different formats. They're going to come through different formats. They're going to be from different software. For example, if you look at the log from like a Windows machine and the log from a Linux machine, oh my God, they're completely different. So the beauty of a SIEM is going to aggregate all that information. It's going to normalize it, meaning making easier for you to be able to find what you're looking for, right? And then it's going to kind of it's going to synchronize the time within all the logs. So if the firewalls is reporting, the routers is reporting, it's going to tell you, okay, the firewall saw this at this time, and then the router saw this at this time, and then this other thing saw this. You will have all of that in the CIEM, the SIEM, and then you would do your investigation. So as you can see, I'm talking about this as like someone who's so passionate about this. It's because this is the most important tool of them all. Everything I've taught you, if you're trying to get your foot in the door, you have to know about CIEM, about SIEM, right? It's very important. So once you did the aggregation of the logs, then you want to do the analysis, right? This is where you go into the SIEM and start like correlation, meaning relating security data and with the threat intelligence, meaning you're going in, you're looking at what all these things have reported, and you're comparing with the intelligence that you've seen maybe from online, and then you are determining, okay, well, did this bad thing really actually happen? Right? Making you basically it's helping you making that decision. You are going to get the indicator of a compromise, meaning let's say that you follow this guy on Twitter and then he says, oh, there's this attack that is happening right now, and the bad guys that are attacking is this. Well, you got that intelligence. And this is the IP address that they're using. Well, you got that intelligence. You will take that IP address, which is the indicator of a compromise. You will go into your SIEM. You will start hunting. You'll start searching for that thing, that IP address. Okay. Now, because obviously technology doesn't stop, they're taking this thing to the next level. So there's some machine learning that has been integrated within the SIEM to help you do your job better. There is UEBA that's being integrated within the SIEM. This is the user behavior analytics, meaning that's to detect stuff based on how the users behave. And they're going in, they're also using AI, artificial intelligence. They're integrating all that in there too, which is great. The good thing that they're integrating that you will need to know for that exam is this guy right here, the SOAR. Right, SOAR. SOAR, it's interesting. What they noticed was cybersecurity people don't know how to program. They don't know how to code. So they said, okay, well, what if we build them something that can help them automate stuff on the fly, right? And SOAR was born. SOAR stands for Security Orchestration, Automation, and Response. Yeah. Like I said, I mean, this actually is a little bit better compared to the TAC and all the other stuff. This is better. So what I need you to focus on is the orchestration. And remember this for that exam. Orchestration and automation. These two. Whenever you do your CIEM, it's looking at this stuff. Whenever these logs are coming in into the CIEM, well, what if there's a way to automate what it sees and then be able to respond based on what the SIEM is receiving? Right. So because the cybersecurity people didn't know how to program, they designed these things like sort of like a drag and drop. Let me show you this. And we're done, guys, I believe. Yeah, we're done. Then we're gonna go to lunch. Splunk SOR. Splunk literally bought this company. The company is known as Phantom. This name that you're looking at here, Phantom. It's what Splunk bought. The company specialized in SOAR, so they bought Phantom, then they integrate Phantom within their products, which was a smart move for Splunk. Splunk. Let me find a good one. I can show you SOAR. God, these are too small. All right, let's try this. Image. It looks all right, but it looks not clean. All right, well, I'll use this. All right, so this is the SOAR that we're talking about. This, like literally this. So the orchestration part of a SOAR is you dragging these right here. Instead of you programming these, scripting these, you're just dragging these right here. And what these are the if. If you know anything about programming, it's about if this, then what, right? So you're going in, you are saying, okay, listen up, Mr. Splunk. If you see a malicious software, if you see some kind of a virus, step one, I want you to notify me. Step two, I want you to quarantine this thing. Right? Step three, I want you to try to see if you can fix it. If you can't fix it, I want you to send me an email. If you can, so it's a bunch of if this happened, then what? Then this, then this. The beauty of a SOAR, it's gonna automate this. So basically, you could be sleeping and somebody's hacking you when you're sleeping, and SOAR is gonna respond to that. All right, that's the beauty. So they're trying to automate the response of this, right? So that's the beauty of SOAR. So they're gonna ask you questions like, oh, a company doesn't have enough employees, right? It's just one-man show, and they wanna be able to respond to things quickly, or they wanna be able to save some time on doing other, manual stuff. SOAR, all day long, SOAR. Orchestration and response. All right, cool. Last thing we're going to talk about is how to manipulate files on Linux. You probably have seen me using cat. Cat is used to view stuff on Linux. Head is for you to view the first 10 lines of stuff. When you're reviewing logs, you don't want to review everything. You may want to just review the first 10 lines of the logs. That's head. Head is the command you will use. Tail is for you to view the last 10 lines, the last 10 lines of something. Logger is a way of creating a log. You can write a log for your Linux. Everything we're talking about here is on Linux. grep is a way of searching through Linux. And the search engine of Linux is grep. You can grep something, it's going to find it for you and bring it back, and bring it back to you. I doubt if this is going to be an exam. They might ask you some questions like, oh, you are analyzing a log, and then you don't want to view everything. You just want to view the first 10 lines of the log. If they say the first 10 lines, it's head. Head is the actual command you use. If they say, oh, you're looking at the logs and you want to see the last thing that happened, is tail, right? You want to see the last thing that happened. You want to see the last lines. All right, questions for me? Guys still with me? All right, stay with me. Let me check your understanding, then we'll go into lunch.
A pharmaceutical sales rep logs onto a laptop and connects to the public Wi-Fi to check emails and update reports. Which of the following would be best to prevent other devices on the network from directly accessing the laptop? Choose two. I'm going to go with VPN.
Out of the DVPN, choose two. Give me another one.
Yeah, I'll say the firewall.
Firewall, host-based, and VPN. Check, and you guys are correct. Good job. So what is happening here in the question where you guys choose, host-based and VPN?
When I chose VPN, I was looking at how it prevents other devices on the network from directly accessing the laptop. I have experience with that where I use a direct connect to the VPN for my organization. So that's what I thought of when I chose that answer.
Gotcha. And just like not to really get ahead of myself, because I believe the next chapter is all about VPN. We haven't talked about VPN yet, but if you're going to be connecting from public Wi-Fi, that means it's a free Wi-Fi. Yeah, VPN all day long. Okay. Nate, why host-based firewalls?
The same thing, basically that end of the question. You don't want other people getting access to your laptop. And firewall do that.
Host-based, right? It's in the laptop. Let's use it. Good job. Next question.
The CISR is reviewing the lessons learned from a recent incident. A worm was able to spread unhindered throughout the network and infect a large number of computers and servers. Which of the following recommendations would be best to mitigate the impacts of a similar incident in the future?
Is B the second one?
Segment the network with firewalls. Okay. Good job. Remember segmentation. Next question.
An organization plans to transition the intrusion detection and prevention techniques on a critical subnet to an anomaly-based system. Which of the following does the organization need to determine for this to be successful?
I say baseline.
Baseline. You guys were paying attention. I thought you were tired, but this is good stuff. All right, good job.
A network administrator has been asked to design a solution to improve a company's security posture. The administrator is given the following requirements. The solution must be in line in the network. The solution must be able to block no malicious traffic. The solution must be able to stop network-based attacks. Which of the following should the network administrator implement to best meet the requirements?
I'd say the NIDS, because we're talking about the network.
Yeah.
Is it NIPS?
It is going with NIPS.
It's
Yep. Yep. NIPS. NetY NIPS. So it's right here. If you send something, you're on mute. Right here, they said the solution must be able to stop. Right? Needs is detection. You're on the right track, right? They talk about the network and the right track. This is detection, this is prevention, right? Yeah. So, oh, next one.
Joe, a user at a company, clicked an email links that led to a website that infected his workstation. Joe was connected to the network and the virus spread to the network shares. The protective measures failed to stop this virus, and it has continued to evade detection. Which of the following should a security administrator implement to protect the environment from this malware? Yeah, I believe we did this one, the third
Sure.
one.
Mhm.
Yeah, I was like, okay. All right, good job. Keep getting the knowledge. So the goal, like I said, is to finish this one and then jump to 12. So try to hurry up. Lesson 11, secure network protocols. I know in the past I told you about protocols and I kept asking you, which port is this thing? And you're like, port 80. Well, this is the chapter where we just talk about nothing but protocols. So the protocol that are within this chapter are the ones you just need to know for the sake of that exam. Right? There's over 65,535, like literally, of protocols and port. And this is just for TCP. There's another 65,000 for UDP. Yeah, you're not gonna memorize all that. Memorize few that are important to you. All right, pop quiz before we dive in.
A network administrator would like to configure a site-to-site VPN utilizing IPsec. The administrator wants the tunnel to be established with data integrity, encryption, authentication, and anti-replay functions. Which of the following should the administrator use when configuring the VPN?
I'm gonna guess and say DNSSEC.
Yeah, I'll say DNS too.
Okay. DNS security. That's what that stands for.
I'm gonna guess AH.
SH, authentication header. All right, well, this is a pop quiz, so let's see the answer. And ouch, ESP. Yeah, for a lot of you, like, I don't even know what that stands for. So I'm not even gonna pick that one. Yeah, so guys, look, when it comes to VPN, the only way to secure VPN traffic is using IP security, IPsec. And the IPsec have two modes. Like literally, what I just summarizing right now, it's everything you need to know for the exam. We will get to the IPsec section, to the VPN section, and then adding a couple more to it. But if you remember this, you'll be just fine. So VPN can be secure using IPsec. IPsec have two modes. One of the modes is AH. So Shayla picking AH, you were very close. The issue with AH, it doesn't do any encryption. AH is the authentication header. This only does integrity and authentication of the header of the conversation. It doesn't do any sort of encryption. Now, this right here is the encapsulation, I think, security payload. This right here, encapsulation security payload. This is the mode of IPsec that if you configure IPsec in the ESP, you are doing encryption. So the biggest difference between ESP and AH is encryption, only encryption. Okay. Now, DNSSEC, yes, for DNS. You want to secure DNS traffic, then let's use DNSSEC. All right, DNS security. This is EDR. This is the endpoint detection and response. We will talk about this. This is like a replacement for your host-based firewalls and your antivirus program. And AV. They're trying to replace these things by introducing this thing known as endpoint. Endpoint meaning your host, endpoint, your computer. Detection and a response. These two can detect and respond to things on your endpoint. All right, let's get going. So 1.43.1 from that exam objective. Let me see what time is it. See how fast I need to go. All right, cool. So let's start with DHCP. I told you we were going to talk about DHCP. Who here have heard about DHCP? Raise your hands if you have heard about DHCP. Hands, okay. All right, so this thing stands for dynamic, keyword dynamic host configuration protocol. Here is the only thing you need to remember for this exam. DHCP is used when you want to dynamically assign IP addresses to computers. See, you can assign IP address to computer manually. But what if you have 1,000 of them? What if you have 10,000 of these computers? But you can't manually do that. So that's where DHCP comes in. It's dynamically host configuration protocol. It's literally used to dynamically assign IP addresses to computers. Yep. For the DHCP to do what it does, I'm going to mention one more thing, and this might pop up on the exam. It uses what it normally calls DORA. And there was some sort of a cartoon, you know, like Dora Explorer, right? Maybe that might help you remember this one. So DORA. So DORA usually, the D stands for discover. So the D is for the discover. O is for offer. R is for request. Or O is not for off, it's for offer. R is for request, and A is for acknowledgement, ACK. That's the DORA process. That's how DHCP works. So what happens is we want to dynamically assign IP addresses to computer. Great. How do we do that? We do the DORA process. So the client is gonna sort of ask, hey, is there anybody here who can give me an IP address? And when I say a client, I'm talking about your computer. Okay, is there anybody here that can give me an IP address? Then the DHCP server is gonna be like, yeah, I got some numbers here, I can give you one, right? And then they're just gonna offer that. Then the client is gonna request it, and then the DHCP server is gonna acknowledge that. Like, okay, you want one? Here is one. We normally call that leasing the IP to the client. It's like the IP is being leased, I think, for about 8 days. The IP is being leased to the client for 8 days, right? If we don't have enough IP addresses within the DHCP, well, we can take that IP back. Usually that's how it works. If we have enough numbers, then we will let that device have that IP address. All right, so why is this here? Why is this important for security? Well, look, the bad guys can also do that. So they can present the rogue a DHCP server, meaning a DHCP server that is not authorized. And then they can be offering these IP addresses to your client machines as well. Not good. And DHCP can prevent things such as, sort of like a DDoS attack. I don't want to say they really prevent a DDoS attack because like it just give out IP addresses. That's what it does, right? And it can do what they normally call a starvation attack, basically meaning not giving clients the IP addresses that they're requesting, especially if they think those clients are rogue clients. That makes sense. All right, anyhow, just remember the DHCP server is used to dynamically give out IP addresses, and it uses the DORA process to do so. If you are running a DHCP server, make sure the administrator interface is secure. Okay. That's DHCP. DHCP is port. Ooh, I want to tell you what these are. DHCP is port, I think, 69. All right. Runs on port 69. This protocol DHCP, it's on port 69. Wait, is it 69? Hold on, let me verify that for you. What is the DHCP port number? Yeah, 68, 69. Okay, I mean 67 and 68. So just do 68. 69 is it's an SNMP, Simple Network Management Protocol. That's 161. Okay. All right, so 68. You just sort of remember that 68 is the DHCP. Wanted to be so sure. All right, so you gotta memorize that one. All right, another one is DNS. We talked about DNS. This is the name resolution. So DNS is used to resolve names, host names, and IP addresses, like we said before. And DNS can be found on port 53. Oh God, it's afternoon and I'm running blank. I believe it's 53, but I'm not convinced. DNS, yeah, 53, good. DNS is 53. DNS 53 is the port number associated with the DNS. Okay, so remember what we use a DNS for. That's one, DNS. And then remember it's a 53. And remember it's not secure. Similar to DHCP, if you use the 68 port number, it's not secure. So okay, let me talk about this. So domain hijacking. Domain hijacking is when someone gains control of your domain. Remember, DNS is used for these names and IP resolution. So if somebody take over your domain, they can redirect traffic to certain things and kind of sending people into different locations, all that stuff. If somebody takes over your DNS, you are in big trouble. You're done. Because DNS literally is doing the name resolution for a lot of stuff on your environment. Does your URL is this thing right here, like the www this guy's domain.com. That's a URL. So hackers can also sort of like abuse that, be able to like redirecting folks that can get access to this HT access, then be able to redirect folks. This really doesn't happen as much because nobody uses HTTP anymore. We use HTTPS, which this doesn't work. Domain reputation, this is huge. If somebody takes over your domain, like I said, it could be added into the blacklist because they can use your domain to be able to spoof, to be able to attack other things using your domain. And therefore, the domain is going to be added to the blacklist. When I was working for Trenton Health Team, this have happened to us. Literally, our domain was used to hack other companies, and then Google put us on a blacklist. We couldn't receive no email until 24 hours. Literally, they give us 24 hours. Call Google support, like there's nothing we can do. Gotta wait 24 hours. Right? The leadership were pissed off, like really pissed. I remember the CEO like, I have some time sensitive emails. They got to be there. I'm like, well, there's nothing I can do. All right. DNS poisoning. So if they poison your DNS, right? They poison your DNS, like I keep saying, you're in big trouble because they can do redirection. They can redirect people to different places and stuff. How do they poison your DNS? Well, if they manage to be in the middle of the conversation, let's say that they set up like a rogue DNS server that intercept the DNS conversations. Well, then, yeah, they can redirect you because you're going through them to go where you're going. They can also poison the host file. This is the stuff I used to do in high school and have like fun with it. No, in college, not high school. It's DNS client cache poisoning. So a host file is a location where your computer looks into first before going to DNS. All right. These are Windows machines. Let me show you how a host file looks like. It's on a Windows computers. Right. It's a little bigger. There we go. So the thing that you're looking at right now, this is what we call host files. Literally. Every Windows machine have one of these. So your computer, guys, every time you go to google.com, it looked right here first. You're like, hey, can you resolve who google.com is? What is the IP address associated with google.com? Because I don't know this domain name. So if you can go here, change this, like literally say google.com can now be found on this domain or on this IP address. This is that redirect that I'm talking about. Somebody's going to go to Google, they're going to go to the browser and type in google.com, and then it's just going to redirect them to that IP address, whatever that IP address is going to take them. In college, used to do that for the fun of it. And it was fun. Anyway, so basically you are poisoning the host file, trying to redirect people to different, locations. They can poison the server as well. They can corrupt the cached, the cached information of the server. Again, trying to lie, that's what that means, spoof the responses as well. They can do that to try to impersonating the DNS servers, all that good stuff. So what do you need to remember for the exam about this? Just know that DNS poisoning, it's bad because once they have access to your DNS, they can redirect stuff, right? So what can you do about this? Well, there are some security things you could do. One is making sure nobody ever gets access to your DNS, like literally. No access to the DNS. Protect it, hide it behind a firewall if you are operating this, if you're operating your own DNS server, by the way. Second, have some fault tolerance, meaning have some backup for the DNS. Authenticated every request. So the thing about 53, which is DNS, it's not secure. There are ways where you can secure this. One being this guy right here, DNSSEC. We'll talk about this in a minute. But you could, for example, asking people who are going to be accessing the DNS to authenticate. Who are you? Who you are? What's your username? What's your password? Access control, controlling who have access to that DNS. Patch management, keeping your DNS server up to date. And to prevent footprinting. Footprinting is when they're doing a recon, or they're asking, in this case DNS, they're asking, hey, Mr. DNS, tell us about yourself, who you are, what service you are, what versions you're running. That's footprinting. So we can prevent that. We can tell them, hey, no, we're not giving out that information. DNS security is great, They came out with this. Companies are not really using it. But this was a way of using cryptography to secure DNS. It was a way of using cryptography to secure DNS. So it's called DNS Security Extension. That's what it stands for. There are different flags, RR set, for example. You can have different zones and signing keys and root of trust. Again, cryptography. They were trying to use the asymmetrical encryption to be able to secure DNS. And on that exam, if they ask you which one of the following would you use to secure DNS, this is one of them. In the real world, this is not implemented. What they've been implementing, it's not here because CompTIA is always behind. It's known as a DOH. All right, DOH. DNS over HTTPS. And this, by the way, DOH was introduced with the TLS version 1.3. That just came out a few years ago. That's when they introduced this. So what they did, they're like, okay, look, DNS runs the internet. So we're going to be running DNS over HTTPS. All right? And then get that security of TLS, of the transport layer security. So this is what Firefox implemented, DOH. Right? When they upgrade to version 1.3 of TLS, it brought them with this DOH, which is super secure, very, very secure. So this is how we secure DNS in the real world. Let me share this with you just in case you want to read up on it. Again, you can use the DHCP security, and that will be just fine. All right, DNS 53. Another one, it's directory services. So I told you LDAP is used to communicate with your directory, like something like Active Directory. So LDAP has different binding methods. You can use LDAP with none, meaning they're not asking for any sort of authentication. We can use LDAP with simple authentication, where you set up like username and password before you can accessing the directory, the Active Directory. You can use LDAP with the SES-L, simple authentication security. It's not that secure, but it's better than the simple authentication. You can use LDAP with this, with the TLS, which is what most companies do. And that changes the protocol to LDAP-S, and that operates on ports 636. I would not worry about the protocol of LDAP. I don't think they're going to ask you that one. And then as you're using this, as you're trying to use these different binding methods, you can do that in read only or read and write, really. It's just, are you trying to read in the directory only, or are you trying to read and add stuff to the directory, to the Active Directory? LDAP is the protocol. Remember, every time I said a protocol, guys, I want you to think about a protocol as a language. All this DNS, DHCP, these are all different languages. Right? Computers speaks over 65,000 languages, like I showed you, for just TCP, and there's another like 65,000 languages for UDP. So computers speaks languages, right? Remember LDAP for directory services. Then time. So NTP, what if you wanted to synchronize time? We just finished talking about CIEM and how synchronizing your time is very important, because if all these devices are logging what they see, you want to make sure the time is syncing through all the devices. So NTP network time protocol is great. It uses these global servers that basically keep your devices and everything time in sync, right? So NTP, network time protocol, used for times, servers. Very good for backing up things, for scheduling things, for logging things, and for knowing when people are authenticating, what time they authenticated, and so on and so forth. Another one we have is a simple network management protocol. Well, people are working from different locations now. What if you want to sort of like manage your network stuff? You could use this one. This right here, simple network management protocol. That's the keyword, network management. This one is used to manage devices on your network. Okay. So, and this is 161. Should mention that, port 161. And there's a couple ways of using this one. So you can have an agent that runs on the devices, meaning your routers, your firewalls are going to be reporting to an SNMP server, reporting and be like, hey, look, this is what is happening with me, just in case you want to manage me in some way. Or we could have agents notify the SNMP monitor, right? Basically, the agents notify the monitor, and those are known as traps. Well, they basically send out the events and kind of keep updating the SNMP and be like, okay, this is how things are, this is how things are. So why is this important? Why is this critical? So imagine if you are in a data center, right? If you work in a data center, now a lot of companies are in the cloud, so this is gonna become useless. But imagine if you were in a data center. Usually in a data center, guys, it's very noisy. So a lot of things are making a lot of noises. You don't want to sit there configuring stuff. Right? So you want to be somewhere else with your little laptop and connecting to the switch within the data center and manage it that way. That's where this will come in, SNMP. And then there's different versions of this. SNMP version 1, useless. Version 2, useless. Version 3 is the only one that includes encryption and authentication. On that exam, they're going to ask you which one of the following is sort of like weakest version of what. This one is easy. Just know if you're going to be using SNMP, use version 3. Is the one that provides security, the one that provides encryption. Specifically this one, they might ask you that question that's related to that. I think there's probably a question on this practicing question that's going to ask about this one as well. Ask you which one is the weaker version of what. And this is going to be one of the answer. Okay. Any questions for me?
So it would be 1 and 2. The most secure would be 3.
Yes. So 3 is actually the only secure. 1, it didn't have any authentication. There was no encryption. 2, there were some improvements in the features, but there was still no encryption. And then 3 introduced encryption, meaning as you are receiving these traps, as you're receiving these events from SNMP agents, it's encrypted. They're sending you that in encryption, encrypted way, to you. Before V3, anybody could have sniffed the traffic. They could have captured the traffic and be able to see what's going on. But with V3, it changes all that because the traffic now was encrypted. All right. Any other questions? Let's keep going. B, implementing secure application protocols. Let's take a look at some more of these. 2.1 and 3.1 from that exam objective. All right, another one, HTTP. Everybody knows what this is. This is the protocol that runs the web. Stands for Hypertext Transport Protocol, right? And it's for your web services. This is port what? Port 80, talk to me, you guys. I know it's late. It's port 80, right? And it's not secure. You can capture the stuff that is within a header and be able to see what's going on. And it's just not secure, right? It's the stateless, it's not secure. But then we want to be able to secure HTTP or any one of those other protocol for that matter, right? We want to be able to secure DNS, we want to be able to secure DHCP and the LDAP and all the other protocols. So the protocol, I've told you this one already, the protocol that we use to secure the protocol is known as a TLS, Transport Layer Security. This is the protocol that we use to secure the protocol, right? Then you will see these written as SSL/TLS. I told you last night it's because they got TLS from SSL, right? You still remember that? Yeah. So on that exam, if they ask you which one is the more secure, go with this one. Right? TLS all day long. The beauty of TLS, it uses a different cipher, different modes, and different of cryptographic stuff. Key exchange, you got authentication. There is the Diffie-Hellman. There's RSA, there's AES, there's GSM and SHA-256, and yeah. So guys, look, TLS, it's the security of everything. Is the thing we use to secure other things. The protocol we use to secure other protocols. All right, API. I told you the only thing you got to remember about API is that we use this to help other applications talk to other applications. That's what API does. It stands for Application Programming Interface. Makes web application or service acceptable to automation by scripting. Yeah. Basically, you allow this one application to talk to this other application when technically they were not supposed to be talking. Like they don't have anything in common. Imagine if you're getting Google application to talk to Microsoft application. Right? Google and Microsoft, they're a competition. It's not like they developed their tool thinking, oh, we're going to make sure this works with the Microsoft tools. No. Right? But if you want to integrate the two, get them to talk to each other, you will use their API, Application Programming Interface. Shayla knows about this. You are in software, right, Shayla?
Yes.
All right. So do you do a lot of API or?
We did. We would use APIs. So I talked to government services, and we put those in place.
Okay.
Using Java, of course.
Using Java. Okay. Good. All right. So those keys, API keys, well, they're different. There are some for authentication, authorization, and everything in between. Actually, the SAML and the OAuth, the stuff we talked about, use a lot of APIs, tons of APIs. So that Connect ID, whenever you see people, websites that says log in with Facebook, right? Click here to log in with Facebook. That's all API. They literally took a Facebook API, they integrated with their website, and then voila. Now everything is working. One thing I need to tell you about API when it comes to security is that you just got to keep this secure, like hide it. A lot of companies have gotten hacked because their API have been exposed. That's the issue with this. All right, FTP. I don't know why that API was there, but FTP is the File Transfer Protocol. This is another one you have to remember. It's on port 21. FTP is on port 21. Usually they say 20 and 21, but just remember 21. Okay. FTP is weird because I know I told you that we usually secure other unsecure protocol using TLS. And it's this case. But with FTP though, FTP is weird. 20 and 21, they're not secure. But we can secure FTP using SSH. Yeah, I'm sorry. Yeah. So we can secure FTP using SSH. And that's going to change FTP to work on port 22 because SSH is port 22. Right? And then it becomes a secure FTP. So the S is at the beginning. Here is the tricky part. The S is at the beginning. The secure is at the beginning. But when you're running FTP over TLS, the S is at the end. Right? So there's file transfer protocol secure. And then there is a secure file transfer protocol. Yeah. All right, cool. And the port number that it changes to, the 999, don't worry about that. I would just remember FTP 21. Yeah, I'll probably just remember FTP 21. Email. Email services. Email uses SMTP, Simple Mail Transfer Protocol. This guy works on 25. Port number is 25. And I think you got to remember SMTP route mail between servers. I actually finally like one of their description because it literally does this. So SMTP helps two email servers talk to each other. That's how the emails are going from one email server to another email server. Imagine if you use Gmail, you want to send me an email and I use Outlook. So your Gmail servers are going to use the 25 to get to my Outlook servers. And I say 2025, I'm talking about Simple Mail Transfer Protocol. So Simple Mail Transfer Protocol is not secure. There is a way of securing this using TLS, but that's beyond what we're talking about right now. But just remember, 25 is not secure. And that you could also do like start TLS. This is like a command you can run, which is really, people don't do this. It's not as secure, right? Using this command to try to secure this. There are better ways of doing this. All right, so this is for two servers communicating. What about your client? What about you getting the email into your Gmail, into your Outlook? Right? Then you will use these right here. There's POP3, which is 110. Port number is 110. Port number is 110. There's IMAP, which is 143. Right? And we use both of these these are mailbox access protocol, meaning once the email have been delivered by this guy, then we can access it using one of these. Okay, both of these are not secure. 110, 143, they're not secure. So we have to secure both of them. So there is the POP3 security, again, using what? TLS. Runs on 995, and there is IMAP secure, which runs on 993. Okay, your question might be, okay, then what is the difference between POP and IMAP? Because I want to make sure you understand the difference. Some students don't understand the difference, and that exam tends to just, it might trick you on this one. So here they said better mailbox management features than POP3. One of the biggest reasons why IMAP is better than POP3 is whenever you are viewing the email, remember this is mail access, whenever you're viewing the email into your Gmail, POP3 is gonna sort of like download Like you remove it from the server, then you bring it that to your mailbox, like bring it that to your client, to the client machine. That's what POP3 will do. And you might be, okay, what is the issue with that? Well, the issue with that is if you're viewing the email from your computer, you cannot view the same email from, using your phone, because the email is not in the server anymore. It's in the computer. It's in the client program that is within your computer. So that's the problem with the POP3. It's going to remove the email from the server to the client. IMAP will just make a copy. It's not going to remove the email. It's just going to make a copy. So for the most part, POP3 is disabled. If I go to my email right now, and let me go to the settings of Gmail quickly here. Let me show you this. Where is the settings? I gotta go to the Gmail first. Oh boy. What are the settings? It's little. Come on. View settings. And if we go to the forwarding POP and IMAP, right, you can see that POP is disabled. It's a little bit bigger for you. Here they say POP is disabled. And then, oh, well, my IMAP is disabled too. Why? Gotta turn this sucker on. There we go. And then IMAP has to be enabled, because what happens is if POP is enabled, it's gonna, like I said, it's gonna download the email from the server to this thing that you're sitting in front of, this Gmail in this case. And if I were to want to review the same email from my phone, it's not gonna work. Okay. That's the difference. If you see that on that exam, that's the difference. Cool. All right, get going. All right, so what if you want secure end-to-end of your email? End-to-end meaning from me sending to you receiving. What if you want everything to be secure? Then you might want to use S-MIME. Literally, that's what this thing stands, S/MIME. So secure multi-purpose internet mail extension is an end-to-end encryption for emails. So this is the one that literally we go in and we do that PKI stuff where we can have people do digital signature. We can digitally sign the email, so you will know it's us. You will know it's me sending you that email. So every company that really want the security of the email, they have to implement S-MIME. It provides end-to-end encryption of the entire email. Okay. Voice and video protocols. All right, so we got VoIP. This is a voice over IP. This is literally, they're running video traffic using IP. That's really what this means. So traditionally, guys, you couldn't call people using the internet, but now that's very common, right? If you use WhatsApp, Facebook, calling, all that stuff, that's all VoIP. Zoom, it's video conferencing, the Zoom thing we're using right now. So this is all great. We talked about quality of service, that you should prioritize voice over IP traffic. It's all based on the session and the data that's being transported, and sort of like the traffic has to be in real time with this. So the protocol we use is SIP, Session Initiation Protocol. And there is the secure version of this known as Secure Real-Time Transport Protocol. So both of these are specifically designed for voice and video. And SRTP is like it's better. A lot of companies uses this because of the native security that's built in with Secure Real-Time Transport Protocol. Okay. And the SIP is not secure by default. If you want to secure SIP, you want to use a TLS with SIP, and that's going to change the port number to that. You don't want to remember that this. just if you see SIP, just remember they're talking about voice traffic, voice and video traffic. All right. Any questions before I finalize this and we'll go to another break? Nope. All right. C, implement secure remote access. Let's talk about VPN stuff. So 3133, let's get busy. So remote access. People are now working from home, right? Usually they're working from home. They're working from coffee shops and public areas. So remote access have become more important now. VPN have become very important. Well, guys, if you work from a different location other than your workplace, like you're at the work, you should be using VPN. So what is this VPN stuff? So VPN allows you to create a tunnel and you using the internet, you can tunnel through the tunnel you created and communicate with whoever you're communicating with securely. But for that to happen though, the company must have what we normally call a VPN concentrator. VPN concentrator is a device that allows the VPN traffic to come in. VPN concentrator. And then you yourself must have some VPN applications as well. We will talk about those. So that's VPN. It allows you to create a secure connection from an unsecure internet. Like the internet is not secure. Everybody's doing whatever they do online. You don't want them to see your traffic. Use VPN. You can use VPN over TLS. This is not the most common. I told you the most common over VPN is IPsec. But you can use VPN over TLS. And it's still secure because remember, TLS is secure. You're still using PKIs, stuff and, the certifications and all that good stuff. So you can operate it from TCP, UDP. This is our layer 4 stuff. OpenVPN is free. It's you can download this and start using it online. You can use this secure socket tunneling protocol for point-to-point VPN, meaning if you want to configure two things just to talk to each other without, going through the through the internet, you can use this protocol to do that. I haven't never configured this, like the STP. The way we do a VPN, or the right way of doing VPN, is we configure VPN through IP security, IPsec. This guy right here. And on that exam, just remember this guy. So, and IPsec is very, very secure. In fact, we talked about IP version 6, right? They literally built IPsec in IPv6. That's how good IPsec is. They built that into IPv6 now. Anyway, so network layer security, application independence, provides confidentiality, integrity, endpoint must be configured with IP security policies, at least one matching methods. Yeah. Look, if you're going to be doing a VPN stuff, you must also have an application that accepts VPN. You must also have this thing configured the right way. And the right way, which is AH-ESP. Remember these two for your exam. AH, which I believe was on that first question, this is the authentication header. It's going to sign the packet, but it's not going to encrypt anything. So this is used to sign the datagram, for example. The datagram or the packet, you say the packet. We say the datagram because this happens on layer 4. And the packet is a layer 3 thing, but it's the same thing. Okay, just authentication and integrity. It doesn't do encryption. So you configure IPsec with AH, that means you're trying to get some sort of authentication. You configure IPsec with the ESP, that means you're getting confidentiality. And then you're still getting, the authentication and integrity as well, but you're getting the confidentiality. You might be, okay, what is the issue with this? Well, the issue with this is because you're encrypting everything, so you don't have any visibility. You're not just encrypting portion of this, you're encrypting the whole thing. So there's no visibility. Even the hackers, if they're using ESP, you won't be able to see their traffic. Okay. So for that exam, remember the difference: ESP, encryption, AH, authentication, and integrity. Okay. All right, so IPsec transport and tunnel mode, right? So it's a transport mode. It's a host-to-host connections on the private network. This is literally like creating a VPN within your own environment. Why would you do that? I have no idea. Or it could be like a tunnel mode, right? Tunnel mode is what we are talking about, where you're sitting at the airport, but you want to connect it to your work network. You're going to create a tunnel mode. You will create a tunnel, right? Which is going to go across an unsecure network. It's the tunnel mode. Within the tunnel, then you can route your traffic through the tunnel. And then if you're using ESP, then your conversation is going to be secure. iKey, Internet Key Exchange. So as you're creating the tunnel, you can create that into different sort of like phases. There's iKey phase 1. There's iKey phase 2. So iKey phase 1 provides authentication, because this is like, it's going to ask you for like the pre-shared key. Sort of, it's like creating a VPN using your password, right? That's what phase 1 is. You're trying to connect it to this VPN, they're going to ask you, what is your password? You put that in there, you connect. iKey phase 2 is when we're using the cryptography, where we are allowing a ESP or AH to actually do what they do. Okay. I would not worry about this. I would just worry about knowing AH and knowing ESP. Those two. Okay. All right, you can also create a VPN into using what we normally call the layer 2 tunneling protocol, or iKey version 2. This is sort of like next version, if you will. Not the layer 2, this guy right here. iKey version 2, or IKEv2, makes IP security a standalone remote access VPN. It supports EAP. This is the authentication protocol we talked about earlier. But it also reduces the number of setup messages. In other words, guys, look, you can set up this thing to work with the web, where you don't even need any special software. You can easily just point to the thing and then it starts working. So it's like pretty good. And then layer 2 tunneling protocol, this is where you're creating the point-to-point, the PPP, where between the layer 2 stuff. Like, let's say you set up like a switch and another switch, and then you want a VPN between them. This is the protocol you will use, L2TP. L2TP, layer 2 tunneling protocol. Once you do this, you can still authenticate via EAP, obviously, because again, you're connecting to the switch. Maybe the switch have 802.1x configured to it, which is going to kick in EAP, all that good stuff. But again, guys, like really, folks really don't use this. If you can be connecting to the switch, you have to be there physically. What we're talking about with the VPN, you want to remote in, right? You want to remote in, you're not there physically. So you have to configure your VPN client for all this stuff that I just said to work. So your computers come with the native VPN applications, or you can use it third-party applications. So VPN, I go to VPN settings quickly here in my computer. This is it. So you decide, okay, which the provider, for example, I'm using the built-in. Okay, what's going to be the name, the server's IP. This is the most important of them all. And the type, what are the VPN type? Am I using L2TP? Am I using IPsec, using pre-shared key? meaning password, or am I using certificate with this? Am I using the iKey version 2? Right? I pick one. If I need to put a username or a smart card or certificate, I pick which one, then I go from there. This is built into Microsoft now. I've had students in the past that ask me, which one do you use? And let me show you which one that I use, or which one that I recommend. I recommend NordVPN. These guys. Oh, come on. I gotta clear my cookies. So NordVPN, I'm gonna just share this with you. I recommended this. It's not free, but it's great. It's easy to set up. They have a mobile app, and you can connect it to as many devices as you want. I have a plan of going, sort of like to Africa, and this is what I'm going to use so that my connection can appear that it's coming from the US, the VPN. But also, they mentioned OpenVPN. This one is free. Let me see if this one will come. Yep, there we go. These guys, they have a free version. You can use this one as well. Or you can pay them a little bit of money and go from there. Now, don't use a VPN to commit a crime. It's not like you guys are going to be doing that anyway. But usually these VPN companies are going to tell you, we don't keep any logs, so we don't do this. No, law enforcement can easily get a court order and just go to them like, we need everything you have. Right. Anyway, so you want to configure your computer with either the native VPN client or the third party. And then, do it the right way. These three, I will remember them for the exam. These right here. So let's talk about them. There's the always on VPN. This is where you basically turn on a VPN. It's always on, it's always listening, it's just there. Then you can do this configuration that they call a split tunnel. I don't like this, but some companies use it. This is where they're gonna split the connection between two. Like some connection are gonna go through the tunnel and some connection are gonna go to the internet. So it's gonna sort of like, you're gonna use like two ways of this. Some conversation to the tunnel, some conversation to the free internet. Full tunnel is what you want. Full tunnel is when everything has to go through VPN. Right? Everything has to go through VPN. Cool. All right, remote desktop. All right, so they're GUI-based remote desktop software that you can use out there, but on Windows, Microsoft, we use RDP. If I go to my Windows and remote desktop connection, this is the RDP right here. So literally all you do, if I show options, I just need to point out which computer I want to remote into, who's the user, and then I can click on connect. They can ask me for the password, then I get in that way. It's literally that simple. RDP. What is the port number associated with RDP, guys? 33 what?
9?
89. 3389. So that might pop up on that exam. And then remote desktop now, like with the VPN iKey Phase 2, there have HTML5 clients, meaning you can literally access it from the browser. Like you don't need any special program anymore. You can just connect to VPN from the browser as well. All right, last but not least, out-of-band management. So people now are working from home, or what if you want to manage it from home? Yes, you can VPN into it, but well, how do we know the device you are using to VPN is secure? We might not trust the device you're using to VPN, right? That's where these jumped servers comes in. So jump server is a server we might configure on our network, leave it there, and then you will have to VPN into it to do any sort of a management, right? So we're gonna have what we normally call a secure workstation, secure admin workstation. Then you will use this through the out-of-band management, the console and however it's connected. It would jump into the server. Then you will use the jump server to be able to actually do the configuration. So literally they have, this is a really good diagram here. You're sitting literally right here. This is the workstation, the secure admin workstation. You VPN into the work environment, right? You get right here, literally you VPN into the jump server because they don't want you to come from right here all the way configuring these very critical servers. So what they do, you're gonna get right here and they're gonna be like, hold on a minute. You gonna do all the configuration, all the management from the jump server. So think of the jump server as the thing you're jumping into to be able to manage, super important stuff like super confidential, secure stuff. Right? They don't trust what if you're sitting at home, they don't trust what that thing is doing at home. We don't want that thing to communicate with these guys, even though it's via VPN. We don't want that to have a direct connection to that. I mentioned SSH before. This is port 22. Remember that for exam. It's another thing we can use to remote into stuff, but this is for Linux machine. Right? You will be creating the cryptography still. You're going to do some authentication, which you can use your password if you wanted to. It depends on how you've set this up. Most of the people, they just use the keys, right? The cryptographic keys. If you use that, you got to manage it. You got to manage the keys, and there are different, sort of commands that you will use to set this up. Just remember SSH 22. If you're going to be managing a Linux computer from home, you want to SSH into it because this is secure. An alternative version of this that is not secure is called Telnet. Who's you have heard about Telnet? There we go. Telnet is a port 23. On that exam, they may ask you, the user is trying to use Telnet. Which is the secure version of this SSH? Right? If on that exam they ask you, the user is using HTTP, which secure version of HTTP? HTTPS. Or the user is trying to do SNMP version 1. Which secure version of SNMP? SNMP version 3. Okay. And that's the end, I believe. Any questions for me? Let me check your understanding. We'll take a break, then we will do one last chapter, guys. I promise you that's just going to be the last one. Stay with me.
A security analyst receives the configuration of a current VPN profile and notices the authentication is only applied to the IP datagram portion of the packet. Which of the following should the analyst implement to authenticate the entire packet? ESP,
ESP.
ASP. Actually, it's AH. Yeah, so they confused you when they said the notices that the authentication is only applied to the IP datagram, right? Like, okay, it wasn't applied to the whole thing. So, like portion of the packet. Datagram and the packet is the same thing. We call this a datagram on a layer 4. And we call a packet on layer 3. It's like same traffic. Look, if you see authentication, it's always AH. If you see encryption, ESP. All right, next question.
An analyst is trying to identify insecure services that are running on the internal network. After performing a port scan, the analyst identifies that a server has some insecure services enabled on default ports. Which of the following best describe the services that are currently running and the secure alternatives for replacing them? I would have to go with the first one.
So first one.
The third one,
Number 3.
And that second one, I think.
Number 2. Choose 3. You guys are satisfied? This is good.
Yeah, I say 3.
Is it 3? Okay, all right. Boom. Good job on the first 2 here. But no, it cannot be this one, Michael. So this is the secure file transfer protocol. This is when it's using SSH. It's when we're encrypting FTP using SSH. It doesn't mean it's less secure, just using a different protocol. It's still super secure. And this is the file transfer security. We're using TLS for the security of this one. I don't know how you guys missed this one. I think I had just mentioned that one, right? Telnet is 23. That's the port number of Telnet. It's not secure. SSH is 22. It's super secure. Okay. Next question.
A network administrator would like to configure a site-to-site VPN utilizing IPsec. The administrator wants the tunnel to be established with data integrity, encryption, authentication, and anti-replay functions. Which of the following should the administrator use when configuring the VPN?
ESP.
ESP.
ESP. Good job. Next question.
A security engineer is reviewing log files after a third party discovered usernames and passwords for the organization's accounts. The engineer sees there was a change in the IP address for a vendor website 1 week earlier. This change lasted 8 hours. Which of the following attacks was most likely used? I'll say DNS poisoning.
Okay. Agreed, Sir Michael?
Yep.
Okay. Good job. They try to trick you, but you got it. There you go. And that's it. Here we go. Lesson 12, implementing host security solutions. Keyword here is host. This means this is the security you put in your computer, in the host. You see how we talked about host-based firewalls or host-based intrusion detection, host-based intrusion prevention system. That's all going to be part of this class as well. Hopefully it's going to be faster, but pop quiz.
Which of the following technical controls is best suited for the detection and prevention of buffer overflows on hosts?
It's not D, just in case anybody's picking D. Got network there.
Also HIDS.
Got host-based intrusion detection system.
I'm gonna go with EDR.
ER.
EDR. Yep. I think EDR is a good choice. Yep. This is the endpoint detection and response. Endpoint meaning your host detection and response. He's just gonna detect stuff. And this is not the next generation anyway, Nate. He's been around for a long time. So it doesn't have all the artificial intelligence, machine learning, all that, good stuff. And it cannot prevent anything. And DLP is data loss prevention. Help you not to lose data. Somebody just want to copy stuff into the USB. Well, DLP is going to stop them from doing that. Okay. Let's get busy. 1.2, 3.2, 5.3 from that exam objective. Now, so before we dive in and talk about this host security, let's take a step back a little bit and talk about this from the beginning, actually. Well, we talked about the TPM, Trusted Platform Module. Who can tell me what this thing is? When we talked about this, I don't know if it was last night or today, we were talking about the HSM, the hardware security module, I believe.
It's like a specification, hardware-based storage for encryption keys.
There we go. That's it. Right? Storage for encryption keys. But the thing about TPM, though, remember, is attached to your motherboard. That's what this is. The chip on your motherboard is attached to your motherboard. And if you're going to be protecting hardware, if you're going to be protecting that computer, well, you must have a TPM so you'll be able to hold on to the cryptographic keys. Okay. So just remember what I mentioned about TPM and you'll just be fine. So there is this whole thing known as a root of trust. Root of trust is basically trusting the whole process of booting up the computer. So if we have a TPM present, that means it's going to help us sort of like, help us as we're doing the whole booting up process. So it's called boot integrity, and it was introduced in UEFI, right? This is the Unified Extensible Firmware Interface. This is a better version. It's like a newer version of BIOS. Some of you might be familiar with the BIOS, BIOS. So with the BIOS didn't have any security at all. With the UEFI, they're like, okay, well, people could have changed some things, so let's integrate security into this. So they have a secure boot, which means it's going in, it's validating sort of like files, bootloader, the kernel. It's validating all these things before booting up the computer. Guys, what I'm talking about right now happens before your operating system logo shows up. Right? This is what happens underneath, underneath. Remember, UEFI and the BIOS, this is the firmware. This is the software that talks to the hardware. So when you push the power button on your machine, UEFI receives the signal. It's like, let's get all the hardware ready. All right, so measure boot. Use the TPM to measure the hashes of the boot files and again, it was Michael who told us that within the TPM, it's the storage for the keys and all that stuff. So what's going to happen, we're going to go to the TPM and just be sort of checking the hashes and checking the things that are within the TPM, making sure it matches with what's in the TPM before we boot up the computer. Attestation is what we do if we're trying to do this on a remote server. When I say remote server, I'm talking about maybe we don't have a way of doing a TPM. Maybe the computer doesn't have a TPM. So what we're going to do is attestation. We are going to have like a remote location that we can check the integrity with. I will not worry about that one for the exam. I will worry about the TPM. Remember TPM? Remember, secure boot is the process of making sure we're booting the computer securely. And then it works with the TPM as well. Yeah. All right. So what if you want to do driver encryption? Right? There was this guy, I will tell you this. There was this FBI agent who went to the coffee shop with his laptop. He forgot the laptop. Then the hackers or somebody who wanted to steal that, they stole the laptop and they hacked the FBI that way. So they were able to just get all the information. So the question was, why was the FBI laptop not encrypted? Why didn't have full disk encryption? Yeah. So driver encryption, it's when we're going in and we're encrypting the entire hard drive. It's like you're locking it up, right? One of the best, I probably should say the best program, but one of the programs we can use for that is called BitLocker. And this is free. It comes with your operating system. As long as you have like the professional version of your Windows, BitLocker. So this guy right here, this is on my computer right now. So what I can do, I can turn on this, I can turn on the BitLocker right there. And then voila, what's going to happen, it's going to generate the keys and all that good stuff and save the keys into the TPM. And then it's going to allow me to create a password so that every time I'm trying to access stuff on the hard drive, I have to, present my password. Okay. If your computer doesn't have a TPM, remember TPM is only available in the newer laptops. So if you have an older computer, you can use like a USB thumb drive to perform the same thing. To be able to do full disk encryption, meaning you're encrypting your entire hard drive. But you need a place to put the keys, the encryption keys. All right, self-encrypting drives, SED. These are hard drives that are encrypted by these are a hard drive that provides encryption automatically without you doing anything. And this functionality is given to them by the manufacturer. So each disk has a disk encryption key that is set at the factory, meaning literally these hard drives, they're expensive, by the way, right? They're expensive compared to regular hard drives. Because what happens is as you write data into this hard drive, it's going to encrypt that stuff automatically. So I bet the FBI and all these other agencies, they started using SEDs, right? Encrypting everything on the fly without requiring any special software, no BitLocker, nothing like that. This is the best way to protect laptops, hard drives against loss or data theft. SED, self-encrypting drives. Okay. All right, I did told you about the SolarWinds attack, how it was like a third party. They hacked SolarWinds to get to the government agencies. That's what they did. That's third-party risk management. I mean, that's third-party attack. And we can take care of that by doing what we normally call a third-party risk management. This right here is a supply chain, sort of like supply chain and vendor management. So basically, if you're going to be working with other companies, we have to do the end-to-end process of validating them, right? Remember, supply chain is the end of process of everything that is involved in manufacturing, distributing, and and the releasing of the products, the good, the services. It's like every company that is involved. So if you're going to be picking these vendors, we have to also do an end-to-end process of who are we working with? Do they take security serious? You know, sort of things. It's known as a vendor management. This is becoming huge, by the way, guys. This is becoming huge because the companies depends on other companies nowadays to do what they do. So supply chain management, it's becoming like a very critical issue for most organizations. That's why we require them to have the SOC 2 assessment, if you remember from chapter 1. So SOC 2 assessment, so we can see if they take security serious. Great. Nothing here is going to be on that exam as far as supply chain goes. End of life systems and lack of a vendor support. Well, everything have a life cycle, right? They get developed, they die, we throw them away. Well, end of life, product is no longer sold. End of service life, product is no longer supported. End of service. Lack of a vendor support, it's like sort of like a abandoned project or a software program. Right? So if something reaches its end of life, well, we need to upgrade to the newest version. They don't have any newest version. We probably need to be creative in terms of securing that thing. Remember what I told you about that guy that wanted to secure the web, the 2003 web server. He added a WAF, a web application firewall, in front of that thing, so he can protect all the web issues with our web server, with our 2003 server. Okay, so you got to be creative. Sometime companies might not be releasing security patches anymore. You got to be creative as far as your solution goes. What about the agreements? The ones you need to remember: Memorandum of Understanding, MOUs. This is the intent to work together. This is like a handshake. Me and Nate, we're going into business, we're shaking hands. It's like, Nate, you know what to do? Yep. You know what to do? Got it. Yep. Shaking hands. Memorandum of Understanding. It's not a legal document. Right? You can't really sort of like take somebody to court with this. It's just an understanding between two parties, between two businesses. And there's the business partnership agreement, establish a formal partner relationship. So this one, it's a little bit legal. No, probably not a little bit. This is like a little legal documents for two entities that are going into business together. I will probably remember this one for the exam, and then NDA, and then SLA. Just these three. NDA is the non-disclosure agreement. They hire you, you're a contractor, you should not be sharing anything that is confidential or private, right? Service level agreement, this is the speed. This is the metrics. This is when the ISP tells you, we're going to give you 50 megabytes per second. That's the service level agreement. If they go under 50 megabytes per second, you can potentially sue them or go to court, or you can do something. So establish metrics for service delivery and performance. It's used to negotiate within a new vendor or about the timelines. That's another thing. I'm going to complete this project within 1 week. It got to be within 1 week. You go over 1 week, yeah, we're going to have these different conversations. So I'll remember those three. Measurement system analysis. This is used as sort of like a matrix for management, right? We really don't do this within cyber. All right, any questions with that section? No? Okay, I'm gonna get going. 12B, implementing endpoint security. Now let's dive into interesting stuff. 3.2 on the exam objective. Host hardening. So host hardening, interesting. If you remember what hardening is, yeah, that's exactly what we're talking about. If you remember what it is. So literally, you are reducing the attack surface. You are locking things down into the host, into the computer. Okay. So you're looking at the interface, you're shedding maybe, connections that shouldn't be there in the first place. You're looking at the services, you're shutting down the services that shouldn't be open. You're looking at the port numbers, you're shutting them down, you're disabling things that shouldn't be working. Just remember, guys, when it comes to securing your machines, within Microsoft, there is too much open. You have to just shut things down, like shut them down, like close things down. And that's what hardening is. We're removing everything we don't need. We're starting from like a secure location, like a baseline, like a secure state. So baseline configuration and registry settings, this is exactly what we want to do. We want to configure like a baseline, like a starting point. We want to configure what's normal, right? My first job, I was working as a tech support. This is back in Mobile, Alabama. And we were going from a school to a school. Then we were upgrading their computers. That was the first time I learned about baselines. Eventually, so we had these images. I don't know if when I say images, if you know what that means, but images were like pre-configured, like computer operating systems that are very secure, that they've locked it down and they configure this thing, they remove everything they don't need. Then we have two images, one for the student machines and another one for the teacher's machines. And we were just going from a school to a school, installing, removing. It was sort of fun. I had a manager who was not a good manager, but as a first job, I'm glad he was like that. He was really, really hard, but I'm glad he was like that. All right, anyway, so baseline configurations. You're going in, you're looking at the operating system, you're locking them down, you're looking at the server, the client, the appliance. Like, again, you're going in, you're reconfiguring things. Maybe you're using a template, right? Maybe there's a template that they've configured you're starting from. Maybe you're going into the GPO group policies and configure things from there, like sort of like locking things down from, group policy. Malicious registry changes. Yeah. I mean, nothing should be messing around with the registry. The registry is like the heart of your operating system. If anything changes into the registry, you need to know, like who's making those changes. So again, the biggest, I don't anything, you need to remember the idea behind the baseline, right? But anything else here, yeah, right. So just remember what a baseline is. It's like a secure state that we can start from. And you guys picked that up from one of the questions earlier, so that's fine. Patch. A patch is a fix, just like some of you have said already. So patch management is literally the way you're managing your fixes. So usually companies are going to have a vulnerability management programs where they scan the environment, you give them the vulnerabilities. So the vulnerabilities could be for operating system, applications, firmware, like everything in between. You got to know how to manage these patches. You're not gonna mitigate all the vulnerabilities, but you need to start with the vulnerabilities that are critical to your organization. I think I've hammered that in your brain over and over again. You need to understand what's critical for my company. Then whenever you're doing this patch management, vulnerability management, updates, all that stuff, start with the things that matter to your company first. Okay.
Francois?
Yep.
I have seen for patch management, since my company automatically does this, they schedule and apply all the latest and updates. That is pretty much happening almost like every couple of months, sometimes even every month. And they even schedule it and they send emails out and let people know, hey, this is going to be happening. And all you have to do is pretty much update when you get that update. They also just update sometimes when your computer is either left on and you're away with the cat card out, obviously. But this falls along the lines of that, of this middle part, the update policies and schedule.
Absolutely. So let me be very honest. Majority of the issues we have in security, guys, if we just do the patch, those things will become, they will be solved. People don't apply patches, right? Especially organizations. And to your point, Michael, which I understand, right? You are lucky because it sounds like you guys have a really good patch management program. But for you to put like a really good patch management program, there's a lot of stuff you got to go through. First of all, you can just keep updating everything. You know, some updates will cause more problems than they fix, right? Some applications are not compatible with the new thing, right? Some of this is not talking to this other thing. So what we do in the real world, we will set up a virtualized environment that's gonna mimic the actual environment. Like I will set up like a server in AWS that looks like the actual server, and then I'll test the patch in that thing first. If it doesn't break anything, that's where those announcements will come in, Mike. We'll be like, hey guys, we're gonna be pushing these.
Now, you talk about a separate one. That's a sandbox, right?
Well, so if you are running those updates within the same environment, yeah, you want to make sure you have a sandbox that, right? It's like separate. Good point. You know, you want to make sure that test, basically I'm talking about like a test environment. That's like a place where you test these updates, these patches before you apply them to production. Okay. Yep, but good point. So what I would tell you once you start working in cyber, guys, for those who will be, and for those who are already in it, just push for patch management. Just push for do the patch management the right way. And that's gonna solve majority of your problem. All right, you don't need a penetration testing. You don't need I mean, you do need that stuff. You do need them to find the stuff that's 0 days, the hard stuff. You don't need them for this. All the issues, let me show you this. Michael, you ask a question now, you bring up my interest. All right, so there is this attack known as a CompTIA. It was like a ransomware attack that happened in 2017, right? CompTIA, not CompTIA, which was also like a cousin of WannaCry, if you ever heard about WannaCry. These things, literally, these things cost businesses over $10 billion. Actually, let me bring that up. Recover money. Let me see if I'll find it here at this somewhere. Well, I don't like the Bitcoin. I don't like that. I'm gonna share this with you. But literally, it cost the hospitals, because what the hacker did, they were going into, they're encrypting doctor's office. There we go. There is this right here, right here. They were encrypting doctor's office and all these other things. And they were asking them, hey, you got to pay us $300 before we can let you use this computer. And they did this for almost the entire UK. We didn't get a lot of this in the US, right? So, but it cost these companies over $10 billion. So when they start saying like cybersecurity is a real deal, it's like a real threat. These hospitals, I think even some people died because some doctors were performing surgery, they were in the middle of surgery, and now their computer's encrypted, and now they can't access this, they can't do that. So it literally cost them over $10 billion to recover, which is a lot of money to recover from all the stuff. So the point of view, Mike, is this. Microsoft had released a patch 6 months prior before this attack, so Microsoft had told everybody, patch your system. This is, this is big deal. But again, these are hospitals. Hospitals are like schools. They don't follow the latest trend, right? That's the place you're going to find a Windows 2008, Windows 2003 server still working. You're like, why? Anyway, so patches are important. Push those once you get hired, right? Endpoint protection. Well, these are the protection of your endpoint. Some things you could do. Antivirus programs. Everybody knows about these. Very common. I recommend a web root, right? If you guys want to know a best way to protect yourself from online, go with the web root. Last company I was working at before I worked for ISACA, which is Trenton Health Team, we were using web root. Literally I pushed for a web root. It was great. I liked it. No complaints. And they have some for the home. We were using one for the business. This thing is going to protect you as you're browsing the internet. It's going to protect your computer, and so on and so forth. So unless you have some other sort of like antivirus program, I recommend theirs. So that's one. The beauty of WebRoot is cloud-based. So the signature-based, it gets up to date automatically. You don't have to do anything else. So they push those signature-based automatically. But there are also including all the heuristic, the behavior-based. They're including that behavior-based, so they'll be able to detect those 0 days and all that good stuff. So good stuff there. Another protection for the endpoint. And remember, guys, if they say endpoint, they're talking about a host. Endpoint is a host, is a computer. It just literally is saying a computer or a host. So host-based intrusion detection, host-based intrusion prevention system, these are really good for FIM, fire integrity monitoring. We talked about this. You can set up your honey file, like a decoy, a trap, right? You want something to monitor that and be able to let you know. Great stuff there. EPP, Endpoint Protection Platform. They're trying to literally integrate all of this into one product, like this one thing that have a multiple function, but really EPP, it didn't take off. It really didn't take off. What did took off though is DLP. Excuse me, not DLP. It's EDR. EDRD took off. I will talk about this EDR in a minute. But EPP didn't take off. But this is just a software that's going to allow you to do antivirus, host-based, firewalls, all that stuff. Right? DLP, this is data loss prevention, technology that allows you not to lose anything. Right? So it can block people from copying and transferring confidential information into their emails, into their USBs. It can literally disable the USB on your laptop, on your computer. It's the beauty of DLP. And endpoint protection deployment, just like APP, it didn't take off, but security for endpoint. What you need to remember for that exam from here, maybe antivirus and the DLP, really. And I mean, we did obviously talk about intrusion detection and prevention system for the host. So you know what those are. What about next generation endpoint protection? Well, that's where EDR comes in. This is the endpoint. It's actually in the name. Endpoint detection and response. One of the best, probably shouldn't say one of the best, one of the free ones. And this company, Komodo, just made this one free. It used to be extremely expensive. We have OpenEDR, and I'll tell you what it is. OpenEDR, they made it free. So if you work for a small company, there are those mom and pop shops, and you guys don't have the budget, but you want to do the really good security for them, grab the EDR, this OpenEDR. It's free. Komodo is the company behind this. Komodo, they recently changed their name, which is like weird. But they're behind this. They give this out to the community for free. We thank them for this. Literally, I say thank you because that's where a lot of stuff going. We didn't have any solid technology to do that with. So why EDR? So it's endpoint, meaning it's protecting your host. Detection, meaning it's giving you visibility, right? It's gonna detect stuff in your endpoint. And then there's the response, meaning it might contain the issue, it might prevent the issue from happening. Basically, it's acting as the antivirus program, it's acting as the firewalls. But the beauty of EDR, it includes the UEBA. So the user entity behavior analytics, all that stuff is included. So all the newer stuff, machine learning, ML, and artificial intelligence, AI, all that is included within EDR. So why this took off. The other thing, it's hosted in the cloud. A lot of these are hosted in the cloud, so they know a lot of stuff. Next generation's firewalls integrations. You can use endpoint detection to filter, to alter network firewalls policies, block fireless threats and cover channels, and then prevent lateral movement. Yeah, like turn on your firewall. Like your firewall have to be turned on. And the firewall works well with EDR, but if you have your firewall turned on, some other product cannot work, like your IDS, host-based IDS and your antivirus program might not work. But to turn this on is going to prevent a lateral movement from moving one computer to another machine. It's going to prevent a lot of the attack automatically already. And Microsoft is doing a fantastic job, by the way. They invested billions into security. So the thing that Shayla said, the Defender, Microsoft Defender. Now they have Defender EDR. And they have Defender a lot of stuff. So now you can subscribe for, I think I'll have about like $7 a month, and they will protect like your computer with all kind of EDR like tech into their, Defender, which is cool. All right, antivirus response. So antivirus are going to respond based on the signature. Remember, signature based is okay, but it's not good because you got to keep up with the signature. You got to update that automatic, often. Behavior based, we might want that, right, within our EDR. Malware identification classifications. Again, whenever you see your computer is acting funny, there's probably a malware over there. If your antivirus telling you I've identified a malware, you probably need to believe that. So you can manually remediate stuff, right? Or you can use some kind of advanced malware tools that are specifically designed to remove a malware. And then you can configure your EDR to basically send your computer into a sandbox, basically isolate your computer or the malware, I should probably say. Drop the malware into sandbox where it won't be communicating with anybody else. It's just going to be there so you can analyze it, basically. Can analyze it. They have a distribution for this. We are almost done. Let's see. Yeah, that's the last section, and I'll let you go. So there is this distribution is known as malware analysis. Just like how we use Catalytics for penetration testing, you can use this for as the sandbox that we're talking about. So you can use the Rumnox to be able to analyze your malware. It's like a sandbox. The malware is not going to get out of the environment, and you'll be able to sort of understand how the malware behaves. Right. All right, cool stuff. Any questions with that section before we finish section C, topic C? All right, let's talk about embedded systems. Embedded. Whenever you see this word embedded, I want you to start thinking about the smart stuff, the Internet of Things, right? So basically, it's something that is embedded into another thing. It doesn't really necessarily always have to be IoT. It's something that is embedded into another thing. It's inside of another thing and it's there to accomplish a specific task, a specific goal, right? So we'll talk about each one of these and how they apply to your life. 2.6 from that exam objective, that's what we're talking about. All right, so embedded systems. So it's a computer system with a dedicated function. Literally, it's designed to do a specific thing, right? You have a static environment. A static environment is an environment that doesn't change often. Imagine like your power grid or your power company that give you power. If you live in New York, the New York City, the city transportation, it's an environment, once it's there, it's going to stay there for a very long time. So that kind of environment, like the New York transportation system, you might want to need embedded stuff inside of that environment. These embedded are inside to do a specific thing. For example, if these are the trains within the New York, transportation, they're there maybe to drive that thing. They're there to tell you get here, you stop. You get here, keep going. It's like there to automate stuff. So you find a lot of embedded systems into a lot of places, really, a lot of places. We'll talk about those places in a minute. Okay. But I want you to remember, whenever there's an embedded system, they're talking about something that have a single purpose, like it's just there to do a specific thing, dedicated function. Okay. So the issue with embedded systems, though, they don't have security. It's one of the issues. They don't have security. And for that reason, whenever there is some sort of like embedded of anything, you have to hide it or you have to disconnect it from the internet so you won't get attacked. It's like, imagine like your power grid. Why would we want the power grid to have power? I mean, to have access to the internet? There's no reason, but now they're connecting power grids to the internet, which is why we're having all these issues, people hacking into power grids. It's because these embedded stuff that are within the power grid are not secure. So stay there with me. Let's keep going with this, and it'll make sense all of it in a minute. All right, what are some of the embedded systems that are there? So one, it's a PLC. This is the programmable logic controller. The keyword here is programmable. But the issue with this, not rather the issue, the good thing about this PLC is programmed by the vendor, by the manufacturer. Okay. So imagine if this was a water company, the company that gives, water to people. And the embedded system within the water system could say, okay, the water is going to go up this high. Right? If it goes over that, you embedded the system, you will let me know. So the PLC could be programmed to just monitor the water until when it reaches there, you let me know. PLC. Then you have your COC. This is the system on the chip. These are your Raspberry Pi. For those who have heard about what Raspberry Pi is. It's just like a motherboard that can process, that can do a lot of stuff. Let me show you what a Raspberry Pi is. But some of you might turn out to be geeks and want one of those. Raspberry Pis used to be really, really cheap, but now with everything taking place, they're costing like $100. They used to be like 20. So this is the IOC, it's a system on the chip. And this thing that you're looking at, guys, I can't tell you how many computers have been hacked just by, using this guy. It's called a Raspberry Pi.
Yes, I'm extremely upset.
With the price or?
with the price, because when I bought them, they were like $20. And I need at least 3 right by now.
Yeah, definitely. So the beauty of this though, it has everything right here, right? Like the processor, the CPU, the hard drive. There's a place where you can put your SD card in, and it's great. It's great. So if you're gonna take security serious, this was one of those things you might wanna look at. And he has a Pi OS. That's the beauty. There's the Pi OS, the Raspberry Pi sort of operating system. Let me share the link first. So this is the system on the chip that we're talking about. This right here. Everything is within the same little hard drive. The same drive. Pi OS is the actual software. It's like the operating system that can run on this thing, right? And it's based on Ubuntu and all that good stuff. So it's pretty good. Rico, that thing is like small, like it's very tiny. I think it's very tiny. You can walk anywhere with that thing. So you can connect it. If you want to crack people's, Wi-Fi, you can install Kali Linux in that thing. Can you imagine? So that's a Raspberry Pi. You also have Arduino. Really, Raspberry Pi is the most common. Another embedded one that's very interesting is this guy right here, FPGA. FPGA are field programmable gate array. The issue with these, they are programmed by customers and users. So you buy them, you program them yourself. Now the issue with that is hackers can also program these. They get access to it, they can tell this little thing what to do. Okay, unlike the PLC are programmed by the manufacturer. So you cannot reprogram them. The field programming gate array, you can reprogram them. RTAS is a real-time operating system. So this is what you might find on a system on a chip. Okay. Again, specifically designed for real-time stuff, as of the embedded systems are designed to do a specific task. So RTAS. All right, so I'm talking about a lot of stuff, but here's the only 2 things you need to remember regarding this section: ICS and then a SCADA. Just those 2 things. This whole section, literally just those 2 things. So these so-called embedded stuff, you will find them into what we normally call the industrial control system. Your question is, okay, what the hell is industrial control system? This is this stuff that doesn't change. This is the static environment I was talking about. Energy, power, nuclear, facilities, transportation, you name it. That's what we normally call ICS. So there's a bunch of PLCs embedded into the ICS that are designed to do specific stuff. Bunch of ICS uses what we normally call the OT network. This is the operational technology network. We're not gonna go there. We just know that's what they use. There is a human machine interface. There's the data historian, basically, to see like what is happening. Okay. ICS, you understand, is that environment that doesn't change often, but you want to make sure you're managing that environment. You will use a SCADA. SCADA is the software, right? SCADA stands for supervisory control and data acquisition. These 2 you have to remember for your exam. It's going to run on those PCs, those human machine interfaces. It's going to show you, it's going to gather the data, it's going to show you how the ICS is running, right? How that power company is running. It's SCADA installed on machines to be able to help you monitor the ICS. And here we are. If you're wondering, okay, give me some example of ICS, like I've been mentioning, energy companies, right? Sort of industrial mining companies, manufacturing companies, logistics companies, facilities companies. Even your HVAC in your building, it's a sort of like ICS. Anything that doesn't change often, that stays there for years and years, is ICS. Okay. Internet of Things. This is the Internet of Crop. Probably need to stop saying that, especially when I'm recording. But yeah, this is the stuff that unless you know what you're doing, you don't want this on your environment, on your network. About one of the OK Google thing, because I try to do the IoT stuff on my place, and the kids start abusing that thing. Go, okay, Google, do this. Okay, Google, do that. Okay, Google, do this. So, and there's this feeling that somebody's listening, right? And I was reading this other thing that says, this guy sort of like killed his wife, and then he make her disappear. So, it was like everything, like he didn't do nothing. And then they were investigating him, and then he said, hey, I can't remember, lost, I don't know where my wife is. So come to find out, Siri, they had that little Siri, not Siri, Alexa from Amazon. They have one of those Alexa stuff. So when the wife and the husband started arguing in the house, that thing started recording automatically. They didn't know. So the guy did what he did. So all the FBI had to do was just get Alexa and like, okay, Alexa, tell me, okay, what do you remember? So they don't tell us that stuff, that whenever you start arguing, this thing's gonna start recording. So I don't like IoT, but if you're gonna be setting up IoT, know what you're doing, segment your home network, put it on a separate network, and make sure, because this is a machine-to-machine communicating, just a bunch of things talking to each other, your thermostat, talking to your HVAC, your doorbell, talking to your, camera, it's just machine-to-machine talking to each other. There we go, smartwatches, right? Yeah, they're trying to turn a lot of stuff into smart this, smart that, and some of them, I don't see the value, but again, I probably should be telling you that anyway. But that's where we're going. That's the future. There's really nothing to tell you from a security perspective regarding this. The only thing you need to know is, one, Internet of Things, it's not secure, right? They have a weak default. They have weak defaults. That's what you need to know from security. And it's extremely hard to patch these things. They don't have any interface you can connect it to and start patching them. That's like literally the only thing from security. Then you have your specialized systems. These are what you will find into maybe hospitals. Like hospitals are using a lot of IoT, literally, can you believe? Now in China, for example, they have smart cities. Not really like smart cities, but in China, they have a lot of artificial intelligence. See how you guys, we were talking about biometric? In China, you can buy stuff without a credit card. So you can walk into the store, grab the thing you want, look into the camera using your face. They're gonna charge your, bank by just looking at the camera. So that's where we're going. I don't know if that's gonna fly in the US, because like we were saying, there's a lot of concern regarding privacy, right? You're giving up your face, you're giving up all this privacy. What if somebody's impersonating you? All right, anyway, so smart automation, smart buildings, there's some issues with this as well. But again, they're just trying to make smart stuff, smart surveillances, smart meters, cameras, which they can be abused, all that good stuff. All this stuff, when we're talking about this, guys, look, this means you are gonna be hired for a long time. You get to security really, really good, you're not going anywhere. They're gonna need you, all right? Because I can give you a million reasons right now. Specialized system in IT. So you got multi-purpose printers. These are basically our printers that have IP addresses. So you can print from, different locations. You don't have to be directly connected to that printer. You have IP addresses. You have like a little storage. It can cache your information, which is not a good thing, right? Hackers can hack into the printer and then copy the cached printed files. That's not a good thing. We talked about a voice over IP. Shodan, it's a search engine for smart stuff. This website. So if you ever have a camera, like a smart camera, figure out which brand is it, which version of that camera is, and then just come right here and search for it. See if you'll see it, if you'll find it here. If you find it, that means that company needs to do some security as well. Because if that is in your bedroom, people can be watching you while you sleep, literally. Because these things doesn't have, majority of them don't have really security. So Shodan, it's this search engine for smart stuff, smart, Internet of Things stuff. Then I mentioned specialized systems for medical devices. These are used in hospitals, clinics. Again, there's really nothing to talk about here other than telling you that it's dangerous. Technology is everywhere. We all can agree with that. They're putting technology into hospitals. Therefore, these things got to be protected. So these devices that they're putting into hospitals, they got to be protected. In fact, look, PHI, medical PHI. HIPAA, if we lose Medicaid, HIPAA is coming. It's coming if we lose the PHI. So I just showed you that CompTIA, the ransom that literally even killed some people because it disrupted, doctors as they were doing what they do. So there's that there. All right, so security for embedded, like I said, segmentation. Can I emphasize this enough? If you have an ICS environment, industrial control system environment, why would you connect that to your corporate network? Like why? Make sure this thing is segmented, it's on its own network, and then keep an eye on the SCADA, keep an eye on, monitor how this thing is behaving. If you're using like a free internet, like internet, always use IPsec through VPN if you can. There's a firmware, make sure you keep that up to date. If there is the IoT, remember you cannot patch those. They don't have a way of you patching those, the Internet of Things. But if there is a way of patching it, just patching them. That's the only secure thing. All right, any questions for me? All right, let me check your understanding and we will finish up.
Which of the following would cause a Chief Information Security Officer or CISO to the most concern regarding newly installed internet accessible 4K surveillance cameras?
Number 2.
2.
Yeah, I'm gonna go with 2.
Good job. Got to patch that thing, right? Got to patch it. Next.
Which of the following should a data owner require all personnel to sign to legally protect intellectual property? AUP?
You say A.
The second one, AUP?
Okay. Got A, we got NDP, non-disclosure.
Yes, and
You say NDP, okay.
Yep.
Yep, definitely NDP, guys. This is the AUP is. I can remember what that stands for, but that's what the people sign on how they're gonna use our computer. We give it to them. It's like, look, we give you this computer. These are what's accepted to use with this computer. It's actually user something. And
Use
the
policy. Acceptable user policy.
Acceptable use policy. Thank you. Thank you. Now, NDP, on the other hand, is non-disclosure. So if we're talking about IP, intellectual property, yeah, we don't want you to disclose that. Okay. Next question.
Which of the following should be put in place when negotiating with a new vendor about the timeliness of the response to a significant outage or incident? SLA.
Service level agreement.
I'm going with SLA too.
That's a MTTR.
Or MTTR. Mean time to repair. So it's D, Shayla. It's SLA, right? Yeah, that's the other thing about cyber. I don't know if you've seen it. We love acronym, right? It's like you got to know what some of these stuff stands for.
An enterprise needs to keep cryptographic keys in a safe manner. Which of the following network appliances can achieve this goal?
All right, I'll help you out here. Let me mention what they stand for. This is the hardware security module. This is the CASB. It's I think it's the content access security broker, protecting the cloud. It's not this one, I'll tell you that. TPM, it's a trusted platform module, the chip on the motherboard. This is DLP, data loss prevention.
It would,
That's a TPM.
TPM.
I'll say DLP.
What about
TPM. All right. Well, if you guys pick that, it's because you don't remember A.
Oh,
Yep. So look, guys, they say a network appliance. TPM is a chip on the motherboard. They're the same. It's just this is the network appliance. This is the removable. TPM you cannot remove, is attached to the motherboard. So HSM is a hardware security module. If you're going to be protecting keys, you're going to be doing a cryptographic stuff on a network, you will use HSM. Fair enough. Next question.
which of the following technical controls is best suited for the detection and prevention of buffer overflows on hosts?
EDR.
I will say EDR.
EDR, first one. Good job. Good job, you guys. That's good.